initiating this session 6A in telecommunications engineering, room A. As I told you before, we have around 15 minutes for each presentation, but I will ask you to use around 12 minutes, so we have a few minutes for questions. Okay. So the first presentation is going to be held by Muhammad Ali from Turkey, and the title of the presentation is Improved Hybrid Precoder Design for Secure Millimetric Wave MIMO Communications. So Muhammad, when you want.
Thank you very much. Thanks for a nice introduction. This is my outline. Let's start with the current issues. Basically, with the passage of time from last few decades, the demands of mobile users are continuously increasing. Especially, it is foreseen that with the about 1 trillion of connected devices are realized in Internet of Things, for which a huge amount of data rate requirement along with a sufficient bandwidth utilization is required. However, in addition to that, high resolution video applications are also going increase day by day, for which the current spectrum cannot accommodate such huge amount of devices with proper data while providing a proper data rate requirement. So spectrum congestion in current communication system is strongly realized. Therefore, the researchers are continuously striving for the upper part of electromagnetic spectrum that starts from 30 gigahertz to 300 gigahertz, and which are having a very short wavelength in the range of millimeter wave. That's why these are known as millimeter waves. But the problem with millimeter wave has that they have certain degradation issues like rain fading, penetration loss. So the signal may be die out. So therefore, we can also adopt the multiple antenna technology because the shorter wavelength. However, again, the multiple antenna technology has severe problem related to cost and energy consumption, because for every single antenna, a single RF chain is required. And every single RF chain consists of an analog to digital converter, digital to analog converter, and mixer. So it may be very difficult, as well as the most important, it will be cost and energy consumption issues. For example, in this specific system, we are using 192 antennas at transmitter, receiver, and eavesdropper side. So it's mean that we required 192 multiplied by 3 RF chains. So this is very unrealistic. So for that reason, the solution is the hybrid beamforming technique. In hybrid beamforming technique, what we are doing, we are basically utilizing a combination of analog and digital precoding. In this way, we are reducing the number of RF chains. So hence we are reducing the cost and energy consumption. Since we also know that the wireless communication has broadcast nature, so that's why the information sent by any user is open, exposed to all the user. So the problem is we have to secure our transmission from the undesired users, generally known as eavesdropper. For this purpose, we need to establish a channel which can enhance the signal toward the desired users and degrade the signal and at the undesired users, known as eavesdroppers. So for that, specifically, we need to improve the signal to noise ratio towards the desired user and minimize the signal leakage toward the eavesdropper side by reducing the SNR signal towards them. But there is also very important thing that if the eavesdropper is equipped with exactly same number of antenna as deployed by the transmitter or the intended receiver, in this case, certain information leakage can be realized. So the main objective of this study is to design such a secure hybrid precoder which can protect the information leakage towards the eavesdropper. And the second objective is that we will compare our proposed model with the most recent algorithm in the literature. In this specific study, we achieved this by applying a famous zero forcing scheme toward the eavesdropper side, which basically suppress the channel, and hence the information leakage can be minimized. And to do so, we are using the physical layer security procedure for specifically targeting massive MIMO millimeter communication systems. So this is our system model. In our system model, we are using a very simple system model in which we have alias, the transmitter, the receiver, bob, and the eavesdropper. In this case, the transmitter to the receiver channel is known as HP, transmitter to eavesdropper channel is known as HE. In this model, all the three parties consist of the antennas NA, NB, and NE. Here in this model, we will use small a, small b, and small e for the alias, bob, and eavesdropper. In this model, as you can see that we have digital part and analog part consist of the phase shifters. So basically what we are doing, we are designing a precoder, we are designing a combiner, and a combiner for the bob, which is intended receiver, and combiner toward the eavesdropper side. However, we will try, it is certain condition. For example, the ns data streams, the expected value of data stream into its transpose will be always equal to this thing. However, it is very important that we should keep our number of RF chain lesser than the number of antennas at transmitter, receiver, and bob, and this should be greater than the number of data stream. We try to increase the number of data RF chain more than data stream, because for the multiple stream transmission, whereas as I said that number of RF chain should be minimum than number of antenna to avoid the cost and energy consumption issue. So let's start that the signal X is the output of the transmitter, which is alias. So when this signal is received at both sides through the channel HB, we get YB. When this YB signal is processed with the combiner at the receiver side, intended receiver side, we get SB equation. So where in SB equation we have HB is the channel to our transmitter to receiver, and in this equation the small a with the B and A subscript represent the array response vector at transmitter and the receiver side, whereas this phi and theta are the angle of departure and angle of arrival at the transmitter and receiver side. In similar fashion, for if we are getting SP with the difference that it is subscript with the E represent the eavesdropper. As I said that we are using zero forcing technique in this here. Before further analysis, we are applying zero forcing technique on AVE channel using this equation. So this is basically standard performance matrix of secrecy analysis. We are interested is this main equation. The first part, logarithmic part, is the secrecy rate of the bob, the intended receiver, and the second part is the secrecy rate of the eavesdropper. So basically we are interested in this overall secrecy rate, which is always subtracted from the bob to eavesdropper, where CB and CE represent the capacity of bob and ave. RNB, RNE are the covariance matrices of the bob and ave side. So what we need to do, we are interested to get these four terms subject to these conditions: F analog precoder, digital precoder, analog combiner, and digital combiner. In this equation, two things are very important: this P and this C. These are basically controlling the analog beamformer. Like we can achieve high resolution beamformer by selecting higher value of B. But at the same time, if we increase the number of bits, the circuit complexity is increased. So in this specific study, we are applying low resolution phase shifters and we will use b is equal to 2 value. So first of all, as we know that the channel model that we have selected in this study is sharing scatter model. So in this model, it is millimeter waves. So there will be a certain common angle of arrival and departure between the bob and tape. So what we will try to do, we will first develop a secure channel which is obtained by eliminating common angle of departure from the common angle of departure of bob and if from the bob. So hence we get the secure channel. On this, when after getting secure channel, our accuracy analysis can be interpreted as this in this equation, similar to the previous one, but we have changed from HB and HE into HS model. However, this is still a complicated hybrid precoder design, because in this model we are dividing our procedure into two steps. First, we are achieving analog precoder and combiner using the conventional method based on this secure channel. However, for the digital precoder and combiner, we are creating the effective channel, which is basically the combination of the obtained analog combiner and analog precoder from the convention method, and then applying SVD operation. From SVD operation, we are getting UR and VR unitary matrix. By exploiting these matrices, we are getting the digital precoder and digital combiner. So at if side, we are utilizing minimum mean square error filter as a eavesdropper combiner over the effective channel, which is HE into F. Now we are having all the parameters like FA, FD, omega A, omega D, and combiner at the if side. Now we will go to see our simulation parameter. In our simulation studies, we are assuming that our angle of arrival and angle of departure are uniformly distributed between 0 to 2 pi. The covariance matrix we selected is unity for our simplicity. For more comparison, the lower bound we are selecting is specially space precoding, whereas upper bound is generalized eigen decomposition based on full digital precoder with the physical layer security effort. In the following curve, you can see that we are analyzing our analysis in terms of spectral efficiency versus signal to noise ratio. Basically, this blue curve is just our accuracy rate. We are interested in this thing. The black curve representing the bob accuracy rate, the red one eavesdropper. But we are interested in our accuracy rate of the overall accuracy rate. So you can see that the circle one is representing the most recent algorithm, whereas this square one, the proposed one. You can clearly see that at low SNR value, our proposed model showing similar results. However, at high SNR value, our proposed model showing some better results. In next case, you can see that here we are selecting data stream 4 and number of RF chain is equal to 8. Again, you can see that at low SNR value, our proposed model is representing similar result. However, at high SNR value, our proposed method showing better results. The next final result is the accuracy rate of spectral efficiency versus data streams. As you can see that as number of data streams are increasing, the accuracy rate performance of proposed method is improving. At 1 to 4, the proposed method is slightly improved, but at above than 4 to 8, our slight better improvement can be seen. So the conclusion, in this specific study, we have utilized secure hybrid precoder design for targeting millimeter wave, utilizing massive MIMO systems, and use low resolution phase shifter. To improve from the recent algorithm, we utilize the zero forcing technique at each channel. The simulation studies validated that our proposed method improved the accuracy rate at high SNR value. However, the similar secrecy rate results are seen at low SNR values. Thank you very much. If you have any question.
Okay, thank you very much, Mr. Ali. You got almost in time. So, is there any questions from the audience? Anything from the internet, maybe from YouTube? Okay, nothing also. So I just have a small fast question. I got lost with when you were presenting almost all the distribution, all the evolution of the equations you have to use to find the matrix for the filter. But is this process? I have two fast questions. Is the process adaptive in a way that if the hardware or architecture of the MIMO system changes, is the system adaptive? Can it change in time, or it is fixed for a fixed technology?
Actually, currently we are using a passive eavesdropper. Like in future we can see the active eavesdropper as well. And number two, like in current scenario, you have seen that in our system model we used three basic parameters: transmitter, receiver, and eavesdropper. In future, the number of eavesdropper may be increased. It has the in future they may be active. They may make changes in the real transmission as well. So currently we start from the very simple model. So in this they are passive eavesdropper. They are not active passive eavesdropper.
Okay, thank you very much. I will say the other question if we have time at the end, just in case, and I will make the next question. So thank you very much, Mohammed. Thank you for your nice presentation. So we go for the next one, which is from Evelina Nikolova. Presentation. The title of the talk is multi-particle control at the network edge, presented by Evelina Nikolova Pencheva from Bulgaria. So Evelina, again, you have 13 minutes, and then we save a couple of minutes for questions. Okay, thank you very much.
Thank you. Hello, everybody. Dear colleagues, my name is Evelina Pencheva, and we are with Technical University of Sofia, Bulgaria. This presentation is on multi-particle control at the network edge. Here is the outline of the presentation. The introduction presents the problem, which is related to open access to multi-particle control using multi-access edge computing technology. Next, the deployment of open access to multi-particle control functions at the edge is discussed. The proposed functionality is illustrated by typical use cases, data model, and interface definition. The service feasibility is illustrated by modeling the multi-party call state as seen by network and application points of view. The assessment of application programming interface performance is done theoretically and by emulation. The conclusion summarizes the contribution. Fifth generation system has huge potential to improve our daily lives in various aspects, including numerous mission-critical and healthcare scenarios. Network programmability is a key feature of fifth-generation system, which, in combination with cloud-based services, can support many use cases, including mission-critical and healthcare communications. Existing research on multi-party call control is focused on third-generation partnership project, mission-critical push-to-talk service architecture and feasibility study. Provisioning of 3GPP mission-critical push-to-talk service relies on deployment of Internet Protocol Multimedia Subsystem, or IMS. In this paper, we study how the open access to multi-party call control can be provided by multi-access edge computing. The research novelty is in delegating the multi-party call control to mobile edge applications deployed in the vicinity of end users. The proposed open access to programmability of multi-party call control does not require deployment of IMS, and thus it reduces the cost and provides the necessary performance and reliability. Distributed core network functionality can be deployed by virtualization of core network functions and customized to specific requirements using the technique of network slicing. Mobile edge applications for mission-critical and machine-type communications, which are run as virtual machines, as well as the mobile edge platform, which provides mobile edge services, can share the same network function virtualization platform. We propose a new mobile edge service called Multi-Party Communication Control. The service provides open access to multi-party call control for mobile edge applications. Using the service interfaces, a mobile edge application may place a call that is multi-party with desired quality of service, make to join or to leave given participant, fetch information regarding the ongoing communications. The figure illustrates a typical message flow of mobile edge application initiated multi-party call with call participants management. As a part of service specification, we built the data model and provide interface definition. The multi-party session and session participants are all presented as RESTful resources. The resources are manipulated using HTTP methods post, get, update, and delete. To initiate a new multi-party multimedia session, a mobile edge application sends a post request to the multi-party session resource. It provides the session description, maximal number of session participants, maximal session duration, application and request identifiers. The information about existing multi-party session includes session start time, active time, the session order, and participant number. Adding a participant to existing multi-party session invokes creation of application function session with quality of service in the network. For each participant, the application provides media information. To summarize, the container resources support get method, which retrieves a list of all its child resources, and post method, which creates a new child resource. The leave resources, in addition to the get method, support also patch method, which updates the existing resource, and delete method, which deletes an existing resource. To assess the feasibility of the proposed interfaces, we model the visions of the network and mobile edge application on the state of a multi-party multimedia session. The network and mobile edge applications must have synchronized visions, and the multi-party multimedia session state models must expose equivalent behavior. The figure in left shows the simplified multi-party session state model as seen from the network point of view, and the figure in right shows the simplified multi-party session state model as seen from a mobile edge application. Both models are formally described, and it is proved that they expose equivalent behavior using the concept of weak bisimulation. One of the key performance indicators of mobile edge computing is latency, which should be defined on per service basis. The latency is evaluated for API requests for session creation and for API requests for participant managing. The time budget for local task execution can be calculated as a product of data size in bits and computational workload in CPU cycles per bit over the CPU frequency. The time required for message composition and processing for both the request and response are under 2 milliseconds. In addition to theoretically evaluated latency, an experiment for API functionality is conducted. The experiment includes pushing a batch of 100,000 operations, post requests for multi-party session creation, and the respective 200 OK responses. The configuration experiment setup includes a client running on a host equipped with Intel processor of 7th generation, running at 3.4 GHz with 8 cores and 8 GB of RAM. The server is running on Intel same generation at 2.6 GHz with 6 cores and 16 GB of RAM. The server is implemented using Vertex, which supports a REST-based interface toward the client and Redis configured to work in single node without clustering. The figure in left depicts a decimated portion of operations latencies where the initial part is clearly different with respect of the following, and the effect is based on the so-called warm phase. Should this effect have to be taken into consideration when a service level agreement is prepared, then it has to be described separately, but the rest of the results presented are about the part of so-called steady state. The figure in right depicts the steady state of latency as an ingredient of service level agreement, and the focus is set on the worst case part as a limiting factor for the latency budget of the service. About 99.5% of all requests have under millisecond latency, but part of the rest may hit even 30 milliseconds. This is specific for both cases of the experiment, with a single serving instance at the endpoint and with 4 instances. The figure in left depicts the half millisecond part of the latency population in steady state, as it constitutes over 95% of all recorded post-trials. By increasing the number of instances from 1 to 4, it becomes clear that while keeping almost the same shape of the probability density function of latency moves to lower values as whole. The figure in right depicts the Gaussian mixture model of the steady-state latency in the case of 4 serving instances. Here the aim of the modeling part has at least 3 purposes. First, to reduce the amount of data stored for simulation and development purposes. That is, it is much more practical to generate expected latency from a 5-component model rather than keeping in cache 100,000 samples. Second, to help in service level agreement formulation for the latency as a key performance indicator. Third, to help key performance indicator monitoring for eventual slow shift towards higher values of latency. The open access to multi-party call control at the network edge may be beneficial for mission-critical scenarios and Internet of Things healthcare use cases. It enables creation, modification, and termination of a multi-party multimedia session by applications adding and removing multi-party session participants dynamically, as well as management of media streams used. The proposed API for multi-party call control enables dedicated third-party applications to react promptly on situations requiring management of multi-party sessions with specific quality of service and saves the backhaul network resources. Thank you for your kind attention.
Okay. Thank you very much, Evelina. A very nice presentation. I think it was very appropriate for these times of pandemic to have this information about multi-party calls, which we are all very much used now all these days. So is there any question from the audience? Any questions so far? Okay, and is there anything from the internet, from YouTube channel? Any question? Okay. So just as we have 1 minute, I have just fast question for you, Evelina. More related to my ignorance from this topic. It is in some of the figures you showed us, you were depicting the latency versus I don't know which was the other variable, but it was, I don't know if it was related to the number of people included in the multi-party call. Do you include this topic in the analysis? I mean, how many people is in the multi-party call, or it is only assuming that all of them have more or less the same flux of information and all of them are using the same bandwidth?
Okay, thank you for the question. We just simulate the latency of the request and response for adding a participant. No matter how many participants are involved in the session. We just evaluate the latency because it is one of the basic KPI of mobile edge computing technology.
I see. Okay. Okay, thank you very much. So if there is no more questions, okay, then we will go for the next presentation. Thank you, Evelina. So next one is Evaldas Stankevičius from Lithuania. Yes, hello, how are you? The audio, please.
Good morning. Thank you for the floor.
Good morning, Evaldas. So you can share now your screen.
Thank you.
This presentation is going to be, title is Telecommunication System and Aeronautical Telemetry System in the 1429, 1518 megahertz frequency band. And as I told before, you have around 12 minutes for the presentation and a couple of minutes for the questions. Okay, so thank you very much, Evaldas. When you want, you can start.
Okay, thank you very much for the presentation. So as the chairman presented, I will share our results, our study regarding the cross-border coordination between two systems. And it is the International Mobile Telecommunication System. So simply talking is the mobile networks, and the Aeronautical Telemetry System in the 4029, 1518 megahertz frequency band. So we, together with my colleagues, Šarūnas Obarauskas from Communication Regulatory Authority, Vidas Kalesinskas from Vilnius University, and Mindaugas Žilinskas from Vilnius University and Communication Regulatory Authority, and me as a co-author and the presenter, a member of the Vilnius Gediminas Technical University. So the first of all, introduction, why such studies are needed, why such studies are important, and what's the main key points to present here. So first of all, we made a study in co-channel compatibility between two mentioned systems in the 1.5 gigahertz frequency band. It is important because this frequency band is quite qualified regarding the radio propagation conditions for the 4th generation, 5th generation mobile networks. That's why in this frequency bands we have also working other systems as aeronautical networks, radio relay networks, broadcasting networks, and other let's say, possible systems. But all frequency bands are allocated and used by some systems. And if we would like to change the allocation, for example, for mobile networks, we need to perform the electromagnetic compatibility studies in order to prove that this frequency band is feasible for the mobile networks, and it's possible to have such a systems in a particular frequency band. So the main key novelty we found and evaluated during our work. So first of all, it is more practical rather than academical, because we currently we have, let's say, the protection criteria and coordination distances from telemetry systems. It means that those systems, those radio receivers in particular countries are saved by particular protection criteria. But we see that possibly those criteria are overprotecting the systems. It means that we do not use the frequency in most effective way possible. So we investigated the new possible approaches in this area, how to perform the electromagnetic compatibility in order to share the frequencies as much as possible. So we proposed two possible protection criteria to use. It is I over N, interference over noise, and plus C over I plus N. Is the carrier frequencies, carrier signal strength over the interference plus noise. So those criteria are more precise, more appropriate, because, for example, if you have at least the sensitivity of telemetry system, the ATS system, you can use at least I over N criteria. And if you have the, let's say, the permitted, the acceptable minimum levels of receivable signal strength of ATS receiver, you can use the C over I plus N. And each case is different. So if the neighboring countries have different approaches, means that if one country would like to use the mobile networks and the other country would like to develop the telemetry systems or other systems, you need to case by case calculate the electromagnetic compatibility. And in the current situation, that is, let's say, this the calculations and the interference criteria might be overprotective, so it should be well adjusted or improved. And this, for example, these two possible new approaches could be used in general manner between all the neighbor countries, at least in Europe or worldwide. So with the use of more precise interference criteria, we could achieve much better frequency sharing between the countries and inside a country, not to overprotect, let's say, every radio system, not only, let's say, mobile networks or the ATS systems. So this frequency band, as I mentioned, it is important not because we just found some frequency band where something is changing, but this frequency band is important also for the 5th generation mobile networks as an additional frequency band. So that's why the mobile operators in Europe and worldwide will deploy the 5G networks and currently deploying the 5G networks in the countries. And when you present the new technology, you need to have the new frequency bands. So 1.5 frequency, 1.5 gigahertz frequency band could be like an additional part of spectrum for every mobile operator to ensure the requirements from their clients and communication authorities. So electromagnetic compatibility simply can be done or performed in two ways. It is sharing studies when the systems use the same frequency band. So it means that we have limited frequency band and systems would like to share it. And compatibility studies, it means when the systems operate in different frequency bands. So in our study, we were more focused on core channel because the frequency band is quite narrow. So one country can use it for mobile networks, another country can use for the ATS broadcasting and other fixed systems. So how to share the frequency on the, let's say, between the countries on the border when the, let's say, the between the transmitter and receiver in both countries are very close distance. So evaluating the probability of interference, as I presented the interference criteria we used. So we created the hypothetical networks of 1.5 gigahertz and hypothetical networks of ATS systems, telemetry systems. So it is the telemetry system. So it has the transmitter and some receiver at the ground and the plane flying around the receiver and performing the activities and sending and receiving the signals. So in those two hypothetical networks, we also always calculate the so-called DRSSS. It means the desired received signal strength. This in general, it is like a C carrier, the received signal, the wanted signal, and the other plane, the IRSS, the interference received signal strength. This is the interference from the interfering system from the neighboring country. And in each case, regarding the density of mobile networks, regarding the format, the configuration of ATS systems, you will have different calculation, different results. And regarding the interference criteria, if, for example, it is possibly overprotective, so it means that one country which would like to deploy the mobile networks would need to have a large separation distances to ensure the protection of ATS system. But we raised the question, maybe it is not needed, maybe it is overprotected. So we calculated the situation with the hypothetical networks. So we created a hypothetical networks, first of all in Lithuania, and then additional calculations were made also in Poland. And we modeled the situation when the ATS system is working in a Kaliningrad area. So it's very narrow territory, just a couple of tens of kilometers. So the possible interference from mobile networks from neighboring country could be investigated and could have influence to ATS receivers. So that's why we use such a close situation. So the parameters we use, we try to find as much let's say precise parameters that would be the systems that is working in reality. So to model the system with the practical real parameters. So the parameters of the ATS transmitter on board, it means on the plane, which are flying in some area, at a height of 2,000 meters and 10,000 meters. And somewhere there is an ATS receiver with the particular thermal noise, sensitivity levels to calculate the possible interference. And international mobile systems, or the so-called simply the mobile networks, we also created like three base stations, cluster of base stations with the default parameters, the default emission powers, and calculated the interference level at the ATS receiver point. So if two ways of calculation were done. So first of all, when you only know the ATS receiver's sensitivity, it is the minus 35 98, and then you can calculate more precisely if you know the signal, minimum signal strength that it is needed for the ATS receiver from the ATS transmitter. So you can use the C over I plus N and calculate how much, let's say, power budget do you have in order to accumulate the noise level and interference level from the mobile networks from neighbor country. So the hypothetical network looked like in the picture. We have the cluster of base stations. We have the ATS transmitter at the height of 2,000 or 10,000 meters, and the ATS receiver with the antenna height in the neighboring country. Two possible antenna types were used in ATS system, because it's not so, let's say, not so much public information about the ATS system, how it is working, because the system is developed many years ago and it's not so much information. So in the ITU radio communications standards and recommendations, we found two different antenna types that could be used. It is so-called the radar type and tracking type antenna. In the next slide, I will show the antenna patterns, how it looked like. And the simulations are made first of all with one cell, 3 sectors of base stations, and then the cluster with 57 57 sectors. And as I mentioned, 2 different antenna heights of ATS transmitter. So these 2 antenna patterns used for the ATS system, according to 2 different ITU radio communication recommendations. So in the right side, we see the tracking type antenna. It is more like narrow beam, which tracks the plane on the horizon. And then radar type antenna system, it has more wider antenna pattern. Also, it is a wider pattern for the, let's say, for the tracking of the system in the horizon, but also it could take more interference in much wider angle. So, and the calculation itself. First of all, if the, let's say, ATS transmitter is flying around the ATS receiver, the angle between this system and according to the antenna pattern, the gain is changing also. So it's highly dependable situation and the outcome of the situation, how the ATS transmitter and receiver is let's say set, or what is the possible area where the ATS on board the transmitter can fly around the receiver. So it is.
Evalda, sorry, you have 1 minute more. Okay.
Yeah. Okay. No problem. So it's just the situation regarding the, let's say, the gain and elevation angle. And 2 different calculations were made. First of all, with antenna pattern according to the ITU recommendation 1459. So the both pictures show that results highly depend on the aircraft altitude. So using IN method, it can be seen that the coexistence is possible when the aircraft is flying at 10,000 meters altitude. And however, the aircraft altitude is of 2,000 meters, the protection criteria is always exceeded. And if we use the more precise, the more correct interference criteria of C over I plus N, we see that there is a margin of 35 dBs regarding this protection interference criteria. So we have really high power budget, which means that ATS system is overprotected. The same calculations with different antenna pattern regarding the ITU recommendation of 1851. So we achieved or we get the same outcome, that that is more precise C over I plus N interference criteria shows that there is a power margin of minimum 17 dBs. So we see that in radio communications that the 17 between 17 and 35 dBs of power margin, it would let us to share the spectrum much more, let's say, in much more effective way. So the main outcome, the main result of this study, that if we would use the more precise, the more correct approaches with the more precise interference criteria, we can achieve the possible positive interference margin between 17 and 35 dBs. And in who, let's say, working in the radio communication area knows that it is a beneficial major change in electromagnetic compatibility. And the second conclusion, that if we use the C over I interference criteria, you can achieve the better electromagnetic compatibility comparing with the I over N. And the third general conclusion, that if the countries would would change the approaches using the more precise interference criteria, the radio systems would develop much, let's say, in much beneficial way, and both countries would have more developed radio systems as it could, because if the system is overprotective, so it stops the other radio systems development in a particular country and for the neighboring countries. Okay, thank you for your attention.
Okay, thank you very much, Valdas. Is there any fast question? Because we are running out of time for this part. Okay, so then maybe we can save it for, if something arises, maybe we can save it for the end of the session, because I think we are getting out of time. Okay, so thank you very much, Valdas. Sorry, we don't have time for questions.
No, thank you. Thank you very much.
Okay. So next presentation is going to be modeling a leaf and spine topology for VM migration in fog computing, and it's going to be presented by Pedro Juan Roch from Spain. Pedro, again, you have around 12 minutes for presentation and a couple of minutes for questions. Okay, so when you want, you can share the presentation. Thank you. Oh. Pedro, no se te oye. Your micro. No, we cannot hear you.
There we go.
Yes, now.
Okay, sorry. So thanks very much, Mr. Chairman. My name is Pedro Juan Roig. I'm coming from Spain, from Universidad Miguel Hernández. And this presentation is about modeling a leaf and spine topology for VM migration in fog computing.
First of all, we'll talk about a small introduction. Sorry, Pedro, could you please switch the full screen of the...
Oh, sure. Sorry.
No problem.
Sorry, what's going on here?
Down.
Oh, sorry, there we go. Now?
Yes.
Is that okay now?
Yeah,
sorry for the inconvenience. So let's start again. My name is Pedro Juan Roig. I'm coming from Spain, and this presentation is about modeling a leaf and spine topology for VM migration in fog computing. First of all, we'll make a small introduction. Then we'll talk about leaf and spine. Next, we'll present the modeling of leaf and spine, and finally, we'll draw some conclusions. Well, IoT mobility in fog computing environments. Here we have associated VMs may try to follow IoT devices as close as possible, minimizing both latency and bandwidth use. VM migration among hosts within fog facilities is the solution, and the optimal path is given by the data center topology. The target here in this paper is getting an algebraic model for a leaf and spine architecture to be applied to the VM migration in a fog computing environment. So end devices may move around, so their VM migrate. Well, as an IoT device moves away from the coverage area host 1, just like here, and it gets close enough to host 2, like here, VM migration takes place. So VM migration, VM number 3 just moves from host 1 to host 2. Well, let's start with FAT3, right? FAT3 is a typical in traditional data center facilities. Here we have 3 layers of switches, just like 1, 2, and 3, and just another extra layer of hosts, right? And the layout is heavily dependent on parameter K, such as the number of switches on each layer and their connections, and the number of hosts in the topology and their connections. Here we have an example of a FAT3 topology for K equals 4 and oversubscription rate 1:1, right? But in modern data center facilities, we need the following features. We need equal distance among hosts without any blocking link, thus increasing throughput performances and lowering latency. We also need use of COTS, commercial off-the-shelf switches, meaning less power consumption and lower cost. And we also need that topology is based on east-to-west traffic, leading to scale-out networks, thus adding independent resources to the network so as to enhance performance, as opposed to north-to-south traffic, leading to scale-up networks, thus adding new resources to the network so as to enhance performance. So the proper solution here is leaf and spine, right? So leaf and spine is typical in modern data center facilities where we have just 2 layers of switches, the lower layer called leaf and the upper layer called spine. And here each leaf switch has to connect to all spine switches in a just full mesh topology fashion, right? And here the number of leaf switches is equal to the number of downlink ports per spine, given by variable P. And the number of spine switches equals the number of uplink ports per leaf, given by variable K, right? And here we have an example of a full mesh topology between all leaves and all spine switches. Well, benefits of leaf and spine. All hosts are at most 2 hops away from each other, meaning that just 1 hop away if they both share the same leaf switch, or otherwise 2 hops away. But here we have a drawback, which is when the number of hosts is very high, many leaf switches are needed, so there might not be enough ports in spine switches. And in such cases, 3-layer designs prevail. Well, let's go for the modeling leaf and spine building blocks. First, we'll have the spine switches. We have Q switches going from 0 to Q minus 1, counting from left to right. And each spine switch have lower ports going from 0 to P minus 1, going also left to right? Then we have leaf switches. We have P leaf switches going from 0 to P minus 1 from left to right. And in each leaf switch, we have Q upper ports going from 0 to Q minus 1, and we have W lower ports going from 0 to W minus 1, right? And we also going to model the hosts, and we have PW minus 1 hosts. Sorry, we have PW hosts going from 0 to PW minus 1, and each host has just 1 unique port, meaning the 0 port. All right, so we're going to present the modeling of each of those building blocks, right? Starting for the host modeling, at host layer, it only matters what happens to source A and destination B, and the rest of the hosts do not take part in communication, so they are useless in this context, right? So for the source host, it sends a message, right? H sub A sends the message, and destination host, it receives the message, right? H sub B receives the message. So generalizing, meaning putting all hosts in a concurrent manner. So we have all hosts going from 0 to PW minus 1. They only just send and receive the message. Regarding the leaf modeling, this is the logic. If a message is received from a lower port, right, it is forwarded towards destination host if hanging on the same leaf switch, or otherwise it is sent upwards. And if a message is received from an upper port, it is forwarded towards destination host, right? So generalizing, meaning putting all leaf switches in a concurrent manner. Here we have the algebraic expression for all leaf switches coming or going from 0 to p minus 1, where in this point we have the condition, meaning that if source switch and sorry, if a source host and the destination host share the same leaf switch, it performs this action. Otherwise, it performs the other action, right? And talking about spine modeling, if a message is received from any port, right, it is forwarded towards destination leaf switch through the direct link between them, as we have full mesh topology, right? So generalizing, meaning putting all spine switches in a concurrent manner. Here we have for all spine switches going from 0 to q minus 1, all received messages are forwarded all the way to the destination leaf switch. And the final model is obtained by putting in parallel all three previous models conforming a leaf spine architecture, right? So putting all three different entities we just modeled, right? Hosts, leaves, and spines, right? And as seen at every layer, communication only takes place in all redundant paths existing between source and destination. Therefore, by applying linear superposition, the model is behaving according to the leaf and spine specification. So the model is verified. Finally, conclusions. An algebraic model has been designed layer by layer in order to show the VM migration redundant paths among any two given hosts. So it meets the leaf and spine specifications and it behaves according to expectations. Eventually, this model may permit to obtain all available redundant paths between one source host and one destination host. Also, the chain of devices composing each of the paths, and also the ports used in each device, right? So this model permits to obtain all the features of any given path. So this is it. This is the end, and thanks very much for your attention. And if you have any question, just ask.
Okay, thank you very much, Pedro. Thank you for being in time. I really pretty much appreciate. Is there any questions from the audience here? Okay, any question from the internet?
And from me also, Professor Rodriguez.
Oh, sure.
Uh-huh.
No problem.
Professor Rodriguez, I have a question.
Yes, please proceed. Yes, thank you. Really.
Thank you. Pedro, you simulate, you design just the architecture, not the trigger for virtual machine migration. Is that okay?
Yeah, that's it. I mean, we just perform a theoretical work. And the theoretical work says that if an IoT device just moves close enough to another antenna, to another facility, just the via migration takes place. Why does it take place? We didn't design the trigger, as you said, right? The trigger must be maybe the RSSI of the antenna received. Maybe when it's closer from let's say antenna 2 than antenna 1, the via migration takes place, or it even might be because of the load balancing policies, maybe. So we just leave this for a future work, and we just modeled at this point the mechanism of migration, not the reason of the migration.
Okay, thank you.
Maybe for a future work, this might be a good point.
Okay, thank you very much, Pedro, and thank you for the questions.
You're welcome.
Okay, if there are no more questions, nothing from YouTube. Then, okay, thank you very much again, Pedro.
You're welcome.
We move for the next presentation. Next one is presented by Svitlana Matsenko from Latvia, and title is Development of the Fibonacci Octal Error Detection Code for Telecommunication Systems. So, Svitlana, you have the micro, so as you want, you can start. Please remember 12 minutes for presentation, okay?
Hello. Good morning. My name is Svitlana. I'm from Riga, Latvia.
Svitlana, sorry, there is a lot of echo in your audio. Can you switch off maybe your speakers?
Okay. Wow. Okay. I'm sorry.
There's still a lot of echo.
Now, okay.
Maybe you should switch off your speakers.
And now. Yes. No.
Echo is very persistent.
Yes. No.
No, I'm afraid it's not very good.
I'm sorry. Okay. Today I present my research idea.
Sorry. It is very difficult to understand you. There is a lot of echo and the quality of audio is very bad. Could you please check the system?
I don't know what's like. No.
Can you try again?
No. I'm sorry. I don't know.
Sí, dígame.
Yes.
Sí, dígame.
No, maybe we can move to the next presentation while you try to fix it.
Okay.
Okay. If new, is it okay for you?
Okay. Yes. Okay, and no.
Sí.
New, are you ready for a presentation?
Yes.
Yes. So okay. So I think it is better, Svitlana, if we let New do his presentation, and then we try again later with you. Okay.
Yes.
Okay. Thank you. So please, Svitlana, can you block your screen?
Mở camera lên. Bên kia tắt thì mình mới show.
Okay, can you stop sharing the presentation, Svitlana?
Stop sharing. I don't share in.
Okay, this is it.
Okay.
Okay, so then we're going to move till we wait if Svitlana is able to fix the problems. So next one is going to be presented by New Hong from Vietnam. Presentation is called Enabling Wireless Power Transfer and Multiple Antenna Selection from AOT Network Reliant NOMA. So New, when you want, you have 12 minutes. Thank you.
I would like introduce. My name is Nguyễn Hồng Nhu. I'm living and working in Vietnam. I would like to share idea my paper with title Enabling Wireless Power Transfer and Multiple Antenna Selection to IoT Network Reliant NOMA. Content, motivation. introduction, system model, outage, performance, NOMA and OMA. Numerical results, conclusion. Abbreviation, NOMA, IoT, SIG, OMA, WBC, OB. Motivation, the fast growth of IoT applications. Result, requirement of heterogeneous IoT sensor asset. Sensor accessing to networks in the upcoming 5G network. These applications are related to capability of device in D2D network and M2M network, other circuits and application associated with IoT systems. An animal of power is consumed by these small sensors and IoT device to serve their data transmission and communication. Introduction, the energy harvesting technique is robust to tackle this problem by harvesting the energy from the surrounding environments. Specifically, signal is recorded firstly for the user with the best channel condition, while assuming all the user signal as interference. Motivated by these papers, we formulate the problem of selection of beacon and antenna selection to evaluate outage performance of true NOMA user. In this model, Figure 1 show the IoT system containing the AB asset boy, relay to user and beacon. From the system model, we set up the algorithm equation with two signals X1 and X2. After the clock X1 as relay, the corresponding SI and R is expressed by equation. Continue. The clock is to which SIG is employed to eliminate interference. The SI and R to the clock is given by here equation here. Similar to the receiver and the clock signal at destination, we have general equation. Next, the destination is required to record H1 at T1 at below with equation. the S psi and R to the cock H1 at D2 is given by with equation here. After 6, the S psi and R to the cock H2 is given by equation. The best channel is selected with the index of antenna equipped at the AB at formulate. From the system model, we can see beacon will transfer energy to relay. We can compute harvested energy at relay with equation E, and the transmit power level of the relay E with PR. We had calculation outage performance analysis NOMA. Outage analysis at D1 with OP1. We have outage at D2 with perfect 6. The law form expression is computed to provide outage analysis at D2 at in perfect 6 KS with OP2. The calculation steps for an OMA K are the same as for NOMA, and K of asymptotic calculation read on the paper. We have outage probability destination be expressed at with equation OP I OMA. In this session, we saw the comparison of IoT system relay outage performance up to user using NOMA and OMA. These users are grouped in downlink of the AB using NOMA and OMA. The user are grouped in downlink. I'm sorry. Their user are grouped in downlink of the AB using the relay fading channel under different simulated parameters. We can see with the tree and one antenna K with NOMA and three and one antenna with OMA. In figure, compare outage performance comparison of D1, D2 of NOMA and OMA with energy power beacon noise by variant K equal 1 and K AQ 3. Next, outage performance comparison of D1, D2 for NOMA and reset energy power base station noise by variant with with energy with the factor power distribution. Let's continue figure 5 outage performance comparison of the D1, D2 of NOMA and OMA reset with the energy power beacon noise by variant the factor power distribution. Conclusion. In this paper, we had investigated the IoT system by enabling energy harvesting and transmit antenna selection schemes. The related scheme with wireless power transfer technique benefit to such IoT with performance improvement for too far use who need assistance of wireless power transfer assisted relay. We derive implicit form for the outage probability for two distant user in the considered IoT system. Thank you for your attention.
Okay, thank you very much. Thank you very much, Mr. New. Is there any fast, quick question? Because we are getting to the end of the gap of this session. Any question from the audience? Is there any question from YouTube, from the internet? Okay, so as we have only 10 minutes to finish this session, I'm going to try again with thank you very much. No, we don't have more time for questions. Thank you very much. Very nice presentation.
Yes.
Thank you. So next we're going to try to connect with Svetlana. Svetlana, are you there?
No, we will talk rồi.
Svetlana, we have lost Svetlana. So maybe she's trying to fix the technical problems. Let's give her a couple of minutes. Darius, are you there? I'm going to try to connect with chat with Svetlana. It's not here. Okay. Well, meanwhile, if you have anything to share, any questions about any of the presentations, if you're still there, we can take the time now to waiting for Svetlana. But I am afraid she's not getting back.
Thank you for perfect sharing.
I have done my best. First time I'm sharing online presentations, So I think it's first time probably for everybody. Not first time Zoom video conference, but probably first time presentations. So you have done a very good work. Thank you very much. Thank you all for coming to the conference, and also thank you Darius and Adimantas for your for the organization. And I hope next year we would have time to meet in person in Palanga. Okay, I know all of you, all presenters and organizers have done a very good work, a lot of effort to have everything ready for the presentation. Okay. So, oh, Svetlana, we have Svetlana here. Hello, Svetlana. Can you hear us? I can see your screen, but I cannot see you. You there? No. She's missing again. Okay. Svetlana, are you there?
No.
Let's give her a couple of minutes. She's trying again. No, it's not working. Okay. We can see that you are trying to share your screen, but we cannot see the presentation, neither you. Hello? Hi, Svetlana, can you switch your video or audio on? Because I'm not sure if you can hear me. I'm afraid you cannot. Okay, so let's wait for a couple of minutes more. This session, remember, it finishes at 10:30. So I'm afraid we will not be able to continue because at 11 we have another session. But for me, there's no problem if Svetlana is here, we can wait for her. But not sure. Ah, hi, Darius. Can you hear me? Hi, Darius. We are having problems with one of the presenters, Svetlana. We had a problem with Svetlana. She had problems with the audio, and we have lost her. So this is the only presentation remaining, but we are not sure if she's coming back because.
She is coming.
Okay, there we are. Hi. One of the presenters.
Hello, hi. No? Do you hear?
Yes.
Yes?
Now,
this is
don't worry.
I'm so sorry. Now, my presentation. One minute. I'm so sorry. one minute. Okay.
Yeah, there we go. Okay.
Okay.
Thank you, Lana. So I'm going to present you again fast. There we go with Svitlana Matsenko from Latvia. She's presenting development of the Fibonacci octal error detection code for telecommunication systems. Please use 10 to 12 minutes, okay? And then we give a couple of minutes for questions. Thank you.
Okay. I'm so sorry. And today I presented my presentation, our idea, and this is a development of the Fibonacci octal error detection code for telecommunication systems. Today, telecommunication systems use a large number of different codes. This is cycling codes, this is polar codes for 5G, this is LDPC codes, and we're using error detection codes. This is another class of coding. Some of the error control codes, for example, cycling codes such as Reed-Solomon, BCH, which have high noise immunity, require complex methods of encoding and decoding coding combinations. As a result, the implementations of these methods in information transfer system leads to an increase in their cost and decrease in reliability and speed. In addition, most encoding and decoding devices, as a rule, don't process the property of cell control. Therefore, it is difficult to implement end-to-end control of information on their basis, covering both is processing and transmission using the same code. Such control makes it possible to reduce hardware cost and increase the speed of exciting telecommunication systems. However, the exciting codes designed to transmit information don't process the property of E2E control. In this work, for the E2E control of telecommunication systems, the Fibonacci octal is used in minimal form, which has a simple structure and a very high error detection ability. And the important task necessary for telecommunication system using the Fibonacci code is the ability to convert it to binary code for communications with binary digital system, and vice versa, the ability to convert binary code to the Fibonacci code. To convert data, we propose use Fibonacci octal code, which consists of a sequence of 4-bit codes modules containing 8 Fibonacci number. And important features of the Fibonacci octal code is those code combination. All these modules are relatively easy to convert to the number of 3 bits binary modules and vice versa. And research object, the idea of this works, this is convert data using Fibonacci octal code, convert data binary to Fibonacci, Fibonacci to binary, because many devices using binary code. Also, however, there is another type of code, this code, another type of redundant coding, in which coders use the nature redundancy, already exciting its structure. Because if we using this type of coding device based on this coding, more speed and simply than if you have if we using cycling code maybe and another type of coding. The nature redundancy of such codes requires less hardware to implement encoding device, as it has already been partially implementation in device that generates code word of the basic task. Also methods and decoding device based on code switch nature redundancy also have a simple structure. And this slide shows coding in a minimal form of representation. This is a Fibonacci code, and you can see Fibonacci numbers. This is Fibonacci code in minimal representation, and some structure of this code, which weights, which code lengths, and another information. All devices, all the above mentions noise resistant codes, which nature redundancy, including Fibonacci code or binary code. This is code with nature redundancy or permutation. These codes can a common drawback, it requires a conversion operation from the Fibonacci codes to binary codes, and vice versa for binary codes to Fibonacci codes to communicate with the binary techniques. Now you can see information about the fraction of detectable errors in digital device based on the minimal form of the Fibonacci codes. You can see some information, and this is code has some high error detection ability, and this is 99.9% with code length equal 32. This is high error detection ability of this code. And we propose some method for convert data using error detection code based on the Fibonacci octal code for convert data from binary to Fibonacci and from Fibonacci to binary code. And this method consists of some steps. The first, the binary code multiply of 3 is divided into modulus consisting of 3 bits, starting from LSB bit and leading to the MSB bit. The result will be a binary octal code. If the total number of bits is not a multiplier of 3, then zeros are added to the left of the MSB, so that the total number of digits in the binary number becomes the multiplier 3. Each binary modulus is converted to the corresponding model of the Fibonacci codes. And the next step, the Fibonacci octal code is formed from Fibonacci modulus and the proposed for conversion binary code to the Fibonacci octal code and ends. And we proposed the methods for converting Fibonacci code, octal code to binary code. And this method consists of 4 steps. The Fibonacci octal code multiply of 4 is divided into modulus consisting of 4 bits, starting from 0 LSB and leading to the MSB bits. The result will be a binary octal code. Is not multiplier of 4, then zeros are added to the left of MSB, so that the total number of digits in the Fibonacci octal code become the multiplier of 4. Each Fibonacci model is converted to the corresponding model of the binary code. The Fibonacci is formed from binary model, and the process for converting a Fibonacci to binary codes ends. And this is some algorithm methods for conversion. This is code using Fibonacci octal system. This is some example how these methods using. If we have some binary number, and this table shows some information about octal type and Fibonacci type and how convert this system. Of course, we can use this system in the telecommunication system, and also we can use this code in for building for synthesis of component of digital device. And now you can see some counters in factory, and maybe another type. This is counters, and this is some information about how using this code in the structure of digital device. And now you can see high-speed Fibonacci counter with parallel work. This is information collection in transmission system with counter, and this is the same counter. And this counter use Fibonacci code, and this counter using this code and consists of the sum structure. This is control unit number 1. This is unit of disposition, analyzed unit, register. This is flip-flop structure, and counter 0 setting unit. And this is digital device using end-to-end control system, because using error detection code and works in error detection code. And the next slide shows some information. This is modeling on this counter, which using this type of coding, and you can see some information about how this counter works using error detection codes. This counter based on the minimal form of the Fibonacci codes and using in these codes. And of course, idea of this work. This is some Fibonacci octal codes, and these codes help this device convert information to binary form and Fibonacci form, and vice versa. Okay, and this is conclusion. We proposed methods for converting binary octal codes to the binary octal codes and vice versa. And this is methods using some information, some modular structure with 3-bit binary code and 4 bits Fibonacci code. And this is research about data converting information from binary to Fibonacci octal code and for Fibonacci to binary octal code. Okay, this is it. Thank you very much. Thank you for attention. I'm so sorry for...
No problem. It happens.
Yeah.
I'm afraid we all have to get used to this. I'm sorry, and thank you very much. I'm afraid we don't have time for questions because we still have one presentation. I almost forgot it. I'm sorry because of this mess. So last one is going to be from Elans Rats from Latvia. It is entitled Supervised Machine Learning-Based Classification of Video Traffic Types. So please, Svetlana, if you could stop sharing.
Okay, okay.
Darius, are we on time?
I think,
but
well, I think 10 minutes, it will be enough.
Okay,
Should
okay.
be enough. Okay.
Okay, you heard Elans, 10 minutes.
Okay, thank you. I will try to be as
brief
as possible.
Thank you.
I'm a postdoctoral from Latvia, and I'm working on machine learning applied for network traffic in scope of my postdoctoral project. And so first, I'd like to share some motivation why I'm doing this. The idea is very simple. We are going to use an SDN network, which controls network, yes, to perform some resources allocation and control for different types of traffic. But we need some decision-making element because different types of traffic have different requirements. For some traffic, it is better to provide higher bandwidth. For other traffic, latencies. Sorry. What is going on? Can you see my screen, or somebody else is trying to share?
No, we can't see you.
You can't see me, yes?
I think that maybe they are trying for the next session.
It seems because Dejan Dragic has started screen sharing.
Yeah, and he's for session 7. So
I see.
Dejan, if you could please stop the presentation.
I wrote a message, okay, to next session people who are waiting, and they will stop share as soon as they can.
Thank you.
There we go.
I see. So we can continue, yes. And so we use two different types of traffic, video traffic. We used live video stream traffic, and we used recorded playback of the very same video fragment. For both of these video fragments, we have used Twitch platform, which allows saving live stream videos in archive.
No. Yeah.
O, garsą įsijunkite.
Sako, pirmą kartą man labas
Labas
rytas.
rytas.
Aš žodžiu neturėjau.
Tai va, kai kopijuoji į naršyklę, tada nėra.
Ja, tai aš anksčiau visą laiką iš nuorodų, kai PVD yra nuorodai, turėjau normaliai, kaip nekeisti. Jau čia kažkas su Zoom. Ne taip.
Okay.
Pirmą kartą susidariau, dabar pradėjau jau nervuotis ir štai mikrofoną.
So we have captured the traffic using Wireshark and exported it into CSV format.
Biškai ankstesnė sesija ne visai sklandžiai vyko, nes elektra trūkinėjo, dinginėjo, tai...
For processing via MATLAB.
So, pas pirmininką. Tai jo toks biškai buvo...
Darius, please, you silence the audio.
As a classifying parameter, we have used the intensity of traffic packets, which showed to be quite good parameter, but other parameters can be used in future as well, so software can be improved. And for network traffic, there is such thing as it collects every packet from every connection, and we need to perform filtering by using, for example, source IP address to select only packets relevant to the stream. Here you can see in picture traffic nature for on-demand video traffic, which is a record. Similar picture have been obtained for live stream video as well. You can here see both of these traffic types. Yellow is on-demand video, which is transmitted in short burst with high intensity, and live streaming video has lower intensity, but it is present constantly. So we need to try and classify traffic based on this intensity by using different supervised machine learning algorithms. First, and the most important thing, is to select appropriate window size for segmentation of this traffic. And here, the most natural choice, obvious at the beginning, is to use the time interval between bursts of the on-demand video traffic. However, this is quite a high number of time, which is 10 seconds, which is a lot. So we try to reduce this window size. And I will go straight to the results by using four most popular algorithms for video traffic captured at 1080p60 video quality mode with 10 seconds window size, both for raw data and filtered data, which means that this data, for example, raw data, has been split into two subsets, which is training data and testing data, which was used to estimate the accuracy. And the same has been performed for filter data. As we can see here, mainly all these algorithms can predict, or should I say better, classify traffic type quite accurately, except for naive Bayes classifier, which shows poor results for raw data, which is unfiltered data with different packets from other connections. The same results have been obtained for other video quality modes, and there is additional one more thing. that we have tried to be more realistic about it. So we can use cleaned, filtered data to train machine learning algorithms. However, if we expect this algorithm or model to work in real time, it will have to deal with real and raw unfiltered traffic. So we have modeled such situation when we have training data clean and testing data real, and there is a problem of time delay. So in order for this algorithm to work precisely, it is necessary to eliminate this time delay between expected, should I say, pattern, which is being searched in traffic, and real traffic windows. So basically, we have 10 seconds video traffic. For blue signal, you can see the burst is at the very beginning of the window. For red traffic, the burst is in the middle. So this leads to pure, quite poor accuracy. And this time invariance is the cause of this. If we perform a 5-second, introduce 5-second delay for the field raw traffic, red traffic, so we shift it by 5 seconds to the beginning, the accuracy is once again improved, except for naive Bayes model, which, as it has been shown, deals poorly with noisy data. So we go straight to the conclusions, and direct use of traffic intensity samples is possible. This yields acceptable results for many algorithms, except for naive Bayes. Neural networks have been used as well, for example. But this requires strict time alignment of data for this to work, which is in real situation, should I say, unrealistic, yes. So future work consists on using statistical parameters of traffic intensity rather than traffic intensity samples themselves. Accuracy evaluation for versus different parameters such as window size. We change different window size, we change intensity sampling time, as well as we try to create hybrid methods which would perform initial processing with unsupervised methods with further improvement of accuracy by using supervised methods. This is continuing work on my project. So thank you, and sorry that it was so
thank you
unorganized.
No, sorry for us. No, it was technical problems that have been keeping delaying all the presentations. I'm really sorry, because we don't have any time more for questions. So if there is anybody interested, maybe they can do it by email later, because we have to give the gap for the next session, I'm afraid. No, Darius?
Yes, exactly.
Okay, so thank you very much, everybody. I'm sorry for the problems.
Thank you, Mr. Chairman.
I see you next time in person in Paraga. Thank you very much.
Thank you.
because it's already time to go ahead with the next session. My name is Michal Frivaldsky. I am from Slovakia, University of Žilina, and my scope of research is power electronics. It's a pleasure to be a chairman of this conference and this session. So maybe just a brief information. Everybody has 15 minutes, including a time for discussion. So please check your time during the presentation. And yeah, I would be very, very glad if there will be a discussion from the, let's say, plenum. Okay, so the first presenter is Mr. Dejan Drajic from the Serbia. He already is sharing the presentation. So the topic of his paper is a reliable low-cost air quality monitoring using off-the-shelf sensors and statistical calibration. So Dejan, I am giving you a word and go ahead with your presentation.
Thanks a lot. First of all, I would like to say hello to everyone, and I'm really sorry that there is not a real live session, but okay, this year we will do like this. Next year we will be in Lithuania. So my background is actually that I'm PhD in telecommunications, and I'm working in one R&D company, Dunavnet from Novi Sad, city of Serbia, and we are IoT oriented. In our portfolio, one of the solutions is this air quality monitoring solution, and it's a team of us who developed this solution, and I was particularly involved in signal processing. So I will here try to explain you how the system works, and then specifically what is contribution regarding this calibration. So first, like introduction, you know that air pollution in the city nowadays is increasing because of cars and other things that are used by man. So in the cities, especially in the winter, it's quite critical. It's quite critical in Balkan area and also in Poland. And we also have some cooperation with Polish people. What is the thing? You have static measurement stations. And on the picture, you can see how it in reality looks. And it's usually operated by the public authorities. Of course, they are reliable, and they are able to accurately measure a wide range of air pollutants. But from the other side, they are very large, as you can see, very expensive, and require significant amount of maintenance. And extensive cost of acquiring and operating these stations severely limits the number of installations. For example, in Belgrade, there are 2 million people, and there is only 6 stations like this. So it's obviously that you cannot cover the whole city, but only 6 fixed points. We developed with low-cost gas sensors our solution. Low cost means that these sensors are available and they are more or less reliable, and the cost is 100 euros is the cost of that sensor. And the device, complete device, depends on configuration, but it's about 2,000, 3,000 euros. And on the previous picture, we saw public measurement station, which cost is 200,000 euros. So ratio is 1 to 100 when we compare to price. But we now have to see how accurate are these sensors. And this solution is complete based end-to-end solution that provides real-time measurements. And of course, you can see the device, and it's like the box for the shoes. So it's maybe 1.5 kilos. So it's very small, and it's portable, and it could be located wherever you want. So that's the importance of this solution. What we could measure particles, then the different gas pollutants. And important thing is that we have opportunity to use multiple communication interfaces. So any kind of mobile network, also LoRa, it's new low wide area network, but with devices with small consumption of electricity, and Wi-Fi. So we can cover every needed technology, and we have the most of the pollutants that are of interest. And one of these things is that you also have possibility to calculate common air quality index. It's common measure that is used to report the quality in some city. Here device take measurements on every minute and send on Azure, Microsoft Azure platform, where it's stored. And after that, there is a dashboard to visualize real time and historical measurements. And there is a mobile and web widget application for this. So now to go, when you have idea what is solution, now to see the methodology. Here are briefly listed used sensors, and it's every sensors are really low cost sensors. What was the methodology? So you have two possibilities. One is to go to laboratory. The problem in laboratory is that they still don't have quite good procedure that can claim, okay, with this laboratory you will have your accuracy and availability enough, and it's very expensive. You spend for one pollutant, you can spend 1 or 2 days in laboratory, and it could be 5,000 euros. So if you do that, then your low cost solution will not anymore be low cost. And so the best possible solution is actually to collocate this with public monitoring station, physically to go into this place and put your device. Of course, you need access to this, and the local authority has to provide you this. Fortunately, we have more than 10 years of experience with this, and we have good cooperation with the public authorities, so they allowed us to do these measurements. And these are the only measurements that are generally on the world level that are recommended how to do the measurements. Other good things, we had period of 9 months. And these sensors are quite sensitive to temperature and relative humidity. So we have enough opportunity to see, to collect data from all different periods of time. And our resolution is 1 minute. And public authority, they also had 1 minute, but they provide average values for 1 hour. So we were, in order to compare, we also did averaging. And also in this averaging, it's not only averaging of results, but it's also some post-processing. Because during this 1 hour, there should be some problems with, for example, sensors, then some interference, then some problem with electricity or with communication. So it could happen that there will be bad measurement. So we developed algorithm for removing these bad measurements. When we come to mathematics for calibration, we are using curve fitting using least square method. It method performs fitting based on minimization of the sum of squares of deviations from a straight line. So linear calibration. And by this calibration, we are actually calculate coefficients A and B. And now when we do this calibration for the first 15 days, it's recommended number of days. After that, we apply the coefficients on the measurements, and it is the same coefficients are used through the whole period of measurements. And as a result, how good is our measurements after calibration? There is regression analysis, and R2 is actually value that say how good is calibration. 1, it's perfect correlation, 0, no correlation. And now here is result for CO, carbon monoxide. On the left figure, you can see in the time measurements. X-axis is actually our measurements, and Y-axis are actually public monitoring station. And you can see how calibration is done. And for this red curve, these coefficients A and B are true regression are done. And when you compare it in real time, you can see the similarity of our measurements and the similarity of our measurements and public monitoring. As you can see, it's 0.933, which is perfect, almost perfect. Then PM, it's a different pollutant, and some pollutants are based on their nature. It's easier to do measurements, some not, unfortunately, because there could be some cross interference from other gases and influence. And actually these particles, it's actually small particles, micrometers particles in the air, actually dust. And here you can see how it is possible to do calibration. And you can see that here we have R2 0.716. which is still good enough. And here is the table where we compared for all measurement gases, where we compared what is this R2 coefficient during different periods of time. And what can be seen that in February and the August is the lowest. Why? Because at this time of year, humidity, especially in February, and temperature, especially in August, how they influence our measurements. And you can see how it's changed through different part of the year. But the good thing, and you can see that ozone, it's quite heavy to measure. So with ozone, we have the lowest correlation, but it's still correlation. So here, by this is proved that these sensors could be used. And then with this, we can claim, okay, you have our small solution and accuracy will be like that. Then second thing is, as I mentioned, there could be some peaks in the measurements, and we should eliminate that. What we proposed? We proposed algorithm where first we do averaging of measurements for some desired period of time. And the input parameter is length of observed period. After that, we define what is the value of the peak. I mean, if you have measurements that are 1.1, 1.2, 0.9, and then suddenly 5, it could be a peak. So we can then define value X, and we said, okay, this is candidate to be peak if it's X times higher than average value. And finally, maybe it's not peak because of peak. Maybe it's something abnormal is going on in the air. So we must be sure. And because of that, we said, okay, then we could check, is it single peak or it's a few consecutive measurements are peaks. If it's, for example, this is parameter N, and if we put the B3, it means that we will tolerate up to 3, that is a peak. And after that, if we not that it's peaked, then it's replaced, and it's replaced with mean value of the previous and next measurements. Here it was campaign 15 days and on 1 minute level, because it's our measurements and we want to eliminate peaks. And here are actually, it was period of sliding window for half an hour. Then the peak is candidate if it has 3 times higher value than average. And finally, number 3, it was number of observed consecutive values. And based on that, we also get measure results. And here you can see by gases, and you can see by part of the year. And obviously, it is seen that exactly in this period of year, when it's extreme temperature or humidity, that we have the most of the peaks. And it also depends. O3, ozone, he has the highest number of peaks because of measurement process. And also this ozone it's very hard for monitoring, because he's something in between. Very often he's going from ozone to NO2 and oppositely. And on the figure left, it can be seen peaks and how they are eliminated. Which peaks we eliminated by this algorithm. And finally, it's calculation of common air quality index. Actually, here it's in order, when you have to present your results to ordinary people, they will not understand what is 1.1, 0.9. And because of that, it's calculated air quality index that categorize all measurements in 5 ranges, five ranges, from low value, very low, to very high. And it's colored from red to green with different nuances. And based on that, it's possible to compare around Europe and around the world all results. And few gases, actually all the gases that we observed, they are actually used for calculating of common air quality index. And it's first calculated by pollutant. So it's sub-index comparison. And here is a presented comparison with the reference monitoring station. We have 100% percentage of overlapping with reference monitoring station for CO. It's different from other gases. And the worst case, it was for O3 in August, 77%. But total common air quality index is calculated when we take the worst pollutant. He dictates the level of common air quality index. index. So the 4 could be right, and the 5th one could be bad, and it will be the air quality index. And on this level, you can see that in the worst case, we have 80% overlapping with referent monitoring system. And it's the web portal and how it is presented. So in the web portal, you can go and click on your reference on your station, and you can get in real time and in some history time how is common air quality index monitoring. Conclusions is that the idea was to prove that low-cost electrochemical sensors are able to do complementary measurements to public monitoring station. It will never be so accurate as public monitoring, but you can compare the price and the quality. So collocation method was used. Calibration is done with LSM algorithm. Results obtained for a period of 9 months are compared. Proposed algorithm for peaks detection elimination is developed, and common air quality index is calculated and compared with public monitoring station. And the main conclusion is that with a careful data post-processing, low-cost sensors could be used with high reliability as a complementary network to public monitoring station. Final slide is future work, of course. Future work is development of calibration algorithms that are taking into account impact of the air temperature and humidity on readings. So when we apply algorithms, for sure, we will increase correlation. And also analysis of influence of peaks elimination on correlation coefficient will be done, and common air quality comparisons will be done on 24-hour level, because in this work we compared on 1 hour level, and other thing is to see how it influenced 24-hour. So as you can see, the main conclusion is that these sensors could be used, but you have to be to take care and to do enough good post-processing to increase the correlation of measurements. And basically, I'm sorry, I had only 15 minutes, so it's story for half an hour. But I hope that I give you idea what we are working. Thanks.
Okay, thank you very much, Dejan. Yes, I think you are on time. We still can ask one question for the discussion. So if there is anybody who would like to ask, please feel free. Okay.
Maybe you're interested in air quality in your area, so we can cooperate.
Yeah, I see that there are some also European projects and European calls for the air pollution monitoring, so the development of the sensors and also the statistical, let's say, informations are very important for us.
Yes, because in this, how we get this know-how? Because we were in a FP7 project, CitySense. It was guided by people from Norway, from Norwegian Institute for Weather, and they teach us how to actually do measurements and how to present results and to do post-processing. And now we improved with further algorithms for post-processing, and that's the idea.
So yeah, so it was under the project. So yes, good work. Fine. So if there are no questions, I would like to thank you, Dejan, and we can proceed with the next presentation. So please stop sharing your screen.
Okay, thanks a lot. Yes.
Bye-bye.
Bye.
Okay, and the second paper will be presented, I suppose, by Mr. Václav Kolar from the Technical University of the Ostrava, Czech Republic. And the paper is, I think, in cooperation with the Polish colleagues from Gdańsk University of Technology. The topic is a development of a capacity voltage divider for high voltage measurement as part of a combined current and voltage sensor. So it is also a topic related to the sensing technology. So I would like to welcome Mr. Kolar, and now you can start sharing your presentation and you have a word.
Yeah. So thank you, Mr. Chairman. Can you hear me?
Yes, it's good.
Yes, okay. And Can you see my screen?
It's perfect.
Yeah, okay. So I'm Václav Kolář from Technical University of Ostrava, and my presentation is about capacitive voltage divider for high voltage measurement. So our team dealt with development of combined voltage and current sensor for measurement in high voltage power networks. This sensor is dedicated to be placed on overhead power voltage line, and it has a remote wireless data transmission, and it should have autonomous operation. It should operate there for at least 20 years. We hope it will be possible, but it will be hard question. Now we started to test it. Yes, purpose of this device is for diagnostic of high voltage power networks, and also voltage measurement, current measurement, and indicative power measurement. We did this development in cooperation with one electrotechnical company from our city, and important thing is also cost effectiveness of this device. It must be relatively cheap. For current measurement, we use their inductive instrument current transformer, but it's not part of this presentation. For voltage measurement, we use capacitive voltage divider because first it is cheaper than, it's much cheaper than inductive instrument voltage transformer, and also it is lighter and smaller. But from some point of view, it's not so accurate as inductive instrument voltage transformer. So we stated some requirements for accuracy in cooperation with the company. Voltage error should be below 0.5%, current error below 2%, and power error below 5%. From these values, we calculated phase angle error. It must be below 0.6%. There is digital data processing with sampling rate 16 kilosamples per second. And if there is some constant error during measurement, which is always plus or always minus 1%, 2%, is not problem. It can be easily corrected. But if error is changing, it is problem. So stability of the all components is very important. Here you can see schematic diagram of voltage divider, and this is high voltage capacitor which we use for it. There are two high voltage capacitors in series, and here as a low voltage part of the divider, we use ceramic capacitors with dielectric C0G. They are very good capacitors, very stable. There is no problem with them. But these high voltage capacitors are relatively cheap, are very robust, and it is important, but they are not dedicated for measuring applications. So we have to test them and find how they work when temperature is changing or so on. So we made such a testing device. Here are two inductive voltage transformers. Originally, they are measuring voltage transformers from 22 kilovolts to 100 volt, and one of them we use as power source in opposite direction from voltage 50 volts. We increased the voltage to 11 kilovolts, and second one was used as a measuring transformer, as a normal instrument voltage transformer. Because we want to test at least 8 capacitors, so because of time saving, there are 3 capacitors simultaneously. We can test 3 dividers together. So high voltage part of the voltage divider and separately low voltage part of the divider, and high voltage part or low voltage part or both of them can be inserted into constant climate chamber and test their temperature dependency. Core of the measuring apparatus is this analog to digital converter by National Instruments, and there are also some another measuring devices, and we measure also temperature. First, we tested long-term stability while temperature was constant. Temperature was about 25 degrees of centigrade. At the beginning, you can see voltage error or voltage deviation. Yes, of course, it's important. Voltage was 11 kilovolts. So 110 volts is 1% of the overall voltage. So at the beginning, error was 0. And as you can see, during time, there is some deviation which stabilizes after 24 or 48 hours. Some capacitors are more stable, some capacitors are stable less. So important is after assembling the voltage divider, it must be somehow calibrated, but not immediately, but it has to be connected to voltage, and we must do calibration after at least 1 day. 2 days is better. As far as phase error is small. It is within limits which was stated. Phase error is not problem from this point of view. Then we tested temperature stability of capacitive dividers in constant climate chamber. Here you can see changing of temperature from 25 degrees of centigrade to about 70, back to 25, to minus 25, and back to 25. Phase error changed, but not too much. It is still within stated limits, but amplitude error changed a lot. 250 volts, it is more than 2% of measured value, and it is too much. It must be somehow compensated. So in this picture, you can see temperature dependency of each tested capacitor. Low voltage capacitors are okay. There was no problem with them. Phase error, there is phase error, but not very big. But most important is this amplitude error of high voltage capacitors. Fortunately, this is linear function, almost linear function of temperature, so it can be quite easily compensated by such formulas. We decided to correct phase angle error only by constant, which is independent on temperature, and amplitude error by this formula, what is linear function of temperature. According to these equations, we get these coefficients. In this table, you can see values measured when temperature was 0 and temperature was 25, and final correction coefficients. After this, we chose from our 8 capacitors, we chose 3 of them, which was the worst, and tested them again in constant climate chamber, and we used that mathematical equations to correct measured values. So here you can see again how the temperature changed. Here you can see voltage error after mathematical compensation, and here you can see phase error. All of them are now within limits which we stated at the beginning. And here for amplitude error, you can see there are such peaks. Always when temperature changes from one value to another value, there is peaks of error. It is still within limits. Limit is about 55 volts, and it is below 50, so it is okay. But if it would be possible to remove these peaks, the result will be very, very good. I think it is because of temperature time constant of capacitor, because capacitor is big, and when temperature penetrate from outside environment inside the capacitor, it takes some time, and there is some temperature transient. So maybe it is possible to develop some mathematical algorithm which consider temperature time constant of capacitor and which can suppress these peaks. But until now, we didn't test it such algorithm. So with this mathematical compensation, our capacitive divider is good enough to be used in combined current and voltage sensor for high voltage measurement. We finished several pieces of prototypes of such sensors, and now they are tested in testing laboratory of our industrial partner, and we hope in future it will be produced commercially. So thank you for your attention. And do you have any questions?
Okay, Václav, thank you for your presentation. So now I am opening the discussion. So are there any questions from the auditorium? Probably there are no questions. I would like to say that this work was very interesting for me, as I understand the requirements on the accuracy, and I very appreciate the experimental approach and testing. So maybe I will ask you, did you also test these sensors also in operation? Let's say some transition line or something like that?
Not yet.
Not yet. Mm-hmm.
We did this testing with lower voltage than is nominal voltage at 11 kilovolts, but there was one capacitor. In reality, there will be 22 kilovolts and 2 capacitors.
Oh, okay.
And our industrial partner has better laboratory. They test it now in 22 kilovolts, but only in, as I know, only in laboratory. It will go to field, but in future.
in future. Yeah, because such a sensors also need some kind of certification and
Of course.
additional testing. So there is a long way still to be done. Okay, thank you very much, Václav. Now you can stop sharing your presentation. And we will continue with the other paper from the colleagues from Turkey. And the presenter will be Mr. Mehmet Demirtas. The topic of this paper is lossy capacitance measurement circuit based on analog lock-in detection. So it's some kind of additional informations or very similar problematics to previous presentation we can compare and discuss maybe. So you are free to start sharing your presentation, Mehmet, and I am giving you a word.
Thank you, Mr. Chairman. Hello, everyone. My name is Mehmet Demirtas. I am from Turkey. I'm a PhD student, and my presentation is about a measurement circuit, which is titled as a lossy capacitance measurement circuit based on analog lock-in detection. Here, the contents of my presentation. First of all, I will start with the introduction part. Then I will talk about the design circuit that will measure the lossy capacitance. Then I will move to the theoretical analysis of the design circuit. Then I will analyze that circuit on LT-SPICE and Vivado, that is called as computer-based analysis. And then I will show the experimental results that I carried on before the conclusion part. And first of all, the introduction part. The capacitance measuring is actually an efficient method to detect many real-world parameters. For example, we can use capacitive measurement techniques to detect displacement, pressure, force, humidity, moisture, or something like liquid level measurement. And also, we also know that capacitance can be lossy. I mean, they are inherently lossy, and they can be represented as an ideal capacitance in parallel with a resistance, as it is shown in this picture here. The lossy capacitance model is shown here. There is a resistance and there is a capacitance. They are connected to each other in parallel. And also, there might be some stray capacitances, and they are called as CP1 and CP2. They are actually parasitic capacitances, and they can arise from the connecting the capacitance to a circuit. Therefore, they should be eliminated, actually. Their effects may cause problems in measurements. Therefore, their effects should be reduced by exciting or driving the lossy capacitance with a low impedance input signal, and also we can virtually ground terminal 2 by using an operational amplifier so that the effects of stray capacitances will be reduced. And this is the overall measurement circuit diagram that we use to measure the lossy capacitance model. Let me talk more about the design circuit here. We used FPGA to generate the sinusoidal excitation signal so that we drive the lossy capacitance model with a sinusoidal signal. And this is generated using FPGA. Also, we need square reference waves, and they are also generated using FPGA. Also, FPGA is also used to measure the output of the analog measurement circuit. In our FPGA, there's an integrated ADC, analog to digital converter, and we use that ADC to measure the output. Also, there is a transimpedance amplifier, and it converts the current which flows through the lossy capacitance model into a voltage value, and that voltage value is actually will be processed and demodulated by the analog lock-in detection. And transimpedance amplifier can be designed using an operational amplifier and a feedback resistor. Using the analog lock-in detector circuit, we can able to extract the values of lossy capacitance model. Here is the theoretical analysis. The voltage at the output of the transimpedance amplifier can be expressed as a function of input voltage and feedback resistor, unknown resistance, unknown capacitance, and the frequency of the input voltage. Therefore, the output of transimpedance amplifier can be expressed as a sinusoidal signal with different amplitude and phase, but with the same frequency as the input. So input is actually modulated by transimpedance amplifier. And the output voltage, if you look at the output expression of the transimpedance amplifier, there are two terms, and they are actually 90 degrees phase shifted version. They are 90 degrees phase shifted. Therefore, we can use the first component in the red circle in order to find the unknown resistance Rx. And the second component can be used to find the unknown capacitance. Also, we can theoretically analyze the lock-in detector. Lock-in detector is a known methodology, and it is widely used in demodulation actually. And if we assume that the input of the lock-in detector is x of t is equal to a times sine omega t plus theta, and also we have two different reference signals. They are used to open and close the switches in the lock-in detector. And they are square waves, and they are shifted version of each other. And they can be expressed as a sum of sinusoidals with different amplitudes and with different frequencies. Therefore, if we multiply the input with the reference signals, then we will get in-phase output and quadrature phase output. They are called respectively I and Q. Actually, I consists of the in-phase output consists of a DC component plus some higher frequency terms. And also, similarly, quadrature phase output also consists of a DC component and some higher frequency terms. And in lock-in detector circuit, there is a low-pass filter which eliminates the higher frequency components, and its cutoff frequency should be lower than omega. And then we can obtain I and Q values such that I is equal to 2 over pi times I cosine theta, and quadrature phase output is 2 over pi I times A times sine of t, theta. And the unknown resistance and capacitance can be extracted using I and Q components plus the output equation of the transimpedance amplifier. And if we combine the equations together, we obtain the Rx and Cx equations here. Therefore, if we are able to measure I and Q components at the output of the lock-in detector, then we are able to find Rx and Cx altogether. If you look at the computer-based analysis, as I told before, we used an FPGA to generate the excitation signal which drives the lossy capacitance. And it is actually a 2 kHz signal with an amplitude of 3.3 peak to peak. And if we need reference signals with the same frequency, but they are shifted version of each other. So we can see the Vivado graph here. They are shifted where there are reference signals and the sine wave altogether. And also we analyzed this circuit in LT-SPICE, and we used some certain values, some discrete values to simulate or emulate the lossy capacitance. For example, here we have the schematic of the lossy capacitance and transimpedance amplifier. Here is the unknown resistance is 4.7 K and unknown capacitance is 10 nanofarads. And also we used an operational amplifier with a feedback resistance of 10 K. And if you look at the frequency response and transient response of the circuit, we can see that the output of the transimpedance amplifier is amplitude and phase modulated version of the input signals. Also, we can analyze the schematic of the lock-in amplifier together. Lock-in amplifier actually consists of two different parts. The first part is multiplication part, which uses 4 switches, 4 resistors, and an operational amplifier. And low-pass filter part is actually taking the average of the output of the multiplication. So therefore, we can obtain the I and Q values using the average, that average value. For example, in this schematic, we have shown the input and output signals of multiplication. If there is a sinusoidal input to this lock-in amplifier, the output of multiplication will be something similar to full wave rectified version of the input. And the output of low-pass filter will show the average value of the output of multiplication. We can see that it's actually 0.6346 volts of that output of multiplication. The average value is equal to 0.6 volts, around 0.6 volts. Then we assembled together all the circuits in the LT Spice and we got the simulation results. For example, here we simulated 3 different lossy capacitances. They are all emulated using discrete elements. For example, the first element is 4.7K and it represents the loss resistance part, and 10 nanofarad represents the pure capacitance part. They are all together represents the lossy capacitance part. And there are 3 different lossy capacitances simulation results. For example, actually the first column on the RX and C, the first 2 columns represents the nominal values of the lossy capacitance parameters. And at the right-hand side, we can see the simulated values of the RX and CX, which are found using the LT Spice simulations, using I and Q values. If you look at the computer-based analysis more deeply, we can see that actually we can simulate the relative error, and relative error actually represents the difference between the simulated value and real value. For example, for the relative error for the capacitance measurement is 0.89% for this circuit simulation. And there is also, we defined a case which we call it worst case error, which is actually used to assess and measure the effect of the tolerances of the passive circuit elements. Because we already know that this is an analog circuit, analog lock-in detector circuit, and there are many passive circuit elements like resistors and capacitors, and they have tolerances. Therefore, we should know their effects, if their tolerances affect our measurement results or our errors. If they cause error, we should be able to know that. And if we simulate the worst case error, there is, for example, for the capacitance measurement, 3.41% error is maximum. And also, there is another error analysis method we call as phase error, which is defined as the error caused by the phase mismatch between the input signal and the reference signals. Because we know that the input signal and the reference signal, they should be synchronized, and there should be no phase mismatch between them. If there is a phase mismatch between them, they may cause errors. For example, there is an intentional 5% phase mismatch is given for the simulation, and the error is really high. There are errors really high. We can see that on the right-hand side. And also, we tried that simulations and we tried to make it experimentally, and we can see the experimental photo of the circuit that designed to measure the lossy capacitance. There is an FPGA chip on the left-hand side, and also that FPGA's ADC is used. Also, signals are generated using an FPGA, and some other analog parts are designed on a breadboard. Here, I explain the experimental setup. The FPGA we used for generated requiring signals is called Xilinx Z-board. And the analog lock-in detector, as I told, is built on a breadboard. And also, AD844 high-speed op-amps, and 3 of them are used as part of transimpedance amplifier, multiplication unit, and low-pass filter. Also, we used switches, a CD4066B. It is a quad bilateral switch that is used to multiply the input signal with reference signals so the demodulation will be possible. And also, as I told before, Z-board's 12-bit 1 megasample per second ADC is used to measure the output voltage. And also, if we obtain the results, and we can see the experimental results. Also, we compared 2 different values here, because if we measure a real component, a real discrete resistor or capacitor, we should know it is real value before measuring with this circuit. And the real values of the capacitance and resistance are obtained from an LCR meter that can measure resistance and capacitance with 0.5 and 0.7 accuracy. And we compared the real values of Rx and Cx with the measured values of Rx and Cx, and we found out the relative errors. Especially here, the maximum relative error is 1.62% for the resistance measurement and 6.38% for the capacitance measurement. And those errors can be associated, actually, the causes of errors can be, for example, the on resistance of the switch that used to multiply the signals, or, for example, non-ideal characteristics of the operational amplifiers, or maybe the variations of the passive components, their values, of course, they have tolerances and they may cause errors in the experimental setup. Finally, the purpose of this study, as I told, design, simulate, and experimentally test the lossy capacitance. Here, that is a hybrid system which consists of a digital signal platform, which is called FPGA, and analog circuit elements like operational amplifiers and passive elements. And in simulation environment in LT-SPICE, we use three different error analyses to determine the possible sources of errors. Actually, for example, we found out that the tolerances of the passive elements like resistors or capacitors may cause some errors actually. And also another major factor, actually it is bigger factor than the previous one, another major factor that may cause measurement error is identified as the phase shift. I mean, the phase shift must be controlled accurately, otherwise there will be a big amount of error. Therefore, in order to reduce the effect of phase mismatch, we use the excitation signal and reference signals which are generated from the same FPGA using the same internal global clock, so that their phase shift is accurately controlled in the digital domain. And also, by using an FPGA and using digital ways to control the phase shift, the circuits like analog phase shifter or analog switch driving circuit suggested in the literature, for example, they are no longer required in this circuit type. Also, this circuit, this measurement setup, or let's say, can measure the final DC output of the system I or Q values with precision, with 3-point precision, so that we no longer need a separate measurement device. Thank you for your interest.
Okay, Mehmet, thank you very much for your nice presentation. If there are any questions, we need to speed up, so someone from auditorium. Probably no questions, so we have to little bit speed up. So Mehmet, thank you very much once more.
I thank you.
And we are going to continue with another paper. So the next paper is from the Slovakia, from Department of Mechatronics Electronics, University of Žilina, and it was made in cooperation with the Technical University in Brno. Now I would like to ask Mr. Bajzik to share his presentation. And Jakub, I am giving you a word, so you are in charge now.
Thank you very much. So can you hear me and can you see my presentation?
Everything is okay.
Okay, thank you very much. So let me introduce myself. My name is Jakub Bajzik and I would like to present you results of our work, gunshot detection using convolutional neural networks. So the main motivation and objectives of our research is the design a citable method for classifying sound events using neural networks. In recent years, it has become a topical task to use some techniques, some known techniques to detect environmental sounds that may be associated with the potential dangers such as explosion or gunshot, siren, car alarm, and so on. So this work is focused on the possibility of using audio visualizations as a future for convolutional neural network training for gunshot detection. In our application, the important task is not only the increasing the number of true prediction when the gunshot is predicted as a gunshot, but also reduce the number of false positive predictions because we cannot detect every impulsive sound such as door opening as a gunshot prediction. The conventional approach is to create a single future vector for classifiers and for training. In our work, the combination of several future matrices to a single color image is used. The main advantage of this approach is that the futures are overlapped in matched time positions. This method was used in previous study for the classification of environmental sound, but the novelty of our paper is in the analysis of this method described and implementation for specific event recognition with respect to the time consumption and precision. The most commonly audio signal visualization used in practice is a spectrogram that shows the frequency spectrum change over time. Another representation uses the Mel frequency capstone coefficients, which reflects the nonlinear and masking characteristics of human hearing. The last feature used is the measure of self-similarity of the signal based on the distances. It is similarity metrics. So the two-dimensional matrices as individual color channels, as you can see on the figures, were joined to the resulting image, as you can see on these two images. We assume that the MFCC and similarity metrics will help to classify non-impulsive background sounds. As you can see on this figure, the self-similarity matrix layer of gunshot is almost empty, is black, whereas the background noise contains a visible grid. So in the experiment, we performed several tests. We used different convolutional models for future extraction. We compare the pre-trained weights against the training wall convolutional model. We also tested the signal downsampling, and we compare our results with commercial approach when the spectrogram visualization is used only. The weights of model VGG16 are pre-trained on the ImageNet database for real-world object recognition. Only the hidden layer was unlocked for training. In the case of ResNet 18, all the layers of convolutional model were unlocked for training. The advantage of this approach is that the training convolutional neural network is more adapted for detecting specific shapes in gunshot visualization. The result shows that the training all convolutional layers of model ResNet 18 leads to the best resulting accuracy. As I pointed, when we train all convolutional layers, the algorithm is more adapted for the specific sound visualization and can extract the features more precisely. Also, the signal downsampling does not lead to significant decrease in the resulting accuracy. That means that if we can detect impulsive sound, that based on our results, the signal downsampling does not decrease the accuracy. The practical application was designed for the testing for algorithm, for testing the algorithm on a long duration recordings. The application processes the audio signal in 1 second length segment with a quarter-second time shift. Based on our previous results, we use the model ResNet 18 and signal downsampling in this application. So the algorithm was tested on audio recordings of urban sounds mixed with gunshots. And these gunshots we obtain by recording in indoor shooting range. We record this gunshot using portable audio recorder. Also, the proposed method we evaluated or tested on audio recording of similar impulsive sounds. As you can see on a figure, this is a slam on a drum, door opening, and this is gunshot. So the result may differ by selecting the threshold and sensitivity parameters. In this case, the threshold parameters means the minimal probability of belonging to a class to be a gunshot, and the sensitivity parameter is the minimal number of consecutive positive prediction. To achieve the same results as in this case, in a noisy environment may be essential to lower the threshold value, which may cause an increase in false positives. The real-time performance optimization was also tested. The algorithm or the future extraction time from a 1 second length segment is about 80 milliseconds, and lowest prediction time was reached by using model ResNet 18. So also the lowest prediction time and also the best accuracy was reached by ResNet 18. And total processing time is about half a second. So the real-time performance is also real. We pointed out these conclusions of our results, and the first is that the convolutional models can be used for audio visualization recognition, despite the fact that they are designed mainly for real-world object recognition in images. This may be helpful in situations or in application where we cannot implement the audio recognition and image recognition framework separately, or we want to use the same framework with both. But when we adapt the model for specific audio visualization, we can achieve the better results. In case of impulsive sounds, such as gunshot, the bitrate reduction without significant accuracy decrease can be achieved by signal downsampling. And also, as I pointed out, the maximal accuracy and minimal processing time can be achieved by using model ResNet 18 with trained weight of convolutional layers. So thank you for your attention, and if you have any question, I would like to answer.
Jakub, thank you very much for your presentation. It was once more applied research with a nice experimental verification. So I am opening discussions. So are there any questions from the auditorium? Maybe not. So as I am familiar with this research, because Mr. Jakub Bajzik is my colleague, we can discuss internally. And now we can proceed to the next paper. Jakub, thank you. You can stop sharing your presentation. And now I would like to ask Mr. Ali Tat from the Turkey, the Technical University of Eskişehir. Okay, we can see your presentation, and fine. The topic is a time series prediction for amount of airworthiness based on time delay neural networks. So now, please, Ali, you are free to start the presentation and check your time.
Thank you. Good morning, ladies and gentlemen. I would like to quickly introduce myself. I am Ali Tatlı from Departments of Avionics, Eskişehir Technical University. I will try to present our study with my fluent English. This is a pioneering study that we are supported with instructor pilots. A significant study before us isn't included in the literature about airworthiness. They are not many, and they are not detailed. And also, they do not meet some requirements. This is a signal processing with unique problem. Because of the time is limited, I want to summarize our study. We have some criterions to create a airworthiness dataset from meta reports with the contribution of pilots. This is the important part of this study, I think. And then we built different type of neural network models to make predictions on it. Neural networks are well known in the literature. We experienced in our study 10 type of input datasets, 4 type of activation functions, and from 3 to 60 number of hidden layer neuron. To begin, I would like to introduce to you my presentation plan. My talk is divided into 6 main sections. First, I am going to present the importance of study. In the next section, I will give information where the study is conducted. It is important because of runway, and then which meteorological dataset we have used to form airworthiness dataset. The next thing I will share with you is what is principal components of airworthiness and how we create the airworthiness dataset to make our predictions. Then I will introduce our methods about predictions. Finally, I will ask you to results. First of all, we need to focus on these headlines to make understand easily. And I think this is important because of the method we have used in the study. I mean, time delay neural network has been known for years. There are legal restrictions in Aeronautical Information Publication, AIP, which you have to comply. You cannot fly whenever you want in aviation. Pilot experience, which you have to consider. Instructor pilots assist the study with the limits that they use in education activities. Our study covers flight training organizations, not for all of the aviation society. And there are some technical issues, differs from aircraft to aircraft. In this this is a meteorology-oriented study. Meteorological parameters and events directly affect flight activities. And also, from another perspective, meteorology knowledge makes it possible for aviation activities to be carried out. From first perspective, aviation activities are mostly carried out in the troposphere and stratosphere layers of the atmosphere, and aviation activities exposed to weather events in the troposphere, where meteorological events occur. Flight training organizations prefer to keep simple aircraft in their inventory because of maintenance and equipment costs. Although these aircraft are more vulnerable to meteorological events. Approximately 20% of the accidents that take place in the aviation sector are meteorological origin. And when considering in the inexperienced pilot candidates, it is so important for the training process. From other perspective, the flight and maintenance schedules, the travel times, the movement routes, and the flight altitudes are determined in the light of meteorological information. Provision of times that aren't suitable for flight is also an important factor in the planning of maintenance activities. To sum up, simple aircraft and inexperienced pilot candidates require meteorological parameters to be well analyzed and predicted. Planning can be made more effective by separating the days that aren't suitable for the flight to maintenance activities. According to International Civil Aviation Organization, it is considered necessary that taken into account a period of at least 5 years in meteorology-focused aviation surveys conducted in Annex 3. In this study, a time series including hourly flight availability per day information was created by using hourly metal and specie observations belonging to Hasan Polatkan Airport, covering the period of from January 2009 to June 2015. It means there are 58,053 hourly meta and specie reports we have used. Here an example of a report and its meaning. We decode reports and use it in the study. It has many information about weather conditions. For example, wind speed and direction, cloud sailing and covering, prevailing visibility. Let's take a look at LTBY station. This is a satellite image from our avionics department of university and LTBY airport. LTBY station is used by Department of Flight Training to carry out education activities. General information about the airport is given in table. All of the properties most important to us is runway direction. Because of aircraft must take position relative to the heading of runway during their landing and takeoff. For this reason, crosswind components exceeding the limits according to the type of the aircraft restrict the use of the runway for the relevant aircraft. The direction of the runway doesn't change, but the direction of the wind often changes. Other parameters are indirectly affect airworthiness. These are Cessna and TB-20 aircrafts in the inventory of university. Depending on the intended uses, the design and flight performance of aircrafts are different, so they are affected from meteorological events at different levels. Besides, as a technical criterion, wind speed and gust condition according to the runway heading shouldn't exceed the crosswind limits of the training aircraft. It is 15 knots for Cessna and 25 knots for TB-20 aircrafts. The majority of the education-oriented aviation activities are completed under visual flight rules. As stated in the Turkish Aeronautical Information Publication, AIP, the VFR visual flight rules, the VFR flights cannot be made in the process, which covers the close sailing falls below 1,500 feet, the visibility falls below 5 kilometers, and also 20 minutes after sunset and 20 minutes before sunrise. We calculate sunrise and sunset times for all the time periods 6.5 years that we research in terms of night conditions. And we checked with these three criterion all of the meta reports if it is valid with regard to VFR or not. But this is not enough. In this study, both the VFR conditions and the absence of aerodrome announcement and significant meteorological event that will affect aviation operations are evaluated as a measure of airworthiness. Utilizing plot experience, the conditions are considered necessary for airworthiness. There should be no heavy torrential rainfall, thunderstorms, clouds of cumulonimbus and cumulus congentus. Cloud cover should be less than 5 of the 8 octa. Cloud sailing should be more than 3,000 meters. And also temperature should be more than 5 degrees. We created our airworthiness data in the light of all these limits. Artificial neural networks constitute a model that will generate suitable outputs in response to the network inputs. Determining the appropriate network weights of this model is called the training process. I mean, training is an error minimization process between input and output. Also, when inputs are time series, the use of time information can provide meaningful information to the network in establishing the input and output relationship. The time information can be provided directly to the network as an input, as a numerical quantity, or it may be provided in the form of a time window. So, network could be available to recognize the patterns that evolve over time. I mean, a time information to the network may be provided by the changing frequency of an input signal. By incorporating time into the operation of the artificial neural network, it can be possible that statistical variations can be followed in a non-stationary time series. In the study, we provide the time information into the network, both as a direct input to the network and as a part of the network's operation. Also, in our experiment, we use some activation functions. We change and train it. The network structures consist of 4 models with no lag, 1 time lag, 2 times, and 3 times lag delay. Thus, by using 10 data sets as input, a total of 9,280 network models have been trained and tested. The best is underlined. The comparison best result of conventional MLP at the top and the time delay neural network at the bottom. Thank you for your attention. Is there any question?
Ali, thank you for being in time, so I'm opening discussion. So if there are no questions, we will continue due to the time schedule. Ali, thank you very much for your nice presentation and very interesting topic.
Thank you.
You can stop sharing the screen, okay. And now I would like to ask Mr. Pančík from the University of Žilina to present his contribution, which is focused on the electronics upgrade of cyclic loading test machines for automotive production. Juraj, you can start sharing your screen, and now you are in charge, so go ahead with the presentation. Juraj, you have to unmute your microphone.
Thank you very much,
Okay.
Mr. Chairman. Hello, everybody. I'm last today. I will be quick. So let me say a few words about our project. Please, can you see my presentation?
It's okay.
Yes, thank you very much, Mr. Chairman. In our contribution, we describe the upgrade of 8 of the machines designed for cyclic testing of automotion mechanical safety critical components in the real production plant. Tested mechanical components were hydraulic brakes, were classified as safety critical, and there were one part of complex mechatronic component. At first glance, it might seem purely technical problem and does not need to address the broader context of common upgrading test machines. From the point of view of functional safety in the automotion, according to the standard ISO 26262, it was necessary to meet the specific requirements in the modernization of the testing machines. Designed and realized information system as temporary solution was cost-effective solution for 4 years, and it prepared the purchasing a new final testing solution in the production plant. The present modernization solution is also a good example of the cooperation of the university and the production plant. The matter of adequate testing of hydraulic brake calipers is performing of many mechanical cycles where brake calipers squeeze the brake pads against the surface of the disc brake pads in disc. You can see this picture. Existing electromechanical counters of mechanical test cycles which are integrated in the old test machines serve as a source of input data for test engineers. Test engineer can read of a number of performed mechanical cycles, by manual reading from electromechanical counter. After all upgrading of brake test machines, the test engineer can also read of a number of mechanical cycles via by us developed electronic modules. The end of fatigue test of tested mechanical part is determined by automatic stop of test machine cycling when the part is suddenly broken. Test engineers should be informed about this test machine stop state in the shortest time by us developed information system. By upgrading of collection of 8 test machines, we reached of automatic collection of cycling data. The number of performed mechanical cycles during the fatigue test for each particular mechanical parts are collected in the database. All upgraded test systems served for testing of caliper integrated EPB, electronic parking brake, or caliper integrated EPB. The EPB system consists of the actuators that generate the clamp force necessary to safe hold the vehicle, the conventional calipers that convert the clamp force into brake torque, electronic hardware with the electronic control unit, and cable harness and switches, especially the control software providing the functions that the driver will experience. The figure shows a typical EPB actuator and caliper assembly. The actuator is screwed on the brake caliper. This is actuator. The spindle gear sets converts the rotational torque coming from motor. Belt drive and planetary gear, this one, set into transaxle clamp force that is applied to the conventional piston. This piston is here. A brake fluid is present in the piston chamber and separated from the sealed actuator. This figure gives us some examples with typical functions of actual EPB systems. The apply release process for EPB system represents its main functionality. Since the EPB was first launched in the 2001 year, number of EPB functions continues to rise significantly. Modern EPB offers by far more than the basic apply release of a conventional parking brake, and it interacts with several other driver assistance systems. You can see remote control parking, start-stop assist, hill assist, K-out apply, dray away assist, emergency braking. There are a lot of functions, about 30 functions implemented in the SI module, and modern EPB can serve for drivers in many sites. The market share of EPB systems is continuously growing from year to year. This figure shows how the fitment rate is position rate of the EPB develops compared to conventional options. The production of the 60 million EPB calipers in 2015 was a remarkable milestone, and the market share will most likely reach 30% within the next years. The forecast shows that the fitment rate could nearly reach half of the market within a decade. This one. Now back to our test machines. The system architecture of the set of upgraded test machines is described in this figure. This client-server architecture can be recognized in the case of the 3-layer web server architecture. In detail, this is one upgraded test machines. This is fatigue test machine. This one. This is special interface prescaler, and another special interface digital control IP module. You can see also industrial plan, local area network. This is all Linux-based application server and web server and MySQL server. On the next picture, we will deal with this part of for system. Here is detail. You can see here a electromechanical counter in old test machines. This one, Calibration counter, is also the name of this part. The head of IP electronic modules is a frequency divider built around Atmel AT-TINI, this one. The module TCV 112, this module is produced by one Bulgaria firm named Teracom, this one. From Russia. Input signals from electromechanical counters, this one. With amplitude 24 volts are optically isolated. Oh, I lost my laser pen, this one, optically. To ensure a fault tolerance, module of frequency divider is powered from IP module. This frequency module divides the frequency of the input pulses generated by input mechanical cycles in the ratio 1 to 100. The output of the frequency divider ensures an input signal for digital input of the module TCV, this one. And the module TCV, this one, creates one SNMP event. It means Simple Network Management Protocol trap. This is a special internet standard protocol for collecting and organizing information about managing devices on IP networks and for modifying that information to change device behavior. Typically, device support SNMP includes cable modems, routers, switches, servers, workstation, printers, and more. This is very, very old internet protocol like HTTP or FTP. Yes, but at the end, you can see that one SNMP trap represents 100 machine cycles. On the next picture, you can see a wall-mounted panel with 8 electronic counters, IP modules, constructions view. This is this blocks represents 4 old test machines with a cable concentrator and also cable deconcentrator here, and 8 IP modules based on Teracom TCM module. These wall-mounted panels was prepared for presentation purposes for project stakeholders in the plant testing room. And you can see also, sorry for delay, my computer has some problem. Oh, it crashed. My Microsoft Power crashed. Yes, this is a photograph of wall-mounted panel with 8 electronic quantum IP modules. This is actual photo. We connected all developed 8 electronic interfaces with Linux application server and MySQL database server. Users, such test managers or test engineers, access the database MySQL database from a Microsoft Excel database client based on MySQL ODBC database interface. Therefore, we decided to develop a database client program based on Visual Basic for Application, VBA, on the Excel Ring platform. As you can see, the users can see the current status of individual test machines. Current status. LP is derived from word level pulsator, another name term for test machines. You can see that working or not working, so like semaphore lights. To use an Excel and VBA, Visual Basic Application platform on client user side was ordered by Department of Management of Information System in the concrete plan. The strictly policy of the production plan, only Excel VBA macros rule is allowed in the test laboratory. Not possible another program. Only Excel platform. Also, this is, you can see another picture prepared by the Visual Basic for application. With Excel and VBA dashboard visualization of on-day mechanical cycle history and test machine utilization. The user can see from database records the total number of mechanical cycles performed for each component tested based on days or months. Next slide. The user can choose day and month and year, and he can see the results from this database. In this concrete case, LP1, LP3, and LP5, in this concrete day, were done out on the work, didn't work. This table represents 1 month from database, the utilization of test machines. You can see white days. It is not good message for test manager, because test manager is interested in utilization of all test machines. And last slide. A fatigue test of the parts ends by its sudden structural degradation. Therefore, it is not possible to tell in advance when this event occurs. The information system, which was developed by us, will provide the user information about the end of the fatigue test and record this time. The information system will further provide information on the duration of the break in the operation of the test machine. The break time of the test machine is defined by the end time of the fatigue test and time of starting a new test with another component of the same test machine. This program module was developed also based on Visual Basic for application. Very important remark, all data presented at this slide are not real data, they are non-public matter. It's not possible strictly to show you a real data about fatigue test of break. Only data for illustration. Conclusion. At first glance, the modernization of old test machines might seem purely technical problem and does not need to address the broader context of common upgrading test machines. From the point of view of functional safety in the automotion, according to the standard ISO 26262, it was necessary to meet the specific requirements in the modernization of these testing machines. Designs and realized information system as temporary solution was cost-effective solution for 4 years, and it prepared the purchasing a new final testing solution in the production plant. The present modernization solution is also a good example of the cooperation of the university and the production plant. Thank you very much.
Thank you, Juraj. So I'm glad that you have been on time, but we still have some delay. It was applied research from the industrial segment. So once again, I'm familiar, we can discuss internally. If there is one question from auditorium, you can ask. Good. If not, we still have one paper that shall be presented. So Juraj, was not the last one. So please stay online. And okay, now we will continue with the final paper of this session. It is a nonlinear load characterization using orthogonal apparent power decomposition. And the presenter is Marko Dimitrijević from Serbia and from Faculty of Electronics Engineering. So hello, Marko. Please start sharing your presentation. And now you are in charge. You can start.
Thank you, Mr. Chairman. My name is Marko Dimitrievich from Faculty of Electronic Engineering, University of Niš, and I will present our recent work. This is a prototype of an instrument for nonlinear load characterization using orthogonal apparent power decompositions. So what is our motivation to do this work? First, the concept of apparent power decomposition in circuits with nonlinear sinusoidal conditions is very ambiguous notions, and it can be very confusing, probably to students and some novice to electrical engineering. It is also very ambiguous in sinusoidal circuits, but even more complicated in non-sinusoidal conditions, when we need to include some harmonics for voltage and current. In non-sinusoidal circuits, we can define reactive and distortion power in different ways, and there is no generally accepted decomposition of apparent power. It is so-called decompositions of apparent power. Also, there is no unique definition of reactive power in such circuits. It was an ongoing debate over 80 years, and still we don't have a unique answer to these questions. Also, there is a lot of papers, a lot of works about power decomposition, reactive power, and so on. But all results are obtained by means of simulations or calculating quantities using some measurements on simple test circuits. Our motivation was to build a prototype of an instrument that can measure reactive power defined with different power decompositions in real time, to build some real-time decomposition instrument. So, to understand power decomposition as itself, we need to review some basic notions. First, most general notion is instantaneous power, that is instantaneous voltage times to instantaneous current in some circuit. And active power, that is related to physical quantity to energy that is dissipated in some circuits as thermal energy or mechanical energy, can be defined as average of instantaneous power. But we also have some other notions as apparent power, that is simply multiplications of RMS values of voltage and current. So the most general decomposition of apparent power is given with these well-known equations, and N stands for some non-active power. This is the most general notions of something that is really not related to any physical quantity in a circuit, but can serve as some explanations in some situations. There is many decompositions of apparent power, let's say some modifications of these previously given equations. And we use some decompositions that are present in the literature. First, the Booleano decompositions, the most common and most well-known. Then IEEE standard decomposition, phase shift method that is used in most devices and power meters today. Then Kimberg's, Sharon's, Price's, Kuster's and Moore's decomposition, Shepard and Zikakani's decompositions, Doppenbrock's and Chernetsky decomposition. I will only mention two decompositions in this presentation for the sake of the time. First, most known and most common decompositions is Booleano decomposition. And Booleano defined the reactive power with these equations as a sum of reactive powers for each harmonic. K is a harmonic order, V and I are RMS values of voltage and the current respectively, and phi is some phase for voltage and current. This is the most common decompositions and most used and most mentioned in the literature. The second decomposition I will mention here is a standard decomposition phase, so-called phase shift method for calculation of reactive power, and it is used in instruments, most instruments, and in power meters. It's very simple, and it can be easily reproduced and implemented with Hilbert filter, and it is very cheap to implement such functions, so it is most common in instruments. So we developed the system for real-time power decomposition, which is unique, as I know there is no such attempts to make some instrument to measure simultaneously more than one power decomposition. It has real-time capabilities for measuring and calculating various power components, and whole system is based on the virtual instrumentation principle. So in this picture you can see some subsystems of this unique system. First we have acquisition subsystem based on National Instruments acquisition models. Then controller that has two stages. First stage is FPGA stage, which is in charge for data acquisition and conditioning of the signals. And the second stage is real-time controller or real-time operating system, which hosts the applications that calculates all parameters, all the compositions, find reactive, active power, and some more exotic definitions of power. All measurements and all parameters can be stored on local storage or transferred via TCP/IP network to PC. PC is the third component. It is only front end and host front end application for controlling the whole system to give some parameters to control the process of data saving and so on. In this picture, you can see one part of FPGA applications. This is the code that is executing on the FPGA for data collection, multiplexing, and data transfer to the next level RTOS operating system. This is the part of the front-end application. You can see some parameters that are grouped with the composition. Also, user can choose the highest harmonic taken in calculations, can choose one or all three lines in a three-phase system, three-line systems. Also, he can control some parameters of acquisition and calculations, manipulate with data, save data, and so on. I will show the part of our results because there are many tables included in the final paper, so you can see more details. Here we made some demo with 20 different nonlinear loads. There are mainly loads with the constant power consumption. This is CFL and LED lamps. And this is one part of the measurements showing standard reactive power defined and calculated with time shift method. Then Fry's reactive power or non-active power. This is the power of the first harmonic, and this is the repeated measurement for the second array of loads. The more interesting case is a variable load, like personal computer. And in this first picture, you can see the steady increase of active power and apparent power, of course, as CPU utilization of PC are increased. So this is the 10%, 20%, 30%, and so on. Increase of CPU utilization leads to increase of active and apparent power. Reactive power is almost constant for this case. Also, you can see another definition of power. This is reactive power defined with IEEE standard. This is Kimberg reactive power and Budeano's reactive power. They're virtually the same. This picture presents Budeano decompositions. We have reactive power and distortion power for Budeano decomposition. Those are Kuster's and Moore reactive, inductive and capacitive reactive powers shown in this picture. And finally, in this picture, you can see Sharon apparent power decomposition, two quantities, and Chernetsky apparent power decomposition. It has three components. So those are some results. You also can read the paper. We have in greater detail discuss all the results and give some more explanations. We used all these calculated and measured quantities as signatures for artificial neural network, and we showed that these quantities can be used as specific fingerprints for recognition of some nonlinear loads. This paper is currently in a process of reviewing, so it will be, I hope, published recently. And this is one more application of this instrument. This is instead of these conclusions, we give a prototype of a measurement and data processing system for real-time simultaneous and pound decompositions, and give some results of measurements and application of these instruments. If you have some questions, please don't hesitate to ask.
So, thank you very much for your presentation. So, are there any questions? Probably not. I think that also we have skipped a little bit more than was expected. So it is, it is seen that the topics were interesting. All of the work was, I think, very nice, and we can close this session. So to everybody, it is a pity that we cannot meet personally and discuss after lunch or after coffee, so maybe next year. So I would like to wish you a good time of the day, a nice day, and many success in your future research and works. So bye-bye to everybody.
Okay, thank you.
Bye.
Thank you, Mr. Chairman. See you next time, I hope.
Darius, ciao, ciao.
Ciao.
and you will introduce later when you will start your presentations. And please mute your microphone if you are not in charge of presentation. And even you can, I can also mute your microphone. So if I will mute you, it means that I do it for purpose, or maybe by mistake as well. So hopefully it will not be by mistake. Okay, so the time is perfect. We see us on the YouTube with a little bit of delay, I think, at least what I see. So welcome to our session 8A, and we have here 1, 2, 3, 4, 5, 6 presentations, and hopefully everything is working perfect. Once again, my name is Blodek Kulesza. I am professor at Blekinge Institute of Technology in Sweden. So I will not show you the window because the weather is very sad today, so you will not be depressed by my weather. I see that you have much more light in your windows and so on, so probably it is much better weather. Unfortunately, we are only on Zoom. We cannot meet personally, what is really a pity, because if you haven't been in Palanga, you should regret that you haven't been. It is so a lovely place. I've been several times at this conference, and I think that is really nice place. And please work on your research to submit paper next year. So hopefully we can meet in Palanga next year. So the list of presenters is already known for everyone. This is a session dedicated to automation and robotics. And I am my professor chair is in multi-sensor system and in automation. So I should be competent in your presentation, I hope. Any question? No questions. So the first presentation will be done by David Gradolewski, who is my PhD student. I must admit that we have some, let's say, we know each other at least. Okay, thank you, David. The floor is yours. Maybe not floor, but the screen is yours, please.
Thank you very much. Can you see my presentation? Good afternoon. My name is David Gradolewski, and I am a PhD student from Blekinge Institute of Technology, Karlskrona in Sweden. Today I would like to present the last result of our work. I'm the development of distributed computing real-time safety system of collaborative robot. The research work conducted under the supervision of Professor Kulesza. During the modeling and prototyping phase, also Dawid Masłowski, Damian Dziak, Bartosz Jachimczyk, Shivateja Mundulmani, and Chadran Prakash participated in the project. The model was developed in Intema and is currently under the evaluation. This research was funded by the National Center of Research and Development of Poland. And the outline of my presentation will be as follows. First, I would like to show the objectives of the research. Then I will jump to the design methodology and solution and prototyping. At the end, I will show shortly the validation and the results and follow the conclusions. Robotization is an efficient and cost-effective approach in modern factories. More and more robots and manipulators are placed in the workplace shared with the humans. Such close cooperation between humans and robots may lead to hazard situations, even to human death. The main objective of the thesis was to find a reliable
cost-effective and real-time solution of a safety system of the cobot to detect, to identify, and even to localize humans approaching the operational zone of the robot. The system reliability in the changeable surrounding environment without compromising machine productivity is crucial for this research. In this research, we use the driven design methodology to define all functionalities and constraints of the system. The design process was systemized, and each stage, both the stakeholders and the future users were involved. The design product is mostly dedicated for a medium and small sized companies where price and easy to adjust the manipulators to other tasks is crucial. The defined general and itemized functionalities are summarized in this table. We selected 7 crucial functionalities, which are safety system, object detection, detection classification, object localization, threat classification, cobot's motion control, and interfacing. To all the functionalities, we itemize and give particular constraints of each of them. To each, we try to define all the possible technologies and algorithms which can fulfill the requirements. And during the analysis, we find the most suitable one. After the analysis, we came up with the solution, which are the IoT-based distributed computing safety system. The safety system is design of the IoT concept, where users has easy access to each subsystem through the GUI. All data is stored on the previous detection and regarding the system performance on the database. The safety system is composed on sensing detection modules, decision-making system, and the robot, which all of them are connected with the internet. The data processing is decentralized, so the computer overload is reasonable. The hardware configuration of the system is presented on the left-hand side. It consists of the camera, ultrasound sensor, and stepper motor for sensing rotation. The number and the configuration of sensing detection modules depends on the customer requirements and the cobot's velocity. To cover all the surroundings, up to 6 modules are needed. The module configuration schema is presented on the right-hand side. We divide the cobot's operational area on the 3 zones. The green one is the safety zone. The yellow one is the warning zone, and the red is the dangerous. The black zone is the robot's working area where hazard situation may occur. On this slide, the flow chart of the system is presented. It consists of 2 parts, the sensing detection module and the decision-making system. The sensing detection module is the pre-processing part and will be described on the further slide. The decision-making system is working on the cropped images sent from each modules. First, the cropped images is identified and the valid and invalid detection counter is calculated. If the invalid detection counter exceeds in the certain time some threshold, we update the background frame. When the valid detection counter in certain time exceed the threshold value, we do the predefined cobot motions on the system. The sensing detection module algorithm is based on the motion detection. First, the background and the current frames are converted into grayscale. Then, to minimize the false detection of small patterns of the image, the blurring is performed. On the later stage, the absolute difference between the corresponding pixels are calculated. Next, the differential image is calculated and thresholded to reduce some artifact caused by lights. Then the cropped image
is sent to the identification process. This slide presents the system prototype with two modules. The decision-making system were implemented on the computer with the GPU. The system prototype consists of camera, ultrasound sensor, and the stepper motor. The stepper motor is used to direct the ultrasound sensor towards the detected objects. On this slide, we have the results of the image pre-processing part. The system have been tested in a real environment. 3 persons walks around the room with changing background. The cropped images were sent to the computer for further identification. We can see here also some false detections, which were further analyzed in the identification process. In the identification process, we tested 3 different algorithms, state of the art, which are Hawk, Villa-Jones, and YOLO version 3. The measured false positive detection efficiency along with the maximum latency and frame per second. The measured latency was measured as delay between the appearance of the object in the zone and its identification by the decision-making system. The frame per second allows us to evaluate the system complexity. Overall, YOLO versus 3 outperforms other algorithms in terms of detection efficiency and in terms of false positive rate. To select a suitable camera resolution and impact on the image resolution and the system latency, and FPS was estimated. We performed a 5-minute test to do this. A person walks in a room and we calculate the identified objects. And for each, we calculate the frame per second and the latency. We can see that the resolution HD meet the user requirements of latency not bigger than 200 milliseconds and the frame per second with more than 10 frames. Another test was dedicated to estimate the accuracy of the localization measurement. It is important to know how well object is localized within a particular zone. One human at the time walked in the observation area and approached market points. These points were distributed within 3 different angles of 15, 30, and 45 degrees and placed at 4 distances from 100, 220, 350, and 470 meters. For different distances, we measured the uncertainty and the standard deviation of the error. It came up that the uncertainty varies from 3% up to 20%, and this meet the user requirements. This research shows the capacity of developing the most reliable real-time safety system of cobot, which is able to detect and to localize human multi-objects approaching to the cobot's operational zone, and then providing a decision about a suitable action of the cobot's control. The systematic design approach of the user-driven design methodology facilitates a development of the system, which makes all requirements and constraints defined by future users and stakeholders. The modular construction embedded into distributed computing paradigm, basing on the self-components, ensures high detection efficiency and low costs of the system. Thank you for your attention.
Okay, thank you, David, for a nice presentation. And this is a little bit complicated now, maybe with the questions, but I think that all the presenters may have also a question. If you just have a question, just open your microphone and state your question. And the audience who are watching us at YouTube, please type your question. There is some window, is some bar, top chart, where you can type your questions. I see that we have some small delay between presentation, what I see on Zoom and on the YouTube, but I think that David also, I can read the question to him. So David, waiting for the others, I have to take my opportunity to ask you the question. And of course, you show the, how to say, lighter side of your project. So everything what was successful. What was drawback of your project? What is the drawback of your solution? If you may find it.
Maybe not the drawback, but maybe the future work. I think it would be nice to extend and to evaluate the system on the larger number of the detection models, because on this research, we tested the system on just 2 models. We still have some capacity on the server side, so to test how the system will act with the more modules connected to the server. So maybe it is the main issue of future work.
Okay. Do you have another field of implementation of similar system? If we did, because you said here it was dedicated because your stakeholder had, let's say, specific requirements, but do you see that similar system can be used, I don't know, at airports or somewhere else? Or what is your idea?
Yes, because it's when we just change the identification algorithm to the different parts, we can detect each moving object. So it's just the measure of the identification algorithm.
Okay. And this system has been already implemented, and I guess it is in production, or how does it continue with the research?
It's already implemented in my company. This project was funded by the grant from the National Center of Research and Development, and currently this product is at the last stage of the development, so it's during the evaluation and during the tests in the company.
Okay, I don't see any question written in the chart and so on, so I don't see anyone who raise a hand to ask a question. So I think that I will make all the time the individual upload, because usually we do this upload. So thank you, David, and please switch off your sharing, and we will invite now Mr. Xu Baoyang. You can introduce yourself and tell where you are from which city, and so it would be interesting to know. David, you haven't switched off your sharing, because until you will not switch off, we cannot continue. Still, David, we see your, now. Okay, Mr. Xu, are you ready?
Yes, thank you.
Please, the screen and the floor is yours, please.
Can you hear me?
Yes, I do. We do. Okay. Speak a little bit louder, maybe, but we hear you.
Okay. Good afternoon. I'm Baoyan Xu, a PhD student from China Agricultural University, and it's my honor to give a presentation here. The title of my presentation is Optimization of Threshing Quality Control Strategy based on Type 2 Fuzzy Logic Rulers.
I'll conduct my presentation from the following 6 sections. As we know, stressing is one of the most crucial functions of combat harvester. Grain loss and crashing are essential parameters to evaluate the stressing quality, but it is still tricky to control them effectively. We can see from this picture, when the ruler rotates, the stressing teeth penetrate into green crop mat in stressing cleaver. Green areas are impacted by high-speed stressing teeth with additional action like calibration, rubbing, and combing. Green kernels are detached from socket with acceleration results from impact. Then green kernels fell into opening between neighboring conical grades. Therefore, conical clearance and drum speed are the important factors affecting the loss rate and the crashing rate. But it should point out that existing literature on fuzzy control strategies do not take into account the uncertainty of environment. Consequently, it is not reasonable to use an accurate membership function for measurement data without considering the fluctuating and disturbances. These people proposed a new control strategy based on type 2 fuzzy logic controllers to improve stressing quality. The control strategy based on fuzzy idea must obtain the relationship between parameters. Therefore, in order to obtain the relationship between concave clearance, ruler speed, loss rate, and crashing rate, the basic data acquisition test is designed. The detection part of the stressing separation quality system installed on the combat harvester mainly consists of 6 parts. Crashing rate not, ruler speed not, green loss not, concave clearance not, data acquisition terminal, and computer. The field harvesting experiments was conducted at Beijing Xiaotangshan. According to national standard equipment for harvesting combat harvesters test procedure, the concave clearance was adjusted as 10 millimeters, 50 millimeters, and 20 millimeters, and the test results are shown in picture. And 2 rules can be obtained from the result. The first one, when the concave clearance is 10 millimeters, 50 millimeters, and 20 millimeters respectively, the grain crashing rate first increases and then decreases. Another one, when the concave clearance is 10 millimeters and 50 millimeters, the grain loss rate decreases with the increases of speed of the drum. But when the concave clearance is 20 millimeter, the grain loss rate decreases first and then increases. In order to improve stressing quality, 2 control strategy would be designed based on experimental data. One is low grain loss rate. The other one is low grain crash rate. In low grain loss rate control strategy, input variables are loss rate and concave clearance. Output variables is drum speed. In low grain damage rate control strategy, input variables are grain crashing rate and concave clearance. Output variables is drum speed.
Before design the control strategy, let me introduce the type 2 fuzzy logic controller briefly. In the clustering coordinate system, the type 2 fuzzy sets can be expressed as a two-dimension region, which is called the footprint of uncertainty. It's the unit of all primary memberships. The upper membership functions and the lower membership functions are the boundary of footprints of uncertainty, and can express as type 1 for these sets. Refer to this reference for detailed mathematical series of type 2 fuzzy logical controller. In low-grain crashing control strategy, one input sets damage rate. Damage rate is defined by three membership functions: ND, MD, and LD. In the interval, another input sets coin clearance. Clearance is defined by three type 2 fuzzy Gaussian membership functions: SG, MG, LG. In the interval 10 to 20. The output sets linear velocity of the stressing roller consists of 5 membership functions, which were MI, SV, MV, LV, MA in the interval 800 to 1200. Characters of the inputs and output of grain damage type 2 fuzzy logic controllers are recorded in detail in table. According to experiment data, 9 rules of grain crashing fuzzy logic controllers are established. Similar to grain crash rate control strategy, in loss rates fuzzy logical controller, loss rate set is defined by 3 membership functions, which are SL, ML, and LL in the interval 0.25 to 0.6. Consequent clearance and roller space sets are equal to grain damage control strategy respectively. Similarly, 9 rules are designed according to the experiment data. In order to test the controller, grain damage and loss rate type 1 fuzzy logical controllers are designed and compared with type 2 fuzzy logic controllers with the use of fuzzy toolbox from MATLAB. Moreover, to evaluate the response of strategy, integral of square error and integral of absolute error are used in this section. Type 1 fuzzy logic controllers and type 2 fuzzy logic controllers of grain damage are built in the fuzzy interface edits in MATLAB. When the value of coin clearance are 10 millimeters, 50 millimeters, and 20 millimeters respectively, there are always an error between the outputs and the output of fuzzy logic controllers and the fitting curve amount of account of open loop system. However, their trends are consistent, as can be seen. Integral of square error and integral of absolute error of type 2 fuzzy logic controller are less than type 1's. Those values indicate type 2 fuzzy logic controllers performance better than type 1. In order to verify the effectiveness of the control strategy, control and uncontrolled experiments are designed. In field experiments, the loading speed of the roller calculated based on the control, and the roller speed is set as the the calculated value. From the estimated result, they can be seen as the crash rate and the loss rate of the control estimate reduced to a certain extent. When the concave clearance is 10 millimeters and the speed of the roller is 900 RPM, as the loss rate and the crash rate decrease the most. And the amplitude are 44.6% and 25.26% respectively. When the concave clearance is 15 millimeters and the loss rate is 900, the reduction of loss rate is largest. And the reducing of crashing rate is the largest as 25.84%. When a concave clearance is set as 20 millimeters and rotation suit and the speed of rollers is 100, the reducing of loss rate is the largest. And the speed and the rotation speed of the rollers is 1100. The reducing of correction rate is largest. In summary, crash rate and loss rate are reduced significantly. So the stressing quality control strategy is effective. Conclusion. To design the model of type 2 fuzzy control, combat stressing quality automatic monitoring system is designed in people. On this basic, the membership function of the variables and fuzzy controllers of control strategy are proposed. For varies the response of type 2 fuzzy logic controllers, type 1 fuzzy logic controllers designed as the objects of comparate simulation experiment. The field experiment results showing that the type 2 fuzzy logic controllers give the concave clearance and the roller rates can significantly reduce loss rate, crash rate, and improve stressing quality. Thank you for your attention.
Okay, thank you, Mr. Xu, for your nice presentation. And we are still open for questions in YouTube. If anyone has any question, please type it. And also, as I said, anyone who is attending Zoom can ask the question. May I start with one question? What was the reason why you started to work with this fuzzy controller? Because there are probably hundreds of possibilities. So what was the motivation of choosing this kind of controller?
Because fuzzy logic controllers is
do you see we have some problem with that you cover your picture with some gray box? I don't know what is this, you see?
Okay.
We had this problem all the time. So you see still there are some gray squares on the top and on the right hand side.
Square.
You know that the gray boxes that you have on the top on the right of your screen. I don't know where it is from, but it is some problem. Maybe fuzzy logic is needed to rid of this. Do you see this on your screen?
My English expression is not very good.
没关系, 没关系. Continue. Okay, yes. So what is your motivation, please?
Because agricultural control is not precision controlled. So I chose the fuzzy logic control.
Okay. When you can come to your conclusions, please, on the last next to the last slide. When you at this last conclusion, you said that you gain damage rates and maximum decrease in losses. What do you compare it with? Do you compare it with this type 1, or what is the reference to this gain that you got? To regular controller, or to which kind of controller you apply this reduction and decrease and so on? So because we need to know what is a reference point of your result.
Because my English is poor.
No, mine is not the best neither, so you know, but we can communicate anyway.
What do you say? Maybe we could exchange our opinion by emails.
Okay. So I will send you some question by email, and you can explain. So we can leave it maybe somewhere on the website of the conference. Okay. Thank you, Mr. Shu. As I said, you have individual just upload. So thank you. Please switch off your sharing. And now we are going to listen the presenters from Pakistan, Ms. Rabia Taksin. Please switch on your microphone and your video and share with the screen with us. The floor and screen is yours, please.
Should I start?
Yes, please.
Assalamu alaikum. I am Rabia Taksin from University of Management and Technology, Lahore, and I am here to present my paper, Fuzzy Expert System for Earthquake Prediction in Western Himalayan Range. As we all know, earthquake prediction is a complicated task, and people have been researching on this phenomena to extract certain parameters that might be helpful for determining or predicting future earthquakes. We are also working in the same line to explore the need for the application of computational techniques provided by artificial intelligence for extraction of structured parameters from unstructured, noisy, and bulk data. We have been motivated for the application of fuzzy logic for the generation of fuzzy expert system, because fuzzy expert system allow us for the application of linguistic variables with fuzzy rules that are human understandable. These rules increase the transparency and interoperability with the data set, and furthermore, due to transparency, modifiability, comprehensibility, and coherence with previous knowledge, fuzzy expert system can be tuned, updated, and adapted if necessary, thus enhancing the degree of freedom in problem solving. Moreover,
as compared to other approaches like neural networks, which are just providing an opportunity for training data that are wholly solely based on training data set, and they are working like black boxes. Fuzzy expert system is providing interaction with the human experts that have solid knowledge of the domain and facilitate us for making earthquake predictions. Then the domain of work, actually we have worked in cross domain. Mainly our work is on fuzzy expert system, that is a branch of artificial intelligence. We have combined it with seismology. We have taken the data set from seismology and joined it with artificial intelligence and developed a fuzzy expert system for earthquake prediction. The data set we have used instrumentally recorded seismic data set obtained from USGS from last 20 years data within 100 kilometer radial area from 34.708 degree north to 72.5478 degree east. And we tried to predict the earthquakes through our fuzzy expert system with magnitude 5.5 or greater in the specified region. We have studied multiple articles before writing this paper, and some of the articles have been presented in this table. It is clear that reactor number 3, 5, and 22 have worked in Pakistani zone. Number 3 have applied image recognition techniques. They have taken images from seismographs and analyzed these images. Whereas 5 and 22 have applied back propagation and forward chaining neural networks. But our work is different from both of them because we have involved human experts. We have taken their judgment while setting our rules and developing the membership functions for the earthquake prediction. This is main methodology of our paper. We have divided the seismic data set into 2 groups. This is the first group that is presented by X. It consists of all the direct parameters, the parameters that have been directly extracted from seismic data. And then the set Y presents the derived parameters, parameters that we have applied, calculated after application of certain formulas on direct parameters. Then these 2 sets are interlinked with each other. They do overlap with each other because some of the parameters, because it is very difficult to define which parameter will belong with which set. So the founder of Fuzzy Logic, ZD, has helped us in this regard. If the membership value 1, membership function gets the parameter, gets the weight factor 1, then it will be belonging to the same set. And if its value is 0, then it do not belong to the set. And if the value is intermediate, then it may belong to the same set. On the basis of this rule, we have divided our data into 2 sets, X and Y, and then we sent these 2 parameters as input value to our NFIS, Adopted Neuro Fuzzy Inference System. In the layer 1, that is fuzzification layer, all the variables that are coming from outside, the crisp variables, has been converted into fuzzy variables on the layer 1 so that they may process according to our rules. Then they go to the layer 2 where fuzzification and is done. Actually here rules are being applied. The rules that have been set by the expert's opinion, they are applied on fuzzy and layer. And then the normalization layer. In the normalization layer, we have applied the function that we have developed on the basis of layer 2 results. After applying these functions, we multiplied it with the weight assigned to every result. The weight factor has been calculated using the product function of all the linguistic tags with the results that has been generated by layer 3. After that, defuzzification has been done for the extraction of predictions about earthquakes, about the future earthquakes. The defuzzification function has been applied using centroid method. Through centroid method, it usually determines the values that will be most prominent while determining the earthquakes. This is the data analysis screen, which shows we have extracted the data from last 20 years and this is seismic energy, cumulative seismic energy that is being accumulated underground. This is the analysis of seismic data, and we have determined that in year 2004 to 2005, the energy is getting accumulated underground, and it is not being released over the ground.
That's why this circle is representing seismic quiescence period. Again, from 2014 to 2015, we again had seismic quiescence period. It means seismic energy is gathering underground and it is not coming out. So in 2005, we had a catastrophic earthquake in Pakistan. And again in 2015, we again had a major earthquake of magnitude 7.5 in Pakistan. The figure B present 5-year microseismicity pattern. From the same data, we have extracted 5-year pattern to show that microseismic events stopped occurring immediately before the occurrence of 2005 event. You can see here the rapid slope that is coming down towards zero, which shows that the occurrence of micro earthquakes that usually occur before a major earthquake has almost narrowed down. And then suddenly earthquake of 7.8 in year 2005 has encountered in Hazara region. We have simulated our fuzzy expert system using MATLAB. Here from these images is a figure A presents that energy gathering underground and the energy release is very low since the long time has passed. So expected magnitude would be higher. More magnitude could be expected here. More magnitude is expected here. And figure B presents that if the earthquake has low depth, if depth is near zero, then it will cause more rupture due to major with the major magnitude. The magnitude that will affect the earth will be high. And then the figure C presents if depth is narrow. If long time has escaped and no earthquake has occurred, then earthquake with narrow depth, that is like 10 meters below the earth or 15 kilometers below the earth, and then expected magnitude would be higher. We have implemented simulated it in MATLAB. These are the results of our method. We have trained our model using seismic data that are of true seismic data and the training data. We have added them in the true responses and predicted results. Both are added in model 1.1. And in second figure, it is presented that we have found matching values like the actual earthquake that have occurred and the earthquake that we have predicted. And it is being shown that 47% of our predicted earthquakes on the historical data have been correctly predicted. So our model is capable of predicting about 47% of earthquakes accurately from historic data. Conclusion. In this research, we have presented fuzzy expert system for earthquake prediction. We have extracted multiple parameters from the data set that have been passed to fuzzy expert system as input. Multiple rules and membership functions described by human expert have been applied. We validated the data using MATLAB. We have generated the model. The model has given us 47% of accuracy. And in future, we intend to apply machine learning on the same data set for improvement of our accuracy so that we may gain 60% or 70% of accuracy. Thank you.
Okay. Thank you very much, Ms. Rabia, for your nice presentation. And this is a very interesting topic, at least application field, of course. And so waiting for some questions maybe from audience and others. Let me ask maybe some simple questions, because when you said that your reliability of your system is 47%, this is what you said. Did you compare it with the other systems? Because I guess, you know, this is probably very hot topic everywhere. And so what is the best of the best now on the market in this area? What is the reliability of the best?
Yes, sir, very good question. Actually, sir, when we use training data, when we overfit our training model, then we can get 100% accuracy. we can get it, but it is because of overfitting. If we control overfitting and make real predictions, then prediction rate got down to 67% or 68, maximum 68% have been predicted using neural network models. But neural network do not involve humans. They simply take data set, they pass it from the model, and the predictions are made. They do not give importance to human knowledge, whereas expert system is a field that has severe impact because it is everything is going on underground, and we have to focus on all the parameters that we cannot see, like weather forecast, everything we can see, but we cannot see under the ground. That's why we are getting low accuracy. But getting 68% accuracy using neural network and machine learning model is a good one. We need to improve accuracy because our accuracy is 47%, but we have taken data from only one aspect, that is seismic aspect. But if we get data of the same region from multiple aspects, then accuracy will be improved. Like if we get reservoir data, we get climate data, we get temperature data, ionosphere data, then the accuracy will be improved definitely.
Okay. I hear that someone put the question on the YouTube, maybe. Where is this? Do you see any question? No, I see just for okay. Do you see YouTube as well? Because I cannot recognize any question here. Darius has informed me that there is some question, but I don't see exactly which one is this. Okay, maybe I will recognize it later. But the next question would be, because you showed that you divided this data set into sets, X and Y. And you said that the Y was created by some equations from the measures that you get. I don't get how did you created this Y set? So you know which equations to use, because you said that you use some mathematical, let's say, relationship between this measure, and you created this input Y to fascination.
Very good question, sir. Sir, actually, we have divided our data set into two groups. One is X and other is Y set. We have divided it into direct parameters and derived parameters. When we get data from regarding seismicity, seismic data, when we get magnitude, longitude value, latitude value, its depth, the area that has been affected from it. These parameters are called, these are the direct parameters that have been obtained from data. And then we have applied formulas. We have defined formulas for the calculation of rupture length, for the calculation of B value maybe. We applied these formulas that are defined by seismology for the determination of derived parameters that are passed to fuzzy expert system as Y. And after that, giving this input, we applied mathematical formulas to generate fuzzy functions. Fuzzy rules has been explained by human expert, and on mathematics, we have applied mathematics for generation of membership functions. Set X and set Y has been discriminated using seismic data. Seismic set X, the set X has already been obtained from the direct parameters that are directly described in seismic data set.
Okay, I see some comments from the YouTube. First of all, someone is proud of you. Rahan Hasim said or wrote that is proud of you, if you don't see. But I see the question from Prakash Chandran. The question is to Rabia, what technique is used to validate your MR fuzzy model, and what is the accuracy?
Our accuracy is 47%, and we have used 5-fold validation technique while developing our model, like I have seen in this stage. Prediction model 1 has been developed using cross-fault validation technique, in which we have calculated the mean square error and absolute error, and our error rate was 0.21. at that time when we trained the data and obtained accuracy of 47%.
We have another question even, a part of the upload, that nice presentation. And the question is, did you consider or will you consider evaluating with time series forecasting models like LSTM or RNN?
Actually, not in this paper, but the next article that we are writing right now, we have applied time series in that model. In that article, we have extracted data from multiple sources, and we are applying time series on that so that we can make real-time predictions. We are working on that, but in this paper, we have not worked on real-time data.
Okay. So thank you. It was nice that we got the questions from the audience on. It means that your presentation really created some interest in our audience. So thank you very much, and individual applaud for you. Thank you very much. And now we are moving to the next presentation. And the next presentation is going to be done by Mr. Mehmet Latif Levent. Could you please switch on your
I am
camera?
here.
Okay, nice, nice to hear you. That's still waiting patiently for us. So please start your presentation with sharing your screen, and the floor is yours, please.
Hi, thank you for your kind introduction. I am here today to introduce our new research. Let me introduce myself and my team. I am working as a research assistant at the Hakkari University in Turkey, and Ömer Aydoğdu, my mentor, works as a professor doctor at Konya Technical University. My talk is particularly relevant to the adaptation mechanism as a new approach. The title is State Estimation with Reduced Order Observer and Adaptive Linear Quadratic Regulator Control of Time Varying Linear System. I have divided my presentation into 7 parts. In the first part, I give an overview in introduction, and this next section I will explain modeling of variable loaded servo system as planned as system. In part 3, I am going to show state estimation, and then I will explain proposed method. In the last part, I would like to give simulation results and conclusion. First of all, I talk about an overview in introduction. In this study, a new controller design was created to increase to control performance of a variable loaded time varying linear system. For this purpose, a state estimation with reduced order observer and adaptive linear quadratic regulator control structure was offered. Initially, to estimate states of the system, reduced order observer was designed and used with linear quadratic regulator control method. That is one of the optimal control techniques in the servo system with initial loop. Subsequently, a Lyapunov-based adaptation mechanism was added to linear quadratic regulator control to provide optimal control for varying loads as a new approach in design. Thus, it was aimed to eliminate the variable load effects and to increase the stability of the system. In order to demonstrate the effectiveness of proposed method, a variable loaded rotary servo system was modeled as a time-varying linear system and used in simulation in MATLAB Simulink environment. Based on the simulation results and performance measurements, it was observed that the proposed method increases the system performance and stability by minimizing
variable load effect. In this second section, I explain modeling of the variable loaded servo system as planned as our system. As seen in this figure, a rotary servo system that can alter the load in time was used in the experiments. In industrial applications, permanent magnet DC motors are widely used as an actuator for electromechanical energy conversion. It directly provides the rotary motion or moment and can provide transitional motion or force when coupled with wheels or drums and cables. The variable loaded servo system actuated with a permanent magnet motor, which has the electric circuit of the armature, and the variable loaded body diagram of rotor are shown in this figure. Permanent magnet motors, which are frequently preferred since they are easily controlled, have been widely used in recent years. These motors have important features such as having no use for excitation current, quite low energy consumption owing to the field fluxes they produce, and low cost owing to their small size compared to the other motors. In industrial applications, the high performance and stable functioning of the system are two very important criteria. In order to meet these criteria, many different approaches have been used in the literature, such as proportional integral derivative control method, sliding mode control, field programmable gate array control, adaptive control, fuzzy logic controller method, and reduced order nonlinear observer. Now I am going to show state estimation. Accurately estimating all the unmeasurable states of the system is an important factor that influences the functioning of the plant in high performance and stability. There are two important methods in state estimation called as observer and Kalman filter. In this study, we used reduced order observer. The full order observer method is applied to estimate all the states in the controller designs, and the reduced order observer method is applied to estimate unmeasurable states. This control structure is used in particular induction motor control, sensorless electric drives, permanent magnet, synchronous motors, linear time delay systems, aircraft motion control, and multi-agent system. Reduced order observer structures are commonly used for system design that provide ease of operation by reducing degree of observer. We can show state estimation with reduced order observer block diagram. The reduced order observer equation is given, and the block diagram that is fit for this equation is represented in this figure. Yes, state estimation. Now I will explain proposed methods. The proposed control structure in this study is given figure in this figure. And actually, the optimal feedback gain matrix value for linear quadratic regulator were obtained from the Riccati equation for initial load. We can see block Riccati solution for initial load, and then therefore, optimal control is not provided with these gain parameters when the load change. When Lipman stability creditation-based adaptation mechanism, as shown, is added to the system, the state feedback gain matrix value will change adaptively, adapt to environmental condition in variable load situation. A Lipman-based adaptive mechanism
was added to linear quadratic regulator control to provide optimal control for varying load as a new approach in design. We can see Lipno-based adaptive mechanism as a new approach. This figure shows the block diagram of the Lipno-based adaptation mechanism as seen previous section. Lipno-based adaptive mechanism, and the reference signal states that are estimated by reduced order observer x1, x2, x3 reference signal, and linear quadratic regulator output. We can see A1, A2, A3. These parameters are defined as inputs in this related block. In this system, different adaptation blocks for the state that are position, speed, and current x1, x2, x3 are designed. The first block provides position control. We can see first adaptive Lipno stability criteria 1 is position control. Second block provides speed control, and the third block provides adaptation for the current control. In this regard, the purpose of the research is to perform a new adaptive algorithm that ensures optimal state feedback of the system on variable loads. In the last part, I would like to give simulation results and conclusion. When adaptive linear quadratic regulator and reduced order observer with linear quadratic regulator control methods are applied in the system, the results for unvarying system are shown in this figure. We can see red line reference signal, black line reduced order observer with linear quadratic regulator, and a blue one adaptive linear quadratic regulator. Examining the error change shown in this figure, it is concluded that position output signal rapidly catches the reference signal, as is shown in table 2. Comparing the results based on their performance measurements, it is understood that the proposed system produced better results and has a high performance. The response of adaptive linear quadratic regulator and other control methods are given in this figure, and effects of the variable load that occurred after 21 seconds on the response curve of the system is shown in second figure clearly. We can see proposed methods catch the reference rapidly. Also, change of the feedback gain matrix value is given in this figure. Here it is observed that the gain matrix value changes in accordance with the environmental condition and rapidly minimizes the load effect, and we can zoom error after the 21 seconds and gain matrix value change in accordance with the environmental condition and rapidly minimize load effect. Conclusion: the designed new control system with a linear quadratic regulator and reduced order observer is based on adaptive state feedback control that compensates the disruptive effects such as variable load and increases the system performance. This controller structure was successfully used in trajectory control of a servo system that can change the load over time in simulation. As is known, it is not possible to completely remove the disruptive effects. The system can estimate the states of the variable loaded servo system.
thus the disruptive effects can be minimized. A stable system design that can comply with the environmental condition was prepared. It is observed on the simulations result that the proposed control method gives quite good results in controlling the system that are exposed to adverse effects like the variable load. The error between system output response and reference input signal was minimized in time. It is understood from the system results that the system control parameters can adapt itself in time. Thank you.
Okay, thank you very much for your nice presentation. And as usually, one of my duties is to make you busy with the question, and we are waiting still for questions on YouTube. Please, anyone who is watching us, please type your question if you have any, because it will be nice for me and for presenters to see such questions. My question would be more about applicability of your very nice research, because automation is the applicable science. So do you see any case study? Because I think that the next step of your research should be to verify your system on some process, on some devices and so on. So do you have any experience which system or which company would buy it and implement it on their systems, please?
Yes. It is, for example, control of permanent magnets, synchronous motor, and motor speed control, but in future, especially in more robotic application, for example, arm of robot or trajectory of control, and in a space application, it will be applicable personally.
Mm-hmm. Do you have any cooperation with a company that would be interested in this one? Because I think that, as engineers, we enjoy really that work, that's our work is implemented and it shows some.
There are a lot of implementation when I study in this work. For example, in fuzzy system, DC motor application, I study in DC motor and I research DC motor in literature. A lot of application was shown, and robotic application, space application, and there are a lot of, but especially I researched this part of study.
I think that I see one question from MJ, and I guess that is to you. First of all, he said that it was interesting and asked any future scope idea about this development of the system, I guess,
Feature.
Yes. Some new future scope ideas, what it could be, because you know what you've done, but you should know what would be later.
In the there are a lot of works about this study, but personally in the future, especially in the space application, for example, trajectory or control in space, it will be applied, and especially in the future for more stable and more good performance in robotic application. It will be applied because this state estimation with reduced order observer and adaptive linear quadratic regulator control, especially is applicable on varying linear system. So it will be applicable in the future personally.
Okay, thank you very much. And I think that even big guys like to appreciation or applaud. So thank you for your presentation. And
Thanks,
now we move to the next presentation, which will be probably done from Beijing. And this presentation will be done by Mr. Wang Yu Xiang. Are you still patiently waiting for your turn, Mr. Wang?
Yeah.
Okay, very nice. Yes, I
Okay.
hear and even I see you and smiling. So it looks that you are happy to be with us. So the floor is yours, please.
Okay. Could you see my PowerPoint? Okay. Okay. Good. Good afternoon,
but we
everyone.
still see some black. Please close all your applications because someone wrote that what we see it is that you open too many applications. You have to switch off all applications to read of these black boxes, please.
Okay.
So just leave this one application that you use and all others should be just switch off, please. Or many applications. We still see at least 3 or 4 applications open on your screen.
But yeah. In my screen, there is only the PowerPoint.
No, but we see, so you have to close the applications, please. We see it. Okay. I don't know how, but you can see it on your YouTube. If you see YouTube, you can see that what is the problem.
Okay, wait for a moment. This time, could you see my PowerPoint without the applications?
Now I see without applications, but we can see if there is also change in YouTube, because it's better to make this improvement now. Still, I see the applications. So close all applications. It will probably.
Yeah. I have closed my all of my applications except the PowerPoint.
But I see still them on the Zoom. Do you see on Zoom? This, you must see the same as what we do.
Okay, I will close this.
So you probably must have more applications. Yeah, close all of them.
Okay, I am doing.
Yes.
Closing.
Even if you write some comments to your sweetheart, she can wait for it.
Okay, this time I have closed.
Now it's probably working. Yes, just go ahead. Okay, good luck.
Just a PowerPoint?
Still one box is open. One application is.
Oh my gosh.
Now 2.
Now 2. Let me look. This time.
Yes, and one in the right upper corner.
Oh, I don't know what's wrong. So I will. I will restart this sharing.
Okay, restart it. Okay, we are waiting.
Okay. Okay, this time there is something wrong.
No, we still waiting. Still there is one black box.
Oh my God. Let me close. How about now?
Still, I see one. But maybe when you open the full screen, maybe it will disappear. Just open the full screen presentation.
Okay, I have opened the full screen presentation.
Not yet. No.
Not yet?
Still we have but a small problem. Okay.
Okay, I will start my presentation. Good afternoon, everyone. My name is Yuxiang Wang, coming from Beijing Key Laboratory of Optimized Design for Modern Agricultural Equipment. colleague of engineering in China Agricultural University. Today, the topic of my presentation is a mathematical model and the analysis of the crossing rate of compact harvesters. And my introduction will cover the following 6 aspects. First of all, let's look at background. Our research is based on field experiments, and the experimental location is in Weifang, Shandong Province, China. Shandong Province is the main area of wheat cultivation in China. During the harvesting season, compact harvesters such as GM18 produced by the Lovo company are the main harvesting machines. Lovo is one of the major compact harvesters manufacturers in China. Our research aimed at GM18, a semi-automatic longitudinal axial flow threshing compact harvester. As all we know, the crossing rate is an important index that farmers focus on and is the core competency of compact harvest. And the compact harvester is a complicated system. Crossing rate could be affected by multiple factors, such as crop status, operation parameters, working conditions, and so on. Also, crossing rate is a key parameter to evaluate harvesting quality. In order to ensure the harvesting quality and efficiency, the operator will frequently adjust speed, stubble height, and some other operating parameters of harvest manning based on their experience. It requires a vast experience of field harvesting and takes high labor intensity. Meanwhile, it's difficult for compact harvesters to keep the best working performance all the time. Therefore, identifying the effective intensity of each factor and obtaining the best combination will have great meaning for actual production. For example, our research could provide a reference for guiding field operation, which aims at improving compact harvesters' performance while reducing labor intensity. Also, the result of our research may guide designers modify their next generation compact harvesters. Our objectives of this paper is aimed at identifying the complex factors affecting crushing rate. Also, a mathematical model of the crushing rate was established through 4-factor and 3-level field experiments in this paper. The optimal operation parameters of compact harvesters were identified through range and variance analysis. Next, I will analyze various factors affecting the crushing rate in detail. First, let's look at the failure rate. The failure rate reflects the performance of the harvest. In general, a larger failure rate means stronger handling capacity and higher working efficiency. And multiple factors such as the density of grain and the cutting range and so on will affect failure rates. And in our experiment, we made some assumptions in order to control some variables. We saw that the density of grain will have small changes in the same group of experiments because the groups grow uniformly. And in our experiment, the cutting range didn't change because we always did full harvest. At the same time, during harvesting, cutter height maintained at a defined height. So the stubble height was almost the same. The only adjustable variable is operation speed, which can be easily controlled by drivers. In our experiment, we set 3 levels for failure rate, 4, 6, 8 kilometers per hour. Secondly, we controlled the rotating speed of threshing cylinder. According to previous research by Lin Henliao, the high rotating speed with threshing cylinder would cause strong heating force to the grain. Therefore, the grain is easy to be broken, which will cause high crossing rate. However, if the rotating speed is set to low, the increment loss rate will increase. As a result, we also set 3 levels for rotating speed of threshing cylinder, 900, 1000, and 1100 revolutions per minute. The third affecting factor is the moisture content of grain. If the moisture content of grain is high, then low hardness and poor performance of resisting impact will lead to high crossing rate. But if the grain is too dry poor toughness of the grain. No strength and poor impact will bring more broken grain. In this paper, experiments were carried out in the morning, noon, and earlier evening. The three levels of grain moisture content were 15.1%, 13.26%, and 14.4%. The last affecting factor we studied is concave clearance. According to relevant research, when the gap between concave planes increase, it will be beneficial to flow of crops and penetration of grains through the crop layer. Thus, crossing rate and entrainment loss will decrease. According to operators' experience, three levels of concave plant gaps are selected to match the three-sling cylinder speed, 10, 15, and 20 millimeters. The third part I want to talk about is experiment. Firstly, we designed a data collection system. Figure 1 and Figure 2 show the structure and the schematic diagram of this data collection system. The system is mainly composed of sensors, data collection system, data storage model, and analysis unit. On the combat harvesters, Hall sensors and the torque speed sensors are installed to measure the rotating speed of three-sling cylinder. The GPS model can obtain the forward speed of the harvester in real time. CAN controller was used to collect sensor signals and to transfer analog signals into CAN message. Those messages will be immediately transmitted to computer for data storage and analysis. And for moisture of grain measurement, we used a grain moisture tester to do this job. Figure 2 mainly shows three parts of our system and the process of signal conversion. Before the field experiments, crop density needed to be sampled. And according to the China's national standard for measure methods, 5 points were chosen for sampling. And this process was displayed in those pictures, like this. As a result, in this experiment, average crop density of the 5 sampling points was 1.7 kilometers per square meter. Also, the moisture of collected grain was measured and recorded by a grain moisture tester. In each experiment, the combat harvesters worked along a straight line, which was 17 meters. And the data generated at the beginning 20 meters would not be used because the state of combat harvester didn't get stable. Only when running at a constant speed, the data collection system would like to record the related parameters. The distance of data collection was 50 meters. Figure 4 shows the process. After each experiment, we would climb to the granary to collect grains in order to calculate the crossing rate. There is a video shows the full process of our experiment. The last part of our experiment is to calculate the crossing rate. According to China's national standard rules for agricultural sales testing sampling, the crossing rate was calculated by quadruple method. Firstly, we would spread the collected weight evenly on the board. Secondly, divide this weight into 4 parts. Then samples in 2 opposite triangles were further divided by the above method until the weight of the sample was close to 1,000 grams. At last, the crushed grains were screened out by experienced researchers as shown in this figure and weighted by an electronic scale. Then I would like to introduce the range and the variance analysis. Table 2 shows the orthogonal table with 4 factors and 3 levels designed for this experiment. For each experiment, in order to eliminate the influence of test errors on data, we repeat 3 times and then calculate the average value as the final result. Totally, we did 27 experiments, and 9 groups of test data were obtained. The experimental results are shown in table 3. We use A to represent moisture content of grain, B for rotating speed of cylinder, C for operation speed, and D for concave clearance. In order to determine the influence degree of each factor on the crossing rate, we did ridge analysis. As table 4 shows, the value of R was calculated. The larger value is, the greater influence of this factor on the crossing rate is. So we could see the moisture content of grain and the rotating speed of cylinder have almost the same significant impact on the crossing rate. Then followed by operation speed, which reflects speed rate. And the concave clearance have less impact on the crossing rate. At the same time, variance analysis also confirms this result. According to the result of ridge analysis, we could determine the optimal scheme. For factor A, we choose level 3, which the value of Ki is the smallest. So the optimal scheme determined with the same method is A3, B1, C2, D2. In other words, the moisture content of grain is 14.4%, and the rotating speed of cylinder is 900 revolutions per minute. Operation speed is 6 kilometers per hour, and the concave clearance is 15 millimeters. The performance of compact harvesters will be better when GM18 runs in this condition. In order to qualitatively analyze the relationship between those parameters and the crossing rate, the multiple regression method is used to establish the crossing rate model. Since the grain moisture content has a great influence on the crossing rate, so the crossing rate and the cylinder rotating speed are fitted separately under the same moisture content. After removing the abnormal data, the fitting results are as shown in this figure. Table 6 shows the regression equation of cylinder rotating speed and the crossing rate. The last part is the conclusion and the expectation. Through this experiment, we can determine the optimal control parameters for GM18 compact harvester, and we think that orthogonal experiments with more levels could be designed to explore more exact mathematical models. Meanwhile, every year we will continuously collect data to establish a prediction model to estimate yield. Also, through our research, we believe that we will promote the development of compact harvester in China. Yeah, that's all my presentation. Thank you for listening.
Okay, thank you, Mr. Wang, for your presentation. Unfortunately, we are very short in time because I afraid that organizer will punish me if I will not finish in time. So I would appreciate if anyone has any question, please type it in the YouTube, and Mr. Wang will answer your inquiries. I see just that Dong Xiaowei, he or she very impressive by your presentation, so you can read it in the YouTube. So sorry, no question because we are a little bit over time. But if anyone would have a question, we'll send it by typing in YouTube. Thank you, Mr. Wang. Thank you.
Okay, thank you.
Thank you. Take care. So okay. I see that thank you. I see that we have a missing ship. So because Mr. Muazzamil Ali has shown up apparently, and he catch the train of the presentation. Mr. Muazzamil, are you present? Please switch on your camera and show up, please. Are you ready for your presentation?
Yeah, decision to open my video. I can't open my video.
You have to share the screen with us, please.
Okay, no problem.
Because we don't see your camera, we don't see your face. maybe I open.
Can you hear me now?
Yeah, I hear you, but I don't see your face. So please open your camera as well.
I'm trying to open my camera, but I haven't permission.
No, you may have it. Allow.
You cannot
to start
your video because, yeah.
Okay. Oh, now okay. We see you. We have seen you before because you appear for a while on the screen and so on. So you know, we are a little bit short in time. So I hope that you will manage it in required time. Okay. Good luck.
I hope that.
Thank you.
Okay. Thank you, Mr. Hello, everybody. My name is Muzammil Tijani Muhammad Ali. I'm a PhD student at Konya Technical University in Turkey. Today, I introduce my paper that titled as Phasologic.
Oh my God.
Excuse me? Can you hear me? Can you hear me?
We do. It was someone else, you know, just continue, please.
Okay. I will first introduce the traffic control system and its importance, and then I will move to the proposed method that included how we can calculate the cycle time split, providing coordination between intersection, adjusting the green time, and then we discuss the simulation and scenario step, and conclude my discussion by the obtained result and conclusion. The traffic control is considered one of the typical complex system due to its non-linearity, stochastic, time variant, and so on. It's a method to managing a conflicting mixed movement vehicle, motorcycle, that using shared infrastructure. There is a lot of work done in literature, but most of them no use a non-cyclic strategy. That means there is no green time allocated to every phase within each cycle. This can be lead to unpredictable long time, at least at the side road. To overcome this drawback, we propose a cyclic method that assigns a green signal for all phases during each cycle. To do this, we use the Webster to calculate the optimal cycle, and then use fuzzy logic to control or to monitor the traffic situation. For calculation of the cycle, we use the modified Webster version that depends on the critical lane flow, which is represented by Y here. And then we split the calculated cycle time to each phase by using this equation. The optimal cycle minus lost time minus the dedicated minimum green time of each phase, multiplied by the number of the phase. Here we calculate the portion of the green time, and then calculate at the last the total green time that apply for each phase. How we can provide coordination between intersection? We are proposing two modes of the phase. We can select one mode at each time or at each cycle. Mode 1 or mode 2. Mode 1 consists of phase 1, phase 2, phase 3, and phase 4. Mode 2 consists of phase 2, 3, and 4 is the same, and for phase 5 and 6 for arterial. For arterial, we use this combination of phase. The problem is dedicated as a combination problem. For this reason, we use two modes, and combination of these two modes is 46 combination. there is a restriction. For example, there is no problem if we use phase 1, phase 2, followed by phase 3, phase 4, or followed by phase 4 and for phase 3, because phase 3 and 4 is not coordinated phase for our proposed arterial. Here we, at the beginning of each cycle, we can calculate the distance or the time difference between each combination of the phases. This time difference can be calculated by using P and V. P is the phase difference, the remaining time of the phase, and D is the remaining time of the ice phase to be green, and the V is the remaining time of the head vehicle departed from neighbor intersection to reach the stop line of the ice phase. Our proposed system is work as in the flow chart. First, we are set the green time for all phases. Start by phase 1 for the first, and then we read from the detector the situation of the traffic. For the reduce the computational power, we start to observe the phase after this time, and this adjusts the phase using fuzzy logic. If the time is less than 15 minutes, can we use the fuzzy logic to observe the phase, or is the max than or further than 15? We come here to check the green time of current phase. If it's 0, this means the phase is finished or not. This phase is not finished, we continue. If phase is finished, we check the cycle time is finished. There is a new cycle that we can use modified Webster to calculate, and then calculate the split and reorder the phase to coordinate the arterial road. Here we use the fuzzy logic that contain of the 3 input and 1 output. 3 input is named at remaining queue length, passing rate, and remaining time of green current and of current green phase. And the 1 output is denoted by extended, no change, and decrease. This is our proposed membership of 3 inputs. The first input have a 3 membership function, and the second have a 2 or have a 3 input membership function. This is the third input, and our output is no change. This means no decrease or increase. If we need to increase, we use the positive value or the negative value to decrease. This is a sample of a fuzzy rule that proposes it. If, for example, if the remaining queue length is short and the remaining time of the current green phase is short and the passing rate is 0, then the extent no change decrease is negative max. Negative max means there is a little cars and it is far from the stop line. For this, we need to decrease the current green time by the maximum negative number. This is our proposed arterial consists of 2 intersections, intersection A and intersection B. This characters represent the flow of the main direction of the arterial. F1 and F4 is the main flow of the main direction of the arterial. This value is illustrated in the negative in the next table. This value represented here. We produce a 3 hours flow. Each of the different flows that to represent the adaptive nature of the traffic signal. We use some restrictions to perform the simulation. Here we use the maximum vehicle speed is 50 kilometers per hour. Lost time is 3 seconds. The travel time between two intersections A and B is said to be 32. This is corresponding to the link between two intersections, that is 400 meters with 50 kilometers per hour. We compare our result with a non-optimized fixed time. For this reason, we use the mode 2 combination. That's it. The value of the phase 1 and 2, phase 3, 4, 5, and 6 as 20 seconds, 45 seconds, and 15 seconds. For the back pressure, we use the back pressure, capacity aware back pressure. For this reason, we use the capacity of the road. For this reason, we use the default value of 5 meters of a vehicle and 2.5 meters of the headway gap between two vehicles. Using this, we calculate the capacity of each road. We perform the 3-hour simulation. During this simulation, the number of 14,761 vehicles were passed during this interval. The obtained simulation result, we use the 4 performance measurement index for a fixed time, cyclic back pressure. We use isolated fuzzy logic base and coordinated fuzzy logic base. From the waiting time, we obtain the 77.06 for a fixed time, while for a coordinated, we obtained 50.70 seconds with a standard deviation that is corresponding to each method. For every travel time, we obtain for a fixed time with its fuzzy, with its standard deviation. This is the obtained result for the travel speed along the arterial road. Here we represent the Q links or accumulated Q link at intersection A and at intersection B. For a coordinated fuzzy logic base. The maximum value here is less than the 120, and for the isolated fuzzy, the value is slightly more compared to our proposed coordinated method. Here, the total Q length of a cyclic back pressure, here is the value is near to 120, and for a fixed time is the worst one. As a conclusion, a decentralized adaptive signal control strategy based on fuzzy logic and modified Webster optimal cycle formula is proposed. To maintain coordination between successive intersections, the information such as traffic demand, coordination phase, remaining time, and Q length are exchanged between local and neighbor intersection. In this work, we attempt to coordinate between two intersections through the reordering of the phase sequence to adjust the offset. The performance enhancement, for example, in average waiting time is about 34% and 16% with compared to the fixed time and bad pressure, respectively, our proposal. To accomplish good result, we recommended that the mathematical model to calculation the speed of the vehicle based on the existing density of the road must be used instead of the fixed travel time where I use it here. Thank you.
Thank you very much for your presentation. Unfortunately, I see some advantage of this online conference because organizer cannot kill me. That is too much delay. But I hope.
I trying to manage.
No, it's not your fault because it was my fault. I was responsible to keep time, so you don't take it on my. So unfortunately, I think that we cannot have too much time for questions. I just tell you that in Sweden we have everywhere the sensors that help to control the traffic as well. So I see Darius is already present on the screen. Do you want to see something, or because I propose that every participant open your let's say video, that we can see all beautiful faces and even those less beautiful. And we just salute organizer. I think, Darius, that it was great opportunity to have this presentation online. So I think that we should applaud Muzamil as well, but you as organizers as well. So please, everyone.
I think, yes, we can applaud to all of us.
Yes, please. Participants. And sorry for the problem that we couldn't be with you today.
Yeah, it's a pity, but we will see how it's going next time.
But we see anyway our. Okay, do you have
so thank you all presenters, Mr. Chairman as well, and hope to see you next times, maybe in Palanga.
Thank you very much. Take care. Bye.
Thank you.
Bye.
Bye-bye.
2:30, we shall wait for the proper time before we actually begin the session. I'm still waiting, or we are still waiting for the two missing presenters. As far as I can see, it should be the 5th and the 6th presenter of this session, but in total we have 7 papers scheduled for this afternoon. As I can see, it's already 2:30 local time, or 3:30 Lithuanian time. So let me welcome you here at the session 9A. My name is Jaromír Hrad, as you can see in the description of my picture, I hope. And I'm coming from Czech Technical University in Prague, Faculty of Electrical Engineering. I have the honor to chair the session today. And as you know, it shall be focused on electricity and electrical engineering, renewable energy sources, and similar topics that are related to this area. As for the time scope, we have 7 presentations per 90 minutes. So typical length of your presentations shall not exceed 10 minutes, please. Be so kind, try to keep this time limit of 10 minutes, and possibly we can have some short discussion after every single presentation, let's say 2 or 3 minutes as the most, and we will see at the end if there is some time remaining so that we can discuss something in more detail. Well, I'm also going to be polite with you, and since I really am not sure how to pronounce most of the names of the presenters, I'd like to ask you to introduce yourself, including your affiliation and possibly any other details that may be of interest for the audience. So I'm just going to introduce the title of the paper, and please be so kind and introduce yourself. Although I know who is going to present each paper, I simply don't want to mutilate your names. Thank you. As for the technical details, you know that it is necessary to unmute your microphone before entering the presentation and the discussion. So please be sure that you have your microphone unmuted. I'll stay unmuted also for a while at the beginning of the presentation to make sure that you can get my feedback if something goes wrong. And I will then mute my microphone so that I don't disturb you. At the end of the presentation, as you could see in your instructions, it is necessary to stop sharing of your presentation so that the other presenters can continue and take the floor. So I hope that these technical details are clear. So since the time is limited, let me open the session, the technical program, and the first presentation, which is already prepared on the screen, shall be, as you can see, on a new protection philosophy for smart distribution networks. It's from Turkey, so please, the floor is yours, and we are waiting and looking forward to your message.
Okay, thank you, Mr. Chairman. Can you hear me?
Yes, it's okay, so please go ahead.
Okay, thank you all of you for attending my presentation. I am Abdul Fattah from Istanbul Sabahattin Zai University, working as assistant professor. Originally, I am Ethiopian. I am working on smart grid. Specifically, I am specialized on smart grid protection. So I am going to present you my research work on a new protection philosophy for smart distribution network. The outline of my presentation will be, I briefly introduce what smart grid is, and I will focus on technical challenge introduced due to requirement of smart grid and specifically due to the integration of distributed generations. I will directly pass to the proposed method, which is adaptive technique actually, and I will suggest the implementation technique, and finally I will discuss the verification of the proposed method, and I will conclude my presentation. Smart grid, the need arises due to the environmental and other technical challenges like reliability. So in the last few decades, a lot of distributed energy resources are integrated into the grid. most of these integrations happen into distribution networks. So the structure of the power grid is changed from radial energy transmission to bidirectional energy transmission, but the infrastructure is no more changed compared to the other technologies like information communication technology. And this integration of distributed generations and other further requirements, they motivated the development of the smart grid, which is the energy infrastructure with bidirectional flow of energy. The energy flows both from the source side as well as from the load side. And the ICT, the information communication technology, with its actually prevalent challenges. The ICT is already more developed sector compared to the power sector. So by doing so, the smart grid is intended to increase the safety, reliability, efficiency, the economic value, and environmentally clean use of the power grid. So this is the main idea of the smart grid. But compared to the other sectors, it's old sector, as I told you, and the structures of the grid are not ready for this modification, especially the smart distribution network. It's faced with a huge challenge compared with DG's integration. The main challenge faced with smart grid is the protection coordination. The protection systems, which were designed for classical power system, okay, like equipments, relays, fuses, and voltage transformers, circuit breakers, and the other stuff, they are not suitable for the smart grid. Actually, the protections are characterized with selectivity, speed, sensitivity, reliability, and directionality. So there is a need to modify this protection technique. So to justify this one, we just studied a practical power plant. I personally involved in the design of this power plant. It is available in Antalya, 12 megawatt. It is connected to the distribution network. This is the DC interconnection, the DC circuit of the power plant, and it's connected to the distribution network at 30 kilovolt and to the utility further.
I'm sorry to disturb you, sorry to interrupt, but probably you are not sharing the correct window. If you are sharing the presentation window or the editor window, that makes a difference. So please make sure that we can see your presentation. We are still on the first slide. So if you are going forward in your presentation, then please reshare the different window.
Okay, can you see the changes now, please?
I can still see the first slide in the editing mode. So probably you should stop sharing and share the correct window once again. Yes, now it's there. Thank you.
So I don't repeat the previous one, and I just continue from where I stopped to save the time. So this is the Antalya solar power plant, which we used to take as a reference to study the distributed generations integrations to the distribution network. So basically, this is connected to 33 kilovolt to the distribution network. These are the data for the DC and AC circuits of the power plant. Totally, you have 12 megawatt, and I personally involved in the design of the solar power plant. So we tried to investigate how the integration of this DG affect the protection of the distribution network, as well as the solar power plant when the already available protection techniques are used. So here, as you can see from this diagram, we applied a fault at a bus, which is nearer to 1 megawatt solar power plant. This is aggregated model. We use Dick Silent Power Factory to do so. So in this case, the fault current coming from the grid side is like 1.436 kilo ampere. And the other fault current is fed from the nearby distributed generation. So what happened in this case is actually the fault is identified by protection relay R3. And since the relay R2 is non-directional, still the fault current is sensed, and this relay R2 is operated wrongly, because the original setting of this relay R2 is 20.17 ampere. So it's set to pick up value of 1.2 times the rated value. So there is a wrong operation of R2. So similar challenges happened when distributed generations are integrated into the grid. So there are also so many challenges reported in literature. So this is for a particular example. And another thing we observed in the same solar power plant is we tried to observe the fault current variation trends. In traditional power grid, the fault current increase when we go to the source side. Mostly the source is central power plant far away from the load. So there was a radial increase in fault current. But in case of integration of DGs, this is violated. As you can see in these two curves, we don't have only one directional increase of the current, we have two directional fault current, as you observe here. When you go to the solar power plant side, we have fault current still, which is also opposite to the traditional power grid. Even when we go to the network side, still there is increase, but the increase is not, it's not continuous. You know, you can see here some decrease. So this imposes a great challenge on traditional power protection. So we proposed adaptive way of protecting the grid. So adaptation is actually a natural process which is used by human beings as well as even by animals. So in this case, what happened basically in adaptive protection is operational parameters of protected systems are continuously monitored. So central or distributed units can be used. But this happened by analyzing actually the circuit breaker's status or whether the DGs are integrated or not, as we used in our case. Then a new protection settings are calculated based on this online and offline analysis. Okay. Then by using efficient communication, which is actually assumed to be the part of the future smart grid, these new settings are distributed to the protection relays. So this is the technique we propose, even though there are so many techniques proposed in similar aspect by using adaptive. So here we use to monitor the status of circuit breakers as well as the circuit breakers which are used to connect the distributed generations. If there is any status change recognized, so the other setting calculations are followed. So this is a particular example. For example, we have condition A, condition B, condition C. From condition A to condition B, there is no any status change of circuit breakers, but from B to C, there is a status change. By using XOR logic, it can be easily recognized this status change. Then the other process will continue. So what we do is we calculate the short circuit and loading current, and we assign operating time multiplier setting of the relays at critical point. Then what we do is we calculate a new setting. Actually, in our proposed method, what makes it original is we don't need to devise a new device. Actually, we can use originally available intelligent in the device protection relays with minor modification on the computational capacity of those relays. Then we just do this one. We just initialize the setting for some particular relays, and these relays will communicate with other relays in their coordination order. So the architecture used is like hybrid between some central and distributed protection techniques. So we used actually the previously available well-known technique like IEC2553 normal inverse curve, and it's also possible to use the same method for a definite invert time or other curves also, or for short circuit protections. So if I continue to the next thing, so this is the architecture we use. We have central controller, or it can be also used one distributed controller can be used, one of the relays can be used to handle this activity. This is a green broken line. They access the circuit breaker statuses and they recognize the status change. So some agents are used to calculate these statuses based on the previous example I showed you in the table. Then what will happen after we calculate the short circuit current and load flow at every place in the network? So these values are distributed to some peripheral relays. So these relays will have computational capacity. They will calculate their own setting, and they will send the time and time multiplier settings of their own to the next relay in their coordination order, so that they can calculate also their own protection setting. So this can be also realized by using IEC 61815 protocol, which is very common in substation and currently in all energy, to communicate between different devices very fast. And in addition to that technique, to make our protection very fast, we added a follow me technique because the coordination happens in two directions. The relays in one branch will be coordinated with the same order of the relays in the same branch. So what will happen to protect one particular branch? The relay on the left side and on the right side, that means on the two ends, may have different time settings. So the relay with faster time setting, or the relay which recognizes the fault current earlier, has to send to the corresponding relay protecting the same branch, so that they can operate faster than intended time. So there's also this great advantage of the method we proposed. Then we simulated this technique by using Dig Silent Power Factory. We programmed the agent techniques and the algorithms to calculate the fault current, load flow, as well as to recognize the network condition by using DPL, Dig Silent Programming Language, advantages in that aspect using Dig Silent Power Factory. So we checked whether this system or whether this technique works well. So we have observed that the time multiplier setting and operation times of the relays changing properly with each variation of solar power plant. We just initially integrated 4 megawatt, and we increased by 1 megawatt to 15 megawatt. So at each stage, we have observed the relay setting are properly changed. And at one particular instant, we have seen the coordination curve among the relays. So they are properly coordinated. The curves are not overlapping with each other, so they are working properly. This is also for the other pass. There are four curves, as you can see. There is blue curve and green, red, and purple curves. For each pass, we simulated the fault current. I'm rushing maybe to conserve the time. Maybe it can be discussed later on. This is also for the other pass. The protection relays are observed to work properly without any overlapping of the curves. And we observed that the relay settings are changing properly for each integration of the digits. And we checked there is no wrong operation. For example, if we see setting one is designed for when there is only 3 megawatt integration. So there is no wrong operation when there is 3 megawatt, but if there is 4 megawatt of integration, if the setting is not changed to the second level, if we use the same setting number 1, so the relay will operate, this particular relay, RAD01 on our previous curve, will operate wrongly after 16.45 seconds. For further integration, if we increase further the digits, if the megawatt increased, even the protection relay will increase faster, but there is no actually fault current in the network. Similarly, if we see another condition, just to make it very clear, setting number 5 works properly, okay, until 8 megawatt is integrated. But if above 8 megawatt, this will trip wrongly. But setting number 5 cannot be used instead of setting number 4 because it can be oversized. There is a fault current and the fault current cannot be recognized. So by doing so, we verified our protection setting. And when I come to the conclusion, there is a great variation of fault current along the network due to the digits integration. This calls for new protection philosophy, which adapt to the fault current on condition of the network. The proposed method can vary with megawatt variation of the digits, and also if there is any configuration change can also adapt itself. It is adaptive and currently used intelligent electronic device, i.e. this can be used also with minor computational variation. To speed up the operation of the relays, we use follow me technique so that the faster relay or the relay which recognizes the fault current earlier can send a signal to the corresponding relay and they can operate together to isolate the fault. So we use DPL, Dick Silent Programming Language, as well as Dick Silent Power Factory to simulate our network. So the coordination between the relays is verified in this aspect. As a future work, we are intending to change this one to the laboratory test by using hardware in the loop. And also, finally, to the site, we are planning to implement this one. Thank you for attending my presentation. And if you have any question, you are welcome.
Thank you very much. For the moment, I suggest not to go ahead with questions because we are not adhering to the time schedule. So I prefer to accumulate the possible questions to the end. For example, I also have a question concerning the communication techniques that you use or propose to use in your scheme. But for the moment, I'd like to thank you for your presentation and pass the word to the second presenter. So please now stop your sharing of your screen. And we will thank you. We will get the second one from the University of Shanghai, which is titled Evaluation of Wind Energy Accommodation based on two-stage robust optimization. Please, are you ready to share your screen? Yes, Mr. Tian. Please unmute your microphone and share your presentation. Yes. Okay, now we can see our desktop. But still we can't hear you, at least I can't. There can be something wrong with the microphone, although it is unmuted.
Ladies and gentlemen, it's an honor to have the opportunity to address such distinguished audience. I'm Kunpeng Tian. Today, I will briefly introduce my research evolution of wind energy accommodation based on two-stage robust optimization, and my supervisor is Professor Sun. This slide is about the outline of my presentation. There are totally 6 parts. The concept of power system dispatch ability is described in section 2. The evaluation framework of wind energy accommodation is proposed in section 3. The solution methodologies are present in section 4. Numerical studies are conducted and simulation results are analyzed in section 5. Finally, conclusions are summarized in section 6. Background and motivation are given in this slide. Due to the external and internal driving factors, large-scale renewable energy is integrated into power system. The high penetration of renewable energy has become the development trend and important feature of the modern energy system. Renewable energy is a pivotal part in the electric power industry. The production of wind power depends on the environment, which brings challenge to the economic dispatch of power system. For example, wind energy spillage and load shedding are widely concerned. The evaluation of wind energy accommodation can serve the economic dispatch, which is very important for the safe operation of power system. In this slide, based on the theory of pre-dispatch and redispatch, the concept of system dispatch ability is proposed. We take a simple system, include 2 generators as an example to illustrate the process of power system pre-dispatch and redispatch as follows in figure 1. The coordinator axis represents the power production of the generator. Rectangle H indicates the feasible region of the production power of 2 generators. PLP and PLR are their hand and real-time load demand. respective. Then LP and LR are the day-hand and real-time dispersion scheme, which are given in equations 1 and 2. The pre-dispersion scheme needs to concrete because the information of day-hand has prediction error. From the perspective of ramping, the relationship between of pre-dispersion scheme and redispersion is shown in equations 3 and 4. The shadow rectangle S represents the ramping capacity, which is the power system dispersibility, and indicates the range of deviation from the predetermined operation point. The error of S is related to the pre-dispersion scheme, the ramping ability, and the response time. This manuscript proposes the evaluation framework and the metric indicates for window accommodation. The evaluation method is divided into processes. First, the pre-dispersion scheme is obtained by surveying the SCUC problem, and which is defined as the initial operation states of the electrical power system. The classical SCCUC problem is simplified as equation 5 and 9, where equation 5 represents minimizing the start up and shutdown cost and the fail cost of TG. The binary variable X include the unit commitment, start up state and the shutdown state of TG. The decision variable Y indicates the dispersion session, such as generator production power, transmission line power, phase angle. Equation 6 represents the minimum on-off time limits and the logical constraints of the start shutdown actions. Equation 7 represents the constraints of injection power balance, line transpower, and the phase angle of each bus. Equation 8 represents the constraint contain binary and continuous variable, including production power constraints and ramping constraints. Equation 9 represents the window power production constraints. Note that equation 5 and 9 are classical mixed integer linear programming, which can be directly processed by CPLX solver. Based on the day-hand scheme, the largest deviation of window power is calculated. The available band of window energy accommodation is obtained by surveying a two-stage robust optimization problem. The detailed evaluation model is given in 3B. The first stage is to determine the upper and lower bound of window envelope. The second stage is to determine the optimal redispersion scheme under the worst case window power realization. For any window power realization in the envelope band, window energy supply and load shedding should meet the constraints. Note that the model is a non-standard two-stage robust optimization problem because the uncertain set is the decision variable of the first stage instead of the predetermined boundary. Therefore, we need to decompose the uncertain set and the decision variable by equation 21 and the continuous variable V. V represents the ratio of the actual window power output to the largest operation range, and V is predetermined the uncertain set. The optimization aims to seek the bound of the envelope band such that there always find a practicable concretive action satisfying the constraints of window supply and load shedding. When any predetermined uncertain variable V, the standard two-stage robust optimization problem can be solved by Bender's algorithm. Meanwhile, we also notice that the super rare performance of CCG algorithm. This section looks at the methodology of two-stage robust optimization model. For the first stage decision is predetermined. The second stage decision is recast as MILP by strong duality theory and disjunctive inequality. Specifically, the B-level optimization of the inner layer is transformed into a single layer optimization through the strong duality. However, the bilinear term in single layer optimization is transformed into MLP by disjunctive inequality. In summary, the three-level robust optimization is rewritten as a B-level optimization problem. The master problem determines the bound of the envelope bound of the sub-problem determines the worst case of window power realization. The envelope of window power accommodation can be abandoned by Bender's algorithm in utterly solve the master problem and the sub-problem. The outline of Bender's decomposition algorithm is given in figure 2. A numerical example based on the modified IEEE 39 bus test the system are analyzed. The modified system contains 14 6 line and 10 generator, and the topology of system is given in figure 3. Detail the modified system contains a detailed parameter setting can be found in manuscript. The window farmer are integrated into the modified test at the nodes 3, 10, 15, 20, and 26. Respective, the window farmer power production and the load demand profile are given in figure 4. The simulation program written by Yamipu and Cyclic was run in MATLAB, and the average time of each calculation is about 300 seconds. The figure 5 and the figure 6 give a good insight into the ramping and the operation state of the thermal generator. The data in the figure 5 shows that the TG has stop and shut down actions, in which the expensive generator is shut down to reduce the production cost of the power system. All TG are involved in the daily dispatch. The TG located on node 13, 13.3, 13.4, and 13.5 are always in the turn on state, and another generator has stop and shut down action. The thermal generator needs to provide upward ramping capacity to avoid load shedding. Besides, the thermal generator needs to provide downward ramping capacity to avoid window spillage. The result on this slide verify the fact window spillage and load shedding on the envelope bound. We design 4 cases according to the window spillage and the load shedding. Case 1 is the most conservative. Case 2 is load shedding only. Case 3 is window spillage only. Case 4 is the most radical. The result of window power. The previous slide shows the envelope of window power. This slide details the result of case 4 in figure 9, in figure 8. Furthermore, the early window leakage or load shedding in case 4 in figure 9. As shown in figure 9, the total amount of window spillage and the load shedding, only window spillage and the load shedding in case 4. Finally, we can get some conclusion. It is feasible to counterweight the deviation of window power by correcting the pre-dispersion scheme, allowing certain window spillage or load shedding can greater improve the ability to greater cope with window power deviation. The envelope band of window power accommodation represent the maximum range of window power deviation for system, which can provide worrying information for decision maker. Finally, thank you for listening.
Thank you also. As we are still slightly behind the schedule, I'd like to say just thank you for the moment, and we will see at the end of the session if there is some time left for the discussion. So please, gentlemen, record your possible questions and notes that you may have for this very presentation. And I'm going to pass the word right on to the third presenter from the University of Konya, Turkey. Please, it's about second order fast terminal sliding mode control for MPPT or PMSCG based wind energy conversion systems. So we're still remaining with the wind turbines. And please, if you are ready, I'd like Mr. Tian to stop sharing of his screen and mute the microphone and pass the floor to the next presenter.
Can you hear me?
Yes, we can.
I don't share screen.
Okay.
Sorry, it is okay. Hi, everyone. My name is Emre Hasan Dursun. I am from Turkey. I am a research assistant and PhD candidate at Konya Technical University in Konya, Turkey. I will talk about improvement of efficiency for WEGs. My presentation topic is second order fast terminal sliding mode control for MPPT of PMCG based wind energy conversion system. Content of presentation consists of 5 parts. The first one is abstract and introduction. The second one is PMCG based WEGs configuration. The later one is proposed MPPT controller, includes 2 parts, MPPT methods and controller designs. Other one is simulation studies and validations, includes 2 different wind speed scenario, and last one, conclusion of this paper. Abstract. This study proposed a new MPPT controller based on voltage mode second order fast terminal sliding mode control to obtain better performance in the power extraction from WEGs. The major objective of this paper is the design of the second order fast terminal sliding mode controller. This proposed method can ensure the operation of the systems with higher efficiency and less steady state errors and voltage fluctuations. In this study, maximum power references are determined by mechanical sensorless MPPT methods, and WEGs configuration consists of wind turbine, PMCG, uncontrolled rectifier, boost converter, and MPPT controller. Proposed method has not been performed before as a voltage regulator in such this topology. For validation, the proposed controller has been validated for 2 different wind speed test scenario in MATLAB Simulink environment. Also, conventional sliding mode controller is created for comparison, and this controller performance is compared in the some criteria which are output power, MPPT efficiency, output voltage fluctuation, voltage error, and different performance indices. According to obtained results, the proposed method based MPPT controller achieves superior performance. Wind energy is special topics due to some reasons, because the world population is increasing day by day, and after that, technological developments constantly boost the country's energy demand. Conventional fuels-based energy generation raises serious concerns such as lack of research and global warming. In this point, renewable energy source is to be an effective solution for these problems. Therefore, the share of renewable energy source has been gaining momentum in recent years, especially in the last 10 years. Among them, renewable energies. One of the renewable energies, wind energy, is a clean and endless energy source. Has one of the best application potential in the marketplace. Wind energy conversion system. In commercial application, the wind energy is called as wind energy conversion system, and so wakes are divided into two types because of constant speed and variable speed operation. And this one fixed speed wakes is generally cheaper and simpler design. On the other hand, variable speed wakes has been more preferred from small scale to large scale, and higher power capture potential is also acquired by MPPT, different MPPT algorithms in these systems. In the various WEX configuration, various generators are employed. However, two types generators are usually in this industry, wind energy industry. These are double effect induction generators and permanent magnet synchronous generators. However, PMCGs have undergone significant development recently, so they have been preferred recently due to some advantages. These consist of efficiency, high power density, direct drive operation, gearless operation, simpler structure. So we use it in here. In industrial applications and research studies, various power conversion topologies are encountered. However, small and medium-sized applications are evaluated in terms of efficiency and cost. So we preferred following topologies in this study. In the according to wind energy, wind speed, considering wind speed is in a time varying form and includes high nonlinearity. For illustrating a view of the wind speed characteristic change can be these figures. For this reason, effective MPPT control schemas are required. These control schemas include MPPT search methods and controller designs. Controller designs will bring the generator to optimum operation point by switching the power converter. In the control of the wakes, different methods have been used in literature. These methods are linear, intelligent, and nonlinear control methods. Linear control methods fail to provide sufficient performance, generally. On the other hand, intelligent control methods have some disadvantages, such as learning time, processing load, and prior knowledge requirement. And other side, wind nature and wakes structure are nonlinear. So therefore, successful MPPT performance can be achieved by using the nonlinear methods. Sliding mode controller is a control technique, is a robust nonlinear control scheme and exhibits low sensitivity to disturbing effects and parametric changes. There are different types CMC in the literature. Conventional sliding mode controller, modified CMC, PID CMC, integral CMC, terminal CMC, fast terminal CMC. However, the other side, second order plus fast terminal sliding mode is combined technique, which is used in this paper. The authors this proposed methods as a voltage regulator for generating the control signal to bring the system to optimal value determined by MPPT. Thus, proposed methods has a better tracking performance and faster convergence. The designed wind energy conversion system configuration is shown as in here. wind turbine. This is the wind turbine, PMCG generator, uncontrolled rectifier, boost converter, and Lloyd. Wind turbine is the mechanical part, the other side electrical part. PMCG generator is direct drive and directly connected the wind turbine shaft, and PMCG's output transferred to uncontrolled rectifier and the others. The captured mechanical power, when it's come to wind turbine characteristics, dynamics, the captured mechanical power equation can be seen as, and rho is air density, A is swept area, GP turbine coefficient, power coefficient, and wind speed. On the other hand, GP is the nonlinear function based on lambda and beta and some constant coefficient. After that, lambda is calculated with this equation, and radius, bleed radius, and omega m represents rotational speed of generator turbine shaft. From here, maximum mechanical power equation is defined as in here. PM maximum depends on Kp optimal and omega's cubes. During the operation, if MPPT is evaluated on the Lloyd side, namely for maximum electrical power consumption on the Lloyd, more accurate and effective results can be obtained rather than mechanical sides. The electrical power equation on the Lloyd is in here, given in here, and the other side, induces back EMF of PMCG is defined as in here. One phase voltage equation of PMCG is defined, given in here, and given in here. And when mentioned, all over equations are ranging the output voltage of the rectifier is obtained as in here. As can be seen here, when the convergence at low power is ignored, linearity between DC voltage and omega m can be written as in here. Numerous researchers have been reported many different MPPT algorithms. For example, these different times is given in here, and they have, nonetheless, they have some advantages and disadvantages against the different methods. And after some mathematical inference and replacements, PL marks maximum on Lloyd electrical power is based on KR optimal and DC voltage cubes. By the way, KR optimal can be acquired from simulation tests. Block diagram of proposed method-based MPPT controller for WEX is demonstrated in figure 2. The first one in here, second order fast terminal sliding mode consists of several design parts. The linear sliding surface design and the later fast terminal sliding mode controller manifold is created by in here. Others include some parametric coefficients and state equations. In this way, second order fast terminal controller, sliding mode controller generates control signal and it's transferred to WEX systems. Controller design steps. For these steps, the firstly dynamic of BC are obtained as in here, and boost converter circuit schema is given in here. The system variables to be controlled can be defined as in here. And then in the controller design, the first steps, linear sliding surface is designed as in given in here. Then it is modified surface in here, given in here. Later, fast terminal sliding node manifold is designed with second order concept, and in this way convergence of the ST is guaranteed in finite time and reduced chattering. Thereafter, some replacing the state equations, it is synthesized as below, and from here U control signal is arranged as the final equation for controlling to wind energy conservation system. Simulation studies and validations for obtaining maximum power from PMCG based WEGs and the performance of the voltage mode, second order sliding mode controller and conventional sliding mode control structure designed as a voltage regulator is tested and compared. Specific data for both PMCG and BC are given in here in this study. Test scenario one, for the test scenario one, wind speed profile is formed, wind speed profile having 6 and 12 meter per second range is formed as in figure 3. Change of the, also we can analyze this output extracted power which is shown in figure 4. It can be understood that a higher power extraction is obtained with less fluctuation and closer taking to optimal power. And then the change of boost converter output voltage transfer to load is indicated in figure 5. By the way, the other special graphics is the change of the boost converter output voltage error, namely on the load, which is presented in here figure, as can be seen, figure 6. As can be indicated in here, we can say that proposed method is closer to 0. It is desired. Obtained power data for each wind speed in this scenario are listed in table 2. The obtained, according to this table, it's clearly seen that proposed controller ensure a higher power and efficiency the other methods, and also efficiency up to 99.85. The other side, later one, voltage ripples and steady state errors are given in table 3, and we can infer from this table that they have been decreased by using proposed methods. It is desired. Another comparison in terms of performance indices, EIA, ECA, ETA, are given in table 4. Both data indicates the lowest value of the for other tables. Realistic scenario.
I'm really sorry, but I have to interrupt you at this moment because the time is pretty over and we also have to pass the floor to the remaining presenters. So really sorry for this. I have to cut it off because I simply expected you were coming to conclusions, but there's no time for this. So sorry, perhaps we'll have time to finalize this at the end. But now I have to pass the floor to Mr. Dobrutsky from Žilina University of Technology. He's waiting for his input. So please, the floor is yours now. And please share the presentation with us. Yes, now we can see the editing window. I suggest sharing the presentation window instead Yes, that's it. Thank you very much. And now the sound, please unmute your microphone. You're still muted. Still you are muted.
I hear.
Yeah, now it's okay. Thank you very much. Your floor is yours.
Thank you, Chairman. My name is Branislav Dobrutsky. I am from University of Žilina, Slovak Republic. Our paper deals with simulation results and comparison of direct and indirect controlled matrix converter supplying 5-phase induction motor at first. Secondly, and mainly deals with experimentation of indirect controlled matrix converter supplying 5-phase resistive inductive load. The output phases of the converter load are connected in star, pentagon, or pentacle configuration similar to induction motor phase windings. The article follows my previous contribution to improving the efficiency of the hybrid electric vehicles. The worked out results are compared through the output power performances of the individual configuration of the load phases. So this is the topics of my presentation. Is as usual introduction, basic connection of matrix converters, direct and indirect matrix converter simulation result, and then experimental verification with passive RL load, and the output power circumstances in all three types of the load connections, and conclusion. So the first slide, you can see the connection of 5-phase, 3 to 5-phase matrix converter. This matrix scheme, this is the circuit scheme with the input in output, the synchronous generator and induction motor here. As a bidirectional switch are used, the blocking IGBT here. There are three types of winding connection of induction motor. At first, the star connection, pentagonal connection, and pentacle connection. You can see on this figure the star connection here, the pentagon connection here, dashed line, and the full line is the pentacle connection. So our load is also in this connection. The scheme for indirect controlled matrix converter is shown on these slides. So this is the first is the synchronous generator and fictitious DC link, not really fictitious DC link, and from DC link is this part of matrix converter indirect controlled to the induction motor or 5-phase inductive load. This is the simulation result for direct controlled matrix converter induction motor simulation. So you can see the star connection and pentacle connection. It's necessary to note that in the pentacle connection, the output voltage is approximately 2 times bigger than the in-star connection. It's important for our next explanation. Indirect controlled matrix converter with induction motor simulation results here. So this is similar to the previous one, star connection. This voltage, the red one is current, of course, and the voltage is blue one, but the first harmonic is sinusoidal, but started from zero. The current is shifted by the cosine phi of this. Pentacle connection, the voltage is in this connection is also nearly 2 times bigger than in star connection. And this is some theory how to control it, indirect controlled matrix converter. This is direct controlled, and this is derivation from indirect controlled matrix converter. Output voltages and voltages in fictitious DC link here is written. So the input currents can be calculated from these equations, and the voltages in alpha beta systems are calculated from this equation. So now I show you the experimental result from matrix converter supplying active and passive phase, 5-phase load system. So this is show the fictitious DC link. So it's not DC actually, but it's the like this. It looks like this. And now we can see the first star connection of the load. You can see the star connection here actually, and this is the result, measured result, and this is simulation result. So you can compare this is good in comparing. Now this is the pentagon connection. So you can see the current and voltages. This is on this figure is the current, blue one, and violet is the current in the phase, and blue one is the current in the winding. So this is the voltage, yes, voltage on the winding. So this is simulation. This is an experimental validation, and so this is the similar figures, but the output load is connected in the pentacle connection. So the output current and output voltages are the nearly twice bigger than in star connection. It's just is in model, so this is just 50 volts maximum use. This laboratory model, not really, because I'm sorry, we haven't so far the five-phase motor, so we are our research is only for the resistive inductive load in this. This measurement of first harmonic, the first harmonic, the value is here. So this is first harmonic of the voltage, and this is derivation of the pentacle voltages between terminal A and C is the nearly twice bigger than voltages between 0 B and B and 0. This is derivation. So exactly it is 1.9 times bigger, the pentacle voltages. This is comparison between star, pentagon, and pentacle connection. This current, first harmonic of the current, first harmonic of the voltages, and this first harmonic of the active power here. And total active power, you can see that in pentacle connection we get the 7 much more bigger than the in star connection. So conclusion, direct and indirect matrix converter supply in 5-phase systems has been shown under active and passive RL load. Indirect control supply was experimentally verified. The result of simulation and verification are in good agree. So this is the description of the. It was the star pentagon and pentacle connection in great detail in previous figure. In case of use of the 5-phase motoric load, its advantages will even greater due to independent control of the two induction motors by one converter, and the event of the single phase failure, still 80% of the performance remains for the driving. We have want to use for the hybrid electric vehicles. So for the driving is 80%. So it's all of my presentation. Thank you.
Thank you also very much also for adhering to the schedule. Still, we are behind it slightly, so I apologize, gentlemen, but there's currently no time for questions, and I'm going to pass the word directly to the next presenter, who is Mr. Muhammad Arif from Islamabad, Pakistan, and the title of his presentation shall be Single Conversion Stage 3-port high-gain converter for photovoltaic integration with DC microgrid. So are you ready, please, or is he here? Or I could see that he had some technical difficulties connecting to the room because I've admitted him for a couple of times, and I'm not sure if he's currently present or not. But he is surely here somewhere, perhaps not currently with us. Okay.
Okay.
So in such case, if you don't mind, I will dare to switch the order of the presentations. And since the sixth presenter is still not here, as announced, I will invite Mr. Dokur from Bilecik University in Turkey to be the next one if he is ready for the presentation. May I ask you, please?
Yes, I am
Thank you
ready,
very much.
Professor. Can
Thank
you hear me?
Yes, we can hear you.
Okay.
And yes, now it seems very well. We can see your desktop now.
Okay.
Yes, we can see the presentation. Very well. Please go ahead.
Okay. Hello, everyone. My name is Emrah Dokur. I am an assistant professor at Electrical Electronics Engineering, Bilecik University, and also head of Energy Technology Application and Research Center, Bilecik University in Turkey. I'm going to talk about the swarm decomposition technique based hybrid model for very short-term solar PV power generation forecast. My outline have main framework, and I will give a shortly introduction, and I'm going to talk about the swarm decomposition technique and hybrid model results. Finally, I will talk the conclusion and discussion. My main work, my abstract is accurate predictions of solar photovoltaic power generation at different time horizon are essential for reliable operation of energy management systems. The output power of PV power plant is depending on nonlinear and intermediate environmental factors such as solar irradiance, wind speed, humidity, and etc. Intermittency and randomness of solar PV power affects precision of estimation. To address this challenge, in this paper, in this project, has studied a swarm decomposition technique based hybrid model as a novel approach for very short-term solar PV power generation forecast. The original contribution of the study is to investigate use of swarm decomposition technique for solar data forecast. The solar PV power generation data with hourly resolution obtained from the field, where is located in Turkey, solar power PV power plant, is used to develop and validate the forecast. As you've seen in the figure, the flow chart of the study, I will give a detail about the flow chart in the other slides. Rising energy demand and its related environmental impact increase the use of the renewable energy resources in generation rapidly. PV panels have recently become one of the fastest growing renewable power generation techniques. As you know, the renewable energy resources are nonlinear structure and highly depending on geographical locations and weather conditions. So integration of the large-scale photovoltaic power system into interconnected systems is becoming a major challenge. So the solar and also wind power forecasting is important for the power systems. The generation schedule should be planned for very short-term and long-term power system operation in order to ensure reliable operation and economic dispatch of modern power system. The researchers have proposed lots of methods with various time horizon for modeling and forecasting of PV power, such as artificial intelligence technique, deep learning, hybrid models. Today I am going to hybrid models especially, and as you've seen in the figure, the forecasting horizon and related application in this figure. Swarm decomposition technique, a novel signal analysis called the swarm decomposition technique has been proposed by Apostolidis and Hagiotolidis. Swarm decomposition based on the biological swarm rules is a preprocessing method for non-stationary signal. The most important step of the swarm decomposition is swarm filtering that operates with the swarm prey hunting approach and also produce escalatory components from an element input data. As you've seen in the presentation, the pseudocode given in this section, there are lots of parameters in this technique, such as input signal, swarm hunting parameters, and members, control flexibility of swarm, and threshold and output of swarm filtering. As you've seen in the figure, and I am going to talk about especially, although this pre-processing method has been used for the decomposition of many biomedical signals normally and different non-stationary signal research, it has been applied to solar data for the first time in the study. In the study, the real solar data, power output data obtained from the solar power plant for the pre-processing and the composite sublayer by using the swarm decomposition. Real solar PV power output time series data of solar power plant were decomposed into 5 sub-series by CVD. Particularly high frequency component which have changed in solar power output during the Klutli periods have been detected in this sub-series. As you've seen in the figure, the solar data and reconstructed solar data after the pre-processing is given here, and time domain and frequency domain figures. And I am going to talk about the hybrid approach, and as you've seen in the figure, the figure shows the sample hourly power and energy outputs, the clear sky data, but I will use the cloudy and rainy periods. As you've seen in the figure, you can see the flow chart. The flow chart of the study is given in here. Firstly, the data was collected from the solar power plant and it is normalized before the pre-processing step. Sub-series of solar data were obtained using the swarm decomposition technique. For each sub-series, feed-forward neural network model was established and outputs were obtained. All separate forecasting result achieved by each sub-series models were collected to obtain the value of final estimation. I used the sliding window technique for the forecasting method. Also, the hybrid approach was run 10 times independently, and the performance results are evaluated, the performance metrics. As you see in the equation, some error metrics such as root mean square error, mean square error, were used to evaluate the forecasting performance of the proposed methods. Also, you see the sample results of the composite signal one forecasting and performance criteria of the study. The figure shows the decomposite signal one forecasting results and performance metrics in here statistically. Also, finally, I'm going to talk about the hybrid approach results. The performance of the proposed hybrid approach is higher in closely periods. According to performance metric results in here, in table, there is significant improvement in error measurement compared to other forecast model in selected closely case. In this project, a novel PV forecasting model based on the swarm decomposition and Pittsburgh NL network is given to forecast the power output of a PV system. The results were obtained by applying separate estimation model for all sub-series. The simulation results show that compared to other PV forecasting method without the processing approach, the proposed PV power forecasting model can significantly improve the forecasting performance in closely periods. Thank you for your attention.
Thank you also for being on time and for this interesting introduction. Perhaps now it seems that Mr. Arif is with us or not. I'm not sure. I will check. So should be here. So let us give the floor to him, and hopefully we will have some time for questions if the organizers will allow us to do so. So thank you for the moment, Mr. Dokur, and please, Mr. Arif, could you share your presentation? Which will be on single conversion stage, 3-port, high-gain converter for photovoltaic integration with DC microgrid. So we still are with wind turbines or solar systems. Please unmute your microphone and share the presentation. Now we should hear you. What we can hear actually is some noise in the background. Yes, the screen is becoming to be shared. Yeah, now we can see your PowerPoint editing window. So if you'd like to show us the presentation, it would be better to stop or like this. Okay. Yes, now we are sharing. We can see it. We can see the presentation window now. So please, the floor is yours.
Thank you, Chair. I am Mohammad Arif from Comsat University, Islamabad, Hyderabad campus. My presentation title is Single Conversion Stage 3-port High Gain Converter for PV Integration with DC Microgrid. Presentation outline is motivation, introduction, proposed topology. I will explain the proposed topology, operational modes, the mathematical modeling and design consideration, results and discussion, and at the end we will conclude our overall work. Motivation. The figure shows the future DC microgrid where as we know that the penetration of renewable energy increases day by day, and the significance of the DC microgrid increases, especially in the low voltage DC distribution and generation. With the increased penetration of renewable energy resources, especially the PV system increases day by day. But there are some issues with the PV system for the integration of with the integration to the DC microgrid. The first one is the low voltage generation, and the second is the intermittent nature of the PV system. But these issues can be overcome by using for the low voltage generation, we can use high voltage, high gain conversion system, high gain power converter. And for the intermittent nature of the PV system, we can use the storage devices. So for this, in recent times, the researchers has developed many converters uh, for this kind of system. But there are some issues that the researchers has the topologies which has more number of components or the multiple stages to convert that low voltage generated by the PV system to the high gain compatible with the DC bus system, which is the standard like 380 volt by using emerged lines, which is the standard DC bus voltage. With the with low voltage generation. So the battery port provides the stability to cope the intermittent nature of the PV system. So the researchers in recent time researchers has developed many converters, but those converters has the limitation of the high gain by using the more number of devices. Those converter has has multiple conversion stages, which increases the size of the converter, and also the decreases and also decreases the efficiency of the converter. So for this, our objective is to develop a converter that not only cope these limitations in the conventional PV integration system with the DC microgrid, but also to reduce the conversion stages and also the passive devices count in the design of the power converter. So our objective is to use the PV and battery system to integrate it with the DC microgrid. So for this, we introduce a 3-port converter where we have a PV system and a battery system integrated with the DC microgrid. So converter has the following features. It has a 3-port bidirectional power flow capability, a high gain storage capability, simple structure, almost ZVS, zero voltage switching is achieved without using extra circuitry. So the converter is based on the availability of the PV power and the battery charge and discharge. The operation of the converter is divided in SISO, which is the single input, single output mode, DISO, double input, single output mode, and the SIDO, single input, double output mode of operation. Here we have the proposed topology. This is the input port for the PV system. We have a battery port for the battery. We have a coupled inductor. The only for the high gain feature, along with the switch capacitor. We have active clamp circuit to reduce the voltage stress on the man switch, and we have low port. The operation, the converter has only single conversion stage. So the conversion topology in all of the modes, in SISO, DISO, and SIDO mode, some part of the circuit will active. For example, in SISO mode, this is the active circuit part and the current flow path, which will be active for the whole operation during the power transfer from PV to main DC bus. And also for the SISO mode, we have 3 mode of operation, like power transfer in single input, single output mode of operation from battery to the load, The figure 3b shows the current flow and the active part of the converter circuit. In figure 3, in buck mode, when the battery is charged from the DC link, is shown in figure 3c, and for the diasto mode of operation, the active circuit and current flow path of the circuit is shown in figure 3d, where both PV and battery provides power to the load. Keep in mind, the mode of operation is depend on the availability of the power from the PV and the charge and discharge of the battery, and also the nature of the load. Either it is a light load or a heavy load, and so on. So we can switch based on these conditions into different mode of operation. So the last mode of operation is the single input double output mode, where we have the only source, we have enough power at PV port to both charge and serve the load. So this circuit shows, figure 3e shows the active part of the circuit, which is used for the SIDO mode of operation, single input double output, where the only input is the PV port and the output is is the battery port and the DC link capacitor. So for this, we have developed a complete mathematical modeling and analysis is explained in the paper. We just write the key conversion, the conversion equation in each and every mode of operation. For SISO mode, we have 3 operations. When the power delivered from PV to the DC port, we have the conversion ratio of this, and we have the conversion ratio of this in 2 when the power is transferred from the battery to the main DC link, and in third mode of SISO operation, where we have the power transfer from DC link to charge the battery at the input side. So this is the buck operation, and other two are the boost operation. For the ISO mode of operation, we have these relationship, and also for the SIDO mode of operation, we have this one. So as we know that, as you see in the topology, we have only one magnetic element, which is for the main part of the circuit, which is the coupled inductor. So for the design consideration of each and every component is explained in detail in the article. But here I just show you the crisp of the coupled inductor design flow, where we have the design specification, and then based on the power output power, we select the core, and then we calculate the inductance, and then the loss calculation, wire and flux density calculations are done, and if it is true, then we calculate the bobbin fit calculations, and then we develop and test inductor. If it's not true, then we go back to this loop, and also in this loop. We design the switches according to our requirement. As we develop a 500 watt prototype, we choose the switches and the diodes accordingly. As we are using active clamp circuits, and some of the switches we are using with low voltage stress, and we are using the diodes, fast recovery and ultra fast diodes. We have the design criteria for the capacitor selection. We have 3 capacitors. One is used for the load capacitor, and we have a switch capacitor, and we have the active clamp capacitor. So these figure 5, 6, and 7 shows the results, simulation results modeled in Plex simulation results in SISO, DISO, and SIDO mode respectively. So these results are in close proximity with the theoretical analysis. Figure 8 shows the hardware prototype and laboratory photograph of our system. Here, this is the 500 watt hardware prototype of the converter. These are the MOSFETs. This is the control slot. We are using TMS F28379D. This is the inductor, this is the coupled inductor, and we have two ports. One is for the battery and other is the PV port, and we have the output port over here. And this is our experimental desk, which is the in our laboratory. So figure 9 shows the SISO mode of results in experimental results in SISO mode of operation. In this mode, the active switch is S1. So we have the input voltage of 48 volt at PV system for the validation of for the operational validation of the converter, and we have the duty cycle for that switch is 0.5, and we have voltage stress of 96 volt, and this shows there are some ripples and the VDS voltage. This is due to the leakage inductance of the coupled inductor, and we calculated it on the scope, and which is around means by calculating the resonant frequency of the these ripples, and then from there we calculate the leakage inductance. These are the experimental results in DISO mode, and the active switches are the S1 and S2, and the rest of the results are same because the main part of the converter is common in all mode of operation. But keep in mind the converter has only single conversion stage. So these are the experimental results in SIDO mode. So we have the active switch again S1 and S3, and again these results are in close relation with the simulation results as we shown previously. So at the end we compare our proposed converter with the state of the art converter in the literature in SISO mode of operation. As we know that we have comparison in terms of the reduced device count and in the high gain feature. So conventional boost converter has these parameters: switches, diodes, capacitors, inductors, and the converging gain. And the reference article in 13 has this conversion gain, and proposed converter has this one. Proposed converter has highest gain as compared to these converters, although reference 13 has minimum device count in terms as we are using the switch capacitor to elevate the voltage at the output of the converter, but the gain of this converter is low than the proposed converter. Figure 13 shows the gain comparison of the proposed converter with the state of the with the cited and the selected articles are the work presented in 13, 17, and conventional boost converter. So here we can see that the here we can see that the proposed converter and the reference the work presented in the article 17 are in as the duty cycle increases, the almost gain is same, but we can see the clear difference in the device count. The converter proposed in 17 and as we has proposed in this work. So this is the conclusion. In this work, we proposed a three-port converter which has the bi-directional power flow capability. The leakage inductance is achieved by using without using extra circuitry, and we are using the leakage inductance of the coupled inductor to achieve ZVS. Converter has an efficiency of 96% in SISO mode of operation. Comparatively with the paper cited in this article, the converter has less number of device count. We are using the active clamp and switch capacitor technique to elevate the voltage at the output side. And at the end, the converter is the operation of the converter is explained in SISO, DISO, and SIDO mode of operation. As we discussed, is single input, single output, double input, single output. and single input, double output mode of operation. Moreover, nowadays we are working on the control and the energy management between different ports of the converter is will be discussed in the future articles and maybe proposed in the future work of this research. Thank you very much for your time and attention.
Thank you also. Gentlemen, we are finished with all the presentations that have been represented today. And I just would like to ask the organizer if we have some time for discussion or questions and answers, because I have eliminated these during the course of the session because we were not sure about the adherence to the time schedule. So please, Darius, are we allowed to have some?
I think yes, you have. I think discussion is very welcome.
Thank you very much.
It's up to you to manage time, and maybe I just would like to thank you to all participants, to all presenters, virtual participants, because form of the conference is a bit different, but I'm really glad that almost all participants made their presentations, and I hope to meet you probably next time somewhere face to face. So please continue this discussion, and I will be somewhere around you. Thank you, Mr. Chairman.
Thank you very much. Also, I'd like to apologize once again the last presenters from the Institute of Fuzhou, China, because the paper titled "A Novel Pre-Synchronization Control for Grid Connection of Virtual Synchronous Generator" has not been presented, probably because of some personal reasons. So just to recap, we have had 6 presentations, and now I'd like to use my right to ask just 2 simple questions, which are focused on the first and on the third presentation. Perhaps the questions are a bit silly, but it is because of my primary area of interest. So I'd like to ask Mr. Chobole about your design, because you have mentioned that the communication uses some efficient communication means to send the warnings and information inside the design system. So could you please elaborate on this efficient communication? What technologies or what type of communication shall be used?
Okay, thank you for your question. It's an interesting question. First, I say that the communication infrastructure is one of the main important components of the smart grid, because you cannot realize smart grid without efficient communication infrastructure. Specifically, when we come to the substations, or maybe distribution substations, previously wired communication infrastructures were used. It can be copper wire. Later times, fiber optics were used. Now, due to the development of IEC 61815 protocol, this protocol can transmit data in real time over Ethernet. So the current devices, intelligent end devices, for example, the protection relays, they are implementing this protocol, IEC 61815 protocol. So it is easy to exchange data. For example, the circuit breaker status data can be represented in binary, and it can be sent over Ethernet. When we come to if you are asking about the architecture of the communication, since we use now this protocol, IEC 61815 protocol, we are not using the previous methods like master-slave. So the devices, they are configured initially which device will communicate with which one based on IEC 61815 protocol. So based on publish and subscribe method, for example, if they use GOOS methods, generic object-oriented communication, so they can communicate by using this protocol. So it is easy to implement my method by using this protocol. But in actual simulation verification, I just used dig silent programming language and the dig silent power factory. So there is no any requirement for me during the simulation to implement this communication. But in practical application, I will do that one. Thank you. If I answered your question.
Thank you very much. How about considering, for example, power line communication in order not to have to implement any extra network to the existing infrastructure in parallel? How about PLC?
It's an interesting question. Among the communication infrastructures, especially in substations, we need more reliable communication infrastructures. Even if we have access to power line carrier communications, we suggest in case of especially protection signals are very sensitive, very important signals. So we suggest to use fiber optic Ethernet even. We suggest to use fiber optic Ethernet because the power line carrier communication is very prone to noise signals. So the signals which are used for protection, they must be very accurate. So we don't suggest to use power line communication. Thank you.
Thank you very much. So, gentlemen, this was my question concerning the first presentation. Is there anyone else who would like to ask Mr. Schobel about anything concerning his results? Doesn't seem so. How about the second presentation? Thank you. Thank you. How about the second presentation given by the colleagues from the University of Shanghai? Any questions specifically? Well, doesn't seem so. As I've hinted a while before, I'd like to ask Mr. Dursun about, again, just a tiny detail. It's rather a note or just a bone note than a question, but you spoke about endless energy, which is represented by the wind. Well, can you imagine a situation when wind wouldn't be available? Or, you know what I mean? I'm just trying to hint about the situations, for example, in the coast of a seaside, when the situation is rapidly changing from hour to hour, and the wind either blows or not, and both situations can be a problem. So how about this consideration about the endless energy consisted by wind? What is your opinion about that, Mr. Dursun? Mr. Dursun, sorry. If you're still here. I can't see the colleague here. So sorry, we will have to skip this. And how about the rest of the presentations? So this was from Jelena, from Bilecik, and from Islamabad. Any specific questions or notes, colleagues, please? The floor is open. Well, Darius, do we have, please, some inputs from YouTube channel? Well, it doesn't seem so. So in such case, I'd like to say thank you once again to everyone who has participated actively in this session. Thank you the more that you have agreed to participate in this, let's say, substitutional form of presentation and conference in this difficult time for everyone. So let's hope that the situation around the globe will be more relaxed in a couple of weeks. And I also would like to wish you all the best, good health, and express my hope that we will have a chance to meet in person on some more pleasant occasion. Thank you very much. I'm officially concluding the session. Have a nice afternoon, or depending on your time zone. Thank you.
Thank you.
Thank you. Thank you.